this cold is going to have a half-life. All right. Good morning, everybody. I'm Brian Getz. This is Stuart Marks. We work on the Java platform at Oracle. And this talk is API design with Java 8 lambdas and streams. So this is a talk about the considerations for how to use the new language features that were added in Java 8 in your own APIs. API design may sound like a rarefied topic, but in reality, we're all API designers. Whenever we program, if we're programming well, we're separating components into layers, and we're building APIs between them. So the considerations that we use in designing APIs in the JDK may be useful to you in building your own programs, even if you're not building APIs that are published for other people's consumption. So we're going to talk a little bit about some lessons that we learned along the way in building the APIs that were added in Java 8, and hopefully those may be useful to you. Whenever a technology is new, it takes a while to figure out how to use it, right? So in the early days, in the Java 1.0 days, none of us knew how to build APIs for Java. And the book Effective Java that Josh Block did was essentially the lessons learned from building the collections library that was added to Java in 1.2. And it took us a while to figure out how to use the tools that Java gave us to build good APIs. And then when the language changed in 5 and we added generics, APIs that may have made sense in a less strongly typed world all of a sudden weren't exactly right. And it again took us a while to learn how to write good generic APIs. And when we added lambda expressions to the language in Java 8, the same thing happened. It's going to take a little bit of time to figure out how should APIs change. So APIs that might have been as good as they possibly could have been in Java 7, all of a sudden start to look a little stilted. When you have lambdas in the language and you look and you see things where, oh, we could have used a lambda there. So invariably, there's a rush to go update all the libraries. Sometimes we over-rotate. Takes a while to find the equilibrium. So that's essentially what this talk is about, we believe we found our equilibrium and sharing a few of the lessons learned. So we're going to talk about using the features in Java 8, the language feature, lambda expressions, as well as some of the library mechanisms that were added to the library in Java 8, streams and optional. And then we'll talk a little bit about about default methods and and good ways to use those in your APIs as well. So for questions, we're going to try to take all our questions through Twitter. So we have a hashtag Java API. It's on all the slides if you can't remember it. What we're going to do is we'll take a few questions between each section, and then we'll take the majority of questions at the end. So if you have questions, tweet them as they come to you, and we'll get to them. OK, so this first section is about designing APIs for use with lambda expressions. And I'm going to give a couple of examples from the JDK that illustrate some of the wrong turns we made and some of the discoveries we made. So to recap, a lambda expression is a compact way to express code as data. You have a little chunk of behavior, and you want to pass this into a library. And it's concise, which means that it is not painful to use. We've always been able to express code as data using inner classes, but they were clunky and people didn't want to use them. And so people didn't build APIs that required inner classes, even though they could have built a lot of the same APIs then. They just were too clunky to use, and so we didn't do that. Being able to pass around behavior as data means that you can write APIs that have a sort of more permeable boundary. You can say, do this for every element of a collection. Do this if an error happens. Do this after this event happens. And it allows the client to sort of pass more information into the API so the API can take over control and do more work on behalf of the client. So, for example, like in the regular expression API without lambdas, you have to have this interactive conversation of, give me the next match, now I'll do something with it. Give me the next match, now I'll do something with it. With lambdas, you have the ability to say, here's something to do when you get a match. Now go find all the matches and don't bother me until you're done. So this it tends to lead to not only more expressive code, but less error-prone code, because you're able to concisely say, here's what I want to do, and then get out of the way. So Like I said, the tool we had before was inner classes. That was clunky syntactically. It was clunky from a runtime perspective. You had to make a class. You had to make an instance of that. And it was one of those problems, one of those solutions that seemed clever at the time. When they were added in 1.1, they seemed like, wow, this is really, this is much better than what we had. But then, of course, you get used to it and you realize, gee, it's not as good as we'd like it to be. All right. So let me give you an example of an old API that we migrated to use new features in Java 8. So how many people here are familiar with thread local? OK, so the thread local stores the thread local value. And one of the things it lets you do is choose what the initial value for that is. And to do that, if you don't care, you get initial value of null. If you do care, you can subclass thread local and override the initial value method. This is called the template method pattern. And this works, but again, it's a little bit clunky that if you want to have a non-trivial default value, you have to subclass thread local. Which isn't terrible, but it's in some sense it's subclassing is a big hammer to use to solve such a simple problem. And then, once the first time someone calls threadlocal.get on a given thread, the thread local class calls the initial value method once, uses that to seed the value, and then gets out of the way. If we were designing thread local today and we had lambda expressions, we wouldn't do it this way. Now, we have thread local out there. We don't want to throw it away and rewrite it because it is useful. It's just not exactly the way we would write it today. But we were able to adapt it in such a way that new uses of thread local could use a more concise mechanism for initialization without throwing away the old way. So here's how it works. So the old way is you subclass thread local, you override the initial value method, and it returns an initial value on demand. What we did was we added a static factory method to thread local called withInitial. And the argument of withInitial is a lambda expression that, when invoked, returns the initial value. It does exactly the same thing. The client code is obviously a lot more compact. And it means that clients don't have to go and subclass this thing just to customize a little bit of behavior. If we were designing thread local, today, we would do something like pass that lambda to the constructor of thread local. Because we were retrofitting it, the sensible thing to do was create a factory and do it this way. So if you have existing classes that are using the template method pattern and you want to migrate them, you don't have to make an either-or choice. You can go and add additional constructors or add additional factory methods to those classes so that they can be initialized in a more convenient way. So there is a nice migration path. You don't have to throw away your old code. You can adapt it and gradually migrate your code base. And in fact, we haven't even migrated all the uses of thread local of the JDK to use this. We will eventually, but when it gets to the top of the priority list. All right, so let me give another example of evolving an API to be more Lambda friendly. So imagine you want to create a multi-map, which is to say a map where the values is a multi-valued set. So for example, all of the values associated with a certain key, you want to accumulate them into a list or an array or a set or what have you. Now, it's really easy to simulate this with a map. You can say map from some key type to a list of some value type. And when you want to insert an element into the into a map like this, what do you have to do? Well, first you have to check if the key is there. If it's not there, you have to make an empty list. You've got to put that in the map, and then you can add the new element to the map. Now, this isn't hard, right? But it turns out that it ends up being a little bit of boilerplate code that we repeat over and over and over again. So here's an example of this code in action. We have a map from key to list of value, and you want to add an element. So the first thing you do is say get the value or the list of value associated with that key. If it's null, create a new list. Stick that list in the map, and then either way, you add the new element to the list, whether it was the existing list or the old list. How many people here have written this code? How many people here have written this code more than once? How many people here have written this code more than 10 times? How many people are tired of writing this code? All right, I think I've made my point. OK, so what did we do about this? We added a method to map using default methods, because we can do that now, yay, called compute if absent. The behavior of compute if absent is to capture this little pattern of if the thing is present, then just return it. If it's not present, call this lambda that creates an initial value, stick it in the map, and return that. And what we get is the client who wants to add an element to a multi-map can now just call map.computeIfAbsent, pass a little factory lambda that just creates a new array list, and then whatever the result of that is, whether it's the existing list or the newly created list, add an element to it. Can everybody read the code at the bottom of the slide there? So the bottom code is certainly easier to read. It's less error prone. It's just much more obvious what's going on, right? And so we can capture this little pattern of boilerplate, add it as a default method to map, and then at some point later we can go back and update all the uses of all of this idiom to use the new, more compact idiom. So what's the benefit of this? In addition to reducing some boilerplate, you capture a pattern that you've effectively asked your clients to use over and over and over again. You've captured in a library. Well, that's what libraries are for, right? So that we don't have to rewrite the same code all the time, so that it can be centralized in a library. And then as a bonus, it means that subclasses can enhance the implementation of this method in a way that's consistent with whatever that subclass does. So we added this to map, and it does the straightforward thing. But then in the concurrent map implementations, like concurrent hash map or concurrent skip list map, they can be atomic as well. And so not only is it a notational convenience, meaning that the client code is more compact, but it also means that more of the semantics are the responsibility of the library, which is where you want it. All right. So switch topics a little bit. When we added lambda expressions, one of the obvious things that we wanted to do was add some methods for sorting to the collections, right? So there's an existing collections.sort method that sorts a list, and it'll either sort it by the natural order or by a comparator you pass in. And default methods allow us to add new methods, and lambdas allow us to pass around little snippets of behavior. So an obvious thing to do would be to have a sort by, where the lambda you pass to sort by extracts a key from whatever it is a list of, right? So I have a list of person. I pass in a lambda that takes a person and pulls out the person's last name, and then I could say sort by that little key extractor. And that seemed obvious, right? And so we're like, oh, great, we're going to add these sort by methods to list. So we started pulling on that string a little bit. And there were some obvious things like sort by a comparable key, sort by a non-comparable key, but here's a comparator. How about sort by an integral key? Well, that seems pretty reasonable too, and ... So there were like 4 or 5 of those. Well, what about sort in reverse order? Well, all right, well, let's multiply that list by 2. And what happens if we want to do a composed sort of first sort by last name, then sort by first name? Well, we could add methods for that too. And well, what about nulls? Nulls are always weird. We might want some special methods for dealing. You can sort of see where this is going, right? It's like, you could make the list of candidate sort methods that we might add. And hopefully, before you get to the end of this list, you realize, whoa, I took a wrong turn somewhere. I'd better back up and explore a different option. So we were pretty far down this road before we realized that things had gotten out of control. OK, so what was the mistake we made? The mistake we made was we were working at the wrong level of abstraction. We were working at the level of abstraction of list, whereas a much cleaner level of abstraction for sorting would be comparator, right? So instead, we decided, let's build some tools for making comparators, for modifying comparators, for composing comparators into other comparators, and that turned out to be a much more fruitful direction. So a comparator is a very simple function. It takes 2 elements, and it returns a negative value, 0, or a positive value, depending on whether the first one is less than, equal to, or greater than the second one. Now, how many people here have written comparators? How many people here have written too many comparators? All right, you get my point. It seems like there should be some ability to reuse the comparators we've already written, but we never do. Every time we have to write a new comparator, we end up just writing a new one because it's easier to just write the whole thing out than to build on an existing one. And that seems kind of a shame. And lambda expressions give us an opportunity to extract the little bits of a comparator that are relevant so that we can compose them. So as an example, you've got some domain object like student, and you want to make a comparator for compare students by last name. And here we've done it with lambda expressions instead of inner classes, which is a little bit more compact than the inner class version, but it's still not any more abstract than the inner class version. So we say, take the first one, get the last name, use its compare to method, compare it to the last name of the second one. And that's fine. And we can do the same thing for a primitive valued property. The structure is a little bit different, but it's pretty straightforward, right? Take the two scores and then call integer.compare. That's better than inner classes, but we want to do even better than this. Okay? So one aspect of commonality here is you're doing something twice. You're saying get last name, get last name. You're doing that twice. We should be able to extract that little bit of commonality so that the user doesn't have to repeat themselves. So what we did was we added some factory methods. These are static factories that take a lambda and return a comparator. So these are sometimes called higher order functions because they take a function and return a function. You don't have to be scared by the term higher order function. You're basically saying, take a little bit of behavior that does something simple and compose it into some behavior that does something more complicated. So the comparing method takes a lambda or a method reference that extracts a key from your domain object, and then it does the little extract the key from the first one, extract the key from the second one, compare them for you. So that's nice. That's an improvement. Let's see where that falls down and whether we can patch that. So what happens if one of those keys might be null? We don't want to call compare to because we'll get a null pointer exception. So we might want if we know that nulls might be part of the domain, have special handling that says, put all the nulls at the beginning. All the students whose name is null, put them at the beginning, or put them at the end, or do something with them, right? And we'd like to be able to specify that behavior once and not do it again. So we've got a little method here called, we have a lambda here that expresses that of here's how we would handle creating a comparator when one of them might be null. But this is kind of clunky. Right? We would like to be able, now we're back in the doing it all yourself, and that's not so great. Similarly, let's say you want to do a two-level sort, a dictionary sort. First sort by first name, then sort by age. Well, we can write this out by hand, and we all have, but we would like to be able to separate the pattern of do this ordering first, then do that ordering from all the details of actually calling the comparators. So the cool new methods we had of create a comparator to sort by last name start to fall apart when we have these more complicated sorting. And if you try to put these two together of sort by first name then by last name and one of them is null, the code is starting to get complicated again. So we can use lambda expressions to restore simplicity to this. So for example, supposing we create a method that takes a comparator and returns a comparator. The comparator that it takes is just comparing two non-null things and telling you what their order is. And then what this method does is deal with nulls. So this one is called nulls first. So it looks to see if the first argument is null, and if it is, it just says if the other guy's null, they're equal. Otherwise, the left one is less than the right one. And then it delegates to the comparator you passed in. So this is, again, a higher order function, takes some behavior in, produces some more complicated behavior out. And now the benefit of this is at the call site, we're able to express this idea of sort by first name with nulls at the front without all of that goop that we had 2 slides ago. So we're able to say, take the natural order for comparing, put the nulls first behavior to it, use getFirstName as our key extractor, and then the null-friendly comparator as the way of comparing keys, and then we say sort the list according to that. So that's nice. How about the 2-level sorting? Can we do the same thing for that? Well, turns out we can. So we write another one of these methods. We call these combinators. A combinator for comparator takes a comparator, returns a new comparator. So the comparator it takes is it's an instance method on a comparator, and it takes another comparator to be used if the 2 things are equal, right? So it says first ask me what I think of these 2 things, and then if they're equal, I'm going to delegate to the other comparator to do a finer degree comparison between the 2 of them. And then it just converts that into a comparator and returns that. And so if I want to compare 2 students by last name then first name, what I do is I use the factory method that I showed at the beginning to make a comparator for by last name, and then I use this combinator to say, and then turn it into a composed comparator with this other comparator to do the tie breaking. And what's the other comparator? It's based on getting the first name. So this is looking a lot better than the previous example. And just to sort of put it all in one place, the code at the top is the handwritten, even with lambdas, it's the handwritten, I want to do a 2-level sorting with nulls. The code at the bottom is the same thing, but all the boilerplate's been moved into the library. So this turned out to be pretty successful. Rather than adding 4,000 sort methods to list, we added like 7 or 8 methods that make comparators. We added some static factories, make a comparator given a key extractor. We added some combinators, take this comparator and modify its behavior. Inject null handling behavior, compose 2 comparators with each other. There's a default method for reverse a comparator where you say comparator.reverse. And all it does is take its compare method and flip the sign around. So what would have been a large number of methods in list and also in other sortable things turn into a much smaller number of methods on comparator. And also, it's an awful lot easier to test these 7 new comparator making methods. Well, first of all, they're so simple that you can look at them and tell that they're right. But it's a lot easier to test these simple methods than to test 4,000 sorting methods. So the lesson here is, sometimes you see this combinatorial explosion of complexity, and sometimes that's essential to your domain, but very often it's a sign that you're dealing with something at the wrong level of abstraction. You're trying to get the list to handle something that is maybe better expressed at the level of comparator. So this may manifest itself as lots of overloads of something. It may manifest itself as big complicated parameter lists with like 19 different options. And this is often a hint that you can maybe push the problem to a different layer and solve it that way. Break it down into smaller features that are more amenable to composition. And the result we got with comparators was really nice, right? The implementation of each of those methods was trivial. It was obviously correct by inspection, and there were only a few of them because the combinators like nulls first and then comparing and reversed compose very nicely on the base cases created by the static factories. So I think this is sort of a good point to take a couple questions. Have we got some good questions from Twitter?
Yes, we have a couple questions here. One is, why wasn't it reasonable to add a thread local constructor that takes a supplier instead of a static factory?
We looked at that, and there was a reason, and I don't remember what it was.
Well, yeah, we'd have to look at the API again. My recollection of that is that since it's subclassable, you can override anything. And so if you pass in a constructor argument, but then override the method that uses it, it's sort of, wait, this is kind of weird. So it just seemed like, to me, it seemed like a more natural fit to say, here's a static factory, you get an instance of some class, you remove subclassing and overriding from the equation, and the behavior of what you get back from the static factory is specific and well-defined.
Right. Yeah. That was it. There was some ambiguity of what if I use that constructor and override initial value? Now, which one do I call? And with the static factory, there was no chance to do that, so it was clear what you were doing. There we go.
Another question here. Any thoughts or plans on making consumptions of lambdas less verbose? So it's easy to pass in a lambda or method reference, but consuming them there's no shorthand for doing that.
So they don't like the idea that you have to call the test method on predicate. They want to invoke it like a function. That would have been a different way to do it in a different language. The path we chose was that lambda expressions were a concise syntax for creating instances of interfaces. And I think once you commit to that, you've got to commit to it all the way. And so the answer is, we considered that. We decided not to. Many people asked us to reconsider it. We reconsidered it. We decided not to. And there we are.
Yeah, I have another viewpoint on that. One thing is sort of, okay, it's great. It's great that we have lambdas and so forth, but when you want to call a lambda, I think it's a great advantage that the caller could have passed in a lambda, or anonymous subclass, or an instance of a concrete named class, and the user of that doesn't actually care.
That's right.
And so in fact, I've created APIs that took a lambda, and then in some cases I said, I actually want to pass an instance of a real class here. So the fact that those are the same is an advantage to callers.
Yeah, absolutely. So shall we switch? Okay, here. And now, Stuart.
All right, so let me start talking about Streams APIs here. So when we were working on Java 8, we had Lambda expressions well underway, and we had a nice prototype for them going. And so one of the things I looked at was, okay, we have a library, and we need to figure out how to use Lambda in it. And so some of the output of that was what Brian talked about in the first part, but some of it was looking at a bunch of other places and figuring out how to Lambdify it. And so one of the things we ran into was there are a lot of things in an API that aren't actually collections, but they're conceptually aggregates of other objects. And the most obvious thing to do when you have an aggregation of something is for each on it. So, okay, we have this thing over here that represents multiple objects, so let's for each on it. And then when we were working on lambdas, we had these, we could do things like predicates to do testing, so that's a nice little idea for lambda. So let's have a filtered for each as well. And then transformation function that you can map something into another value. Let's have a mapped for each as well. Well, we might want to have a mapped filtered for each, and so forth. So you can start to see, well, wait a minute, we've seen this before, this proliferation of things. So we don't want to have a for each, and then a filtered for each, and a mapped for each, and then maybe a sorted for each, right? So we're going down the same path here. Now, at the same time, there have been some other work out there about composing these functions together. And so what we also had at the beginning was the precursor of what is now the Streams API. And so what very quickly happened was the idea of adding lambdas around the library. I think it was certainly a good idea, but the greater application came from not just putting lambdas on things, but since we have the Streams API, let's apply streams to everything. And so in fact, we went ahead and did that, and there are a variety of places sprinkled throughout the JDK libraries where we use streams instead. So the idea is not, okay, I have this great thing called a lambda, let's apply that everywhere. We have a new library construct called a stream, and let's see what we can do with that. And the answer is, it turns out, quite a bit. In fact, I just covered that already. So, but there is a question, which is, if you have something that is conceptually an aggregate of other things, and you want the caller to be able to look at those multiple things, do you return a collection or a stream? And so the first order answer is, it doesn't actually matter all that much, because if you're given one, it's very easy to get the other. So if you already have stuff that returns a collection, just call stream. The caller can just call stream on it and say, oh, okay, well, I have a stream now. I have all my nice map filter operations and so forth. Now, if you write a new API and the caller can get a stream out of it, but the caller actually wants a collection so it can look at stuff later, well, it can just say collect to list or something like that. There's a nice collectors API at the end of streams that you can easily take any stream and gather all the elements into a collection. So converting from one to the other is pretty easy, so it doesn't matter all that much. But there are a few times when you might want to think harder about, do I actually prefer a stream or actually prefer to return a collection? So I'll talk about a few of those here. So one of those is if creating the collection is expensive. So if you have an abstraction of things and you need to do some I/O or do a bunch of computation to actually compute the elements, store them all in a collection, which there's the computational cost of creating those elements, and then there's also the memory footprint of storing them. If you simply return that to the caller, okay, that might be a fine thing to do. Well, what the caller might do is say, oh, I'm going to pick through, take one away, and throw the rest away. So you just wasted a lot of work. So in a case like that, you might say, well, why don't we return a stream instead of a collection? And what that does is it lets the caller use all the stream APIs, which are laziness seeking. So if the caller wants to say, gee, I want to find the first student who scores over 90 or something like that, right? Instead of doing a bunch of searching and gathering and creation of student records, only to have the caller throw most of them away, just return a stream of those. And then the caller can do a filter and a find first, and that does the minimum amount of work, gives the caller as a result, and we save a lot of computation and storage space. Now, on the flip side, there are times when you really do want to return a collection and not a stream. And there are some cases where, for instance, the elements refer to each other in a particular way. And so you want a consistent snapshot of the state of something at a point in time. And in that case, you could do a stream and collect it into a collection, but if you have some computation where you might want to bounce around within the collection, or you might want to have, like, to borrow a term from database terminology, like repeated read consistency, then you don't get that out of streams necessarily. If you get a stream, look at its contents, and then get another stream, the reason is that streams are only traversable once. So if you get another stream, you might actually have different elements in that stream. So if the caller wants a consistent view of things, if you as the API designer believe that the caller really needs to have a consistent view of things, then that's the time to return a collection. All right, so we said, okay, there are a few times when you want to return a stream. How do you return a stream? So there's a little bit of an art to creating streams. But there's some nice implementation techniques scattered around the library. Sometimes you have 0 elements. There's stream.empty. Or if you have a fixed number of elements, there's stream.of that takes a var args list. Those turn out to be surprisingly useful. So don't forget about those. But usually, sometimes you have an internal collection that you might want to do some pre-processing on, or you don't want to expose directly to the caller. And so the nice thing is, if you have an internal collection and you call stream on that and hand that back to the caller only has a stream, and the caller cannot use that stream to modify your internal collection. So that's sometimes preferable to passing, well, certainly if you return the collection directly, then a malicious or carelessly coded caller might actually modify your internal data structures. And so to avoid that, you might have to use the collection's unmodifiable wrappers, and that's kind of a pain. So an alternative to that is, if you have an internal collection already, just call stream on it and return that. Or if you have an array, just call array.stream. So these are real simple cases. Now, so if you have a class that is some kind of conceptual aggregation of other things, you probably already have a way to iterate over it. And so the way to expose that is to write an iterator. And so as, wait, did I? No, okay. So if you have a class that already has an iterator, it's pretty easy to take an iterator and turn it into a stream. And so there's a little bit of legwork. There are a couple of utility methods that you need to understand. One is you first need to take an iterator and convert it into what we call a splitterator. And so there's a splitterator's utility class that handles that. And then once you have a splitterator, the splitterator is the underpinning of the stream. So then you take the splitterator and turn it into a stream by calling another utility method on stream support. So there are a couple different variations on this. Sometimes you have an iterator and you really don't know how many elements there are. So if you're doing some I/O on a file or a network connection or something like that, you don't know how many elements you're going to process. All you know is, gee, I might want to get the next element. Oh, gee, there isn't one, so I'll return false from has next. But you don't know up front how many there are. So the way to do that, the way to create a splitterator out of an iterator like that is with splitterator unknown size. On the other hand, sometimes you do have some kind of internal data structure that maybe you have to do some processing on to generate, but you might happen to know how many elements you're going to return. And so in that case, there's a different variation of the splitterator's class, splitterator's call, that takes a size parameter. And so what that does is it gives the streams framework a little bit more efficiency because it knows how many there are. It can do some better buffering or potentially some better splitting operations for parallelism. All right, now sometimes you might not have an iterator handy, but in order to get a stream out of something, you might have to write your own splitterator. And there's a big variation in how much effort and how much difficulty there is in writing a splitterator. But fundamentally, the simplest way to write a splitterator only involves writing one method. And so there's an abstract splitterator in the library, and you can override that and override a single method called tryAdvance. And that is kind of a fusion of the hasNext and next methods of the iterator interface that all of you, I believe, are familiar with. But what that does is it does both of those things at the same time. What it does is it advances the stream, if possible, and returns the next element, and then returns true to indicate there was an element, or it returns false. And that's it. So if you have something that's amenable to that, then you can override abstract splitterator, subclass abstract splitterator and override tryAdvance. And in fact, I find myself doing that more often than writing new iterators for things. So if you've ever written an iterator, there's this complicated dance between hasNext and next, where they have to share state and cache something, and you have to do some fancy footwork there to make sure that those methods are communicating with each other properly. So sometimes I find writing the simplest splitterator is actually the easiest thing to do if you want to traverse some data structure. There are some other things you can override on splitterator, and so these all have default methods on them, so you can get away with just implementing tryAdvance. But if you want more efficiency, you can put in more work and get that efficiency. So the next thing that you might want to override is for each remaining. And so what that does is allows you, instead of getting the elements one at a time, it says, okay, just do all the rest of them. And so you can just write your for loop and do your internal checking inside of a loop, and that gets compiled and inlined and gets all the JIT compilation goodness out of that. And so that gets you a lot of efficiency and saves you a bunch of method calls. Now, there's another method on splitterator, which is where things really start to get sophisticated. If you have a data structure that is amenable to splitting and you're interested in parallelism, then you want to override the try-split method. So I'm not really going to go over that right now. There are other talks that cover how to do parallelism in streams. But just to let you know, writing a splitterator is not that big of a deal. There are a couple simple methods you can override, and then you can selectively override more and more and get better efficiency. All right, so now on the way to creating stream, once you've created a splitterator, then just call stream support.stream, and then that takes another there's another overload that takes a splitterator argument and then turns that into a stream. And then finally, also, we're all concerned about efficiency here. Sometimes you're going to want to expose a stream of primitives. We have what we call primitive specializations for int, long, and double. And so there are variations of all of these things. All of the splitterator classes and all the stream support classes and so forth are replicated for objects, int, long, and double. And so the variations are pretty obvious. But if you have something where you want to return an int stream instead of a stream of integer, then you just choose the same things with slightly different names, and it's pretty obvious how that works. All right, so there's a bit of a recap. There's a whole spectrum of ways to return a stream from some data structure. So if you have a collection, there's fixed arguments for, there's a fixed argument stream factory, there's an empty one. If you have a collection or an array, it's really easy to convert those into a stream. And then there's this progression of starting with an iterator, you can turn that into a splitterator and then to a stream. And then if you want to bypass the iterator, get some more efficiency, create your own splitterator, and there's a number of variations you can do and get more and more efficiency for putting in more effort. So just a quick recap here. I talked a little bit about iterators and then splitterators, and it's like, well, why do we have this extra layer in here? So when we were developing and implementing the streams framework, what we found was that iterator was really not quite the right thing. In particular, we needed a better abstraction for splitting and parallelism, but also, like I mentioned a little while ago, iterator has these two methods that you have to coordinate, and so there are some weird things that can go on in between them. The usual thing is for the caller to call has next, next, has next, next. But the caller can actually call those in any order, so you have to defend against that. So that means you have to have extra logic. In fact, my style, whenever I've had to write an iterator, is just call have next, call has next first, and then return, and then do something else, and then return it. And so basically, not only do you have this interaction between the methods, but they call each other, and it actually results in a fair amount of complicated code that you have to think about. And so I often have a problem where the first time I write an iterator, there's some bug in it because I missed some edge case somewhere. So I find that it's often easier to write a splitterator, but from a performance standpoint, the number of method calls necessary to get the next element from an iterator is a minimum of 2, and it's often more because of this complexity that has to go on underneath. With splitterator, there's a single method, try_advance, that either returns the next element or not, or there's for each remaining, which bypasses the entire sequence of method calls for each one. So splitterator exposes a bunch more abstractions to the streams framework, even for sequential iterating, even for sequential streams. So it turns out that splitterator is actually a better sequential iterator than iterator itself.
And it's also not racy.
Iterator, yes.
Fundamentally racy.
Okay.
So we had a couple of relevant questions here on this section. So the first one was, do all the Java library implementations support parallelism? And the answer is the support for parallelism is actually not in the stream library per se. It's in the splitterator for the for the source collection. So all of the collections in JavaUtil provide splitterators that have as good a splitting capability as they can offer. So array list splits really well, tree map splits pretty well, linked list splits really badly, but it will try, right? It'll do something, and if the computation you're doing per element is high, you actually can get some parallelism out of it. But if you're doing just a little bit of work on each element, you'll get no parallelism out of it. But yes, all the collections have been retrofitted with good splitterators that have as good a parallel implementation as we can give it.
Yeah, and even the simplest splitterators, the ones that override abstract splitterator.try_advance, there's some machinery inside of abstract splitterator that what it does, it gets the elements one at a time, but it'll buffer some up and then do splitting on that. So it's possible to get some limited parallelism even if you write a simple splitterator. Now, you're not going to get the best scaling, certainly not if you have an evenly divided array, but the potential is there.
Yeah. So another question here is a question on lambdas. Since lambdas represent code as data, why are they not serializable? See, this just follows me around. Some lambdas are serializable. They can be serializable if the target type is serializable. So I think the question is really, why didn't you make all lambdas serializable by default? And there's a really easy answer to that. Serialization imposes two burdens on a lambda that we don't necessarily want to impose on all lambdas. One is there's a performance cost, because creating a serializable lambda is more work than creating a non-serializable lambda. And the other is there's a security cost. Serializable data is less secure fundamentally than non-serializable data because it's easier, it has a bigger attack surface, it's easier to inject state into it. And so we felt that rather than exposing the pain of serialization, the risk, the performance cost, all that, to all users, why not have the 1 or 2% of users who need serialization for everything ask for it and have them pay the cost for it? So it can be, but we're not going to impose that cost on everybody just because some people need it. And that's the answer there. So, OK, take it away, Stuart.
OK, next section, optional.
There were a lot of questions on optional, but I figured you were going to answer all of them.
See how many I can answer with this. Probably not many. All right, but basics here. All right, so there's been a lot of discussion about optional. I don't want to dive into all the discussion, but what I do want to do is make a clear statement about the primary use of optional. And well, I'll just read it here. I usually don't read my slides, but this is important. Optional is intended to provide a limited mechanism for library method return types, where there's a clear need to represent no result and where using null for that is overwhelmingly likely to cause errors. So that's a fairly narrow statement, and it's focused in on a particular set of circumstances that occurs moderately often in writing library APIs, but it doesn't occur everywhere. And so it turns out that there are many, many places that you can misuse optional, many more than there are uses for optional. There are some very good uses for optional, and I'll talk about those before I get to the counterexamples. All right, so a bit of a recap. If you have a method return value, quite often you might have some kind of searching method or finding method where it's entirely reasonable for it to say, I didn't find anything. And, or you might be searching for one thing, and it might say, I didn't find that thing. And so that, I think, is the closest model for when you would use optional, because an optional can contain an element, or it can be empty. And so the nice thing about, the main thing there is that the usual way you design APIs that can return 1 or 0 things is, oh, I'll just return null. And the problem there is that the caller says, oh, wait, I'm going to get that thing and then call some method on it. And that's where null pointer exceptions come from. So that's really the case that we were focused on when we provided optional in the library. And so that's when it should be used. So if you have something that can return 0 or 1 elements, use an optional instead. And what the caller can do is, instead of basically it doesn't get the element itself, it gets an optional of that element. And so the caller then can chain methods off of that to either do things like either get that element, or if the optional is empty, then to provide a default value instead. So there are a bunch of things you can do there. I'm not really going to go over into the API in detail. I'm just going to touch on some, touch on the most common cases here. One very, very important rule is, if you're writing an API that returns an optional, never return null as the optional itself. That completely defeats the purpose of why we added optional. Always return an optional with a value or optional empty. Never return null. And so notice carefully what I just said there. There's a null reference, but I try very hard to avoid saying optionals containing null, because that's really confusing. It's too easy to confuse with an actual null optional itself. So what I prefer to do is stick to saying an optional that has a value or has a value present, or an optional that is empty, or an optional whose value is absent. All right, so if you are returning an optional from a method, then what it does is it allows the caller to take that optional and do some things on it safely, regardless of whether the optional is present or absent. And so a common thing to do is to say or else. And so that gets the value, or it substitutes a default value in its place if the optional is empty. So that's very convenient for a lot of things. So again here, don't say or else null, or at least try to avoid that, because that buys you back into the whole null thing. Now, the time to use or else null is if you're if you're working with a library that returns optional, and then on the other hand you need to call something where it says really pass null here. That's a time to say, maybe say or else null, but you've got to think about that a little bit. So again, usually there's a different way to proceed than saying or else null. A couple of variations here. There's or else get, which instead of providing a default value, it takes a supplier of the default value. And so you can pass in a lambda that will manufacture that default value on demand instead of having that pre-computed. Sometimes you can delay a little execution that way, or do some lazy computation. And then another variation is or else throw. If the value is absent and and that's a problem, then you can throw a custom exception if the value is absent. Now, there's also get, which is kind of the most obvious thing to do, but it's actually kind of a problem because that buys you into a pitfall, because what it does is it immediately throws no such element exception if the optional is empty. And that's probably not what you want. So unfortunately, get has the most attractive name, but actually the other methods are probably what you should look at first.
Mea culpa. My bad.
So there are times to use get, but you have to be very careful about that. Really, the only time to use get is if you can prove that the optional you're getting back from something is never empty. And that's kind of rare, but it sometimes does occur. All right, a couple examples of what we just talked about with optional. I have a little stream pipeline here that looks for words that start with A. And so the return value from that is an optional string. So that gives, that gives the first word that starts with A or an empty optional. So we can say, we can print out that word or else print not found. Or if I want to go find the message from somewhere, I can say print out the matching word or else get the replacement value from somewhere else. All right, so that's the most straightforward way to use optional. I think the main thing is focus in on the fairly narrow use case of a return value where it's commonly expected that there is no result. Unfortunately, there are a lot of places where you should not use optional. Because it's kind of cool. There's a lot of stuff in there. There's some interesting methods you can do chaining. And it's very tempting to use in other places. So I recommend that it's fun to play around with, no question about that. But it's definitely possible to overuse optional. So I recommend that you not try to use optional as method arguments in object fields or to put optionals in collections. It sort of sounds like it might make sense, but if you start to work with code that does that, it really adds a lot of clutter. One key point here is that it is not a goal of optional to eliminate nulls entirely. Unfortunately, nulls are pretty pervasive in Java programming. What we're trying to do is attack the most common case, which again, I'm repeating myself once again, the most common case of returning a value that might or might not be present, and the error-prone case where the caller is tempted to take some reference, to take the return value and call a method directly on it. That's the case where null pointer exceptions come in, and that's where this is targeted. But there are a bunch of other places where there are nulls flying around, and it actually does not necessarily cause a problem at all. And for those cases, I recommend you not use optional. There are a couple places, for instance, if you're writing a class and it's a reasonably sized class and null is a useful sentinel value for private fields. So what you can easily do is examine all uses of that private field and make sure that they're null safe. And you can use that to mean uninitialized or absent or whatever you want it to mean. But within the scope of a single class, using null seems perfectly fine. If you have something that returns an aggregation, like a collection, stream, or array, don't return null to indicate that there are no elements. This is a common null object pattern, but it bears repeating. If you have no elements to return, return an empty array, an empty collection, or an empty stream. Those are all pretty easy. And the great advantage of that is the caller doesn't have to check for null. The caller just does all processing. In fact, ends up processing 0 elements. And it's so tempting with optional. Oh, look at this. We have optional, and we can chain methods onto the end. And so what people do is they say, oh, optional, that lets us get rid of nulls, right? So I want to write something that handles this string parameter that might be nullable. So I'm going to take an optional, so I'm going to take this nullable pointer and turn it into an optional, and then, oh, cool, I can chain a method, and I can call lambda on it as well. So I'll call the default method. And so I've seen people write code like this, and it's kind of cool that you can write it as a one-liner, and we're using all these new features like optionals and lambdas and method chaining and stuff. But come on, guys. Look at the code on the bottom. It's like, if it's not equal to null, do this. If it's not equal to null, do this, else do that. I mean, it's really simple, completely straightforward. Everybody understands it. And it's a lot shorter and probably more efficient, too. All right. Once again, focus on returning optional for the cases on a method return value where there might or might not be a result. Resist the temptation to overdo optional. It's very easy to do, but just don't. And one of the things we've observed is that overuse of optional has turned into a nice manufacturer of new code smells. So be on the lookout for those. 5 minutes. Okay. All right. So getting the signal to move on. So just a few words about default methods here. So one of the things that so default methods are a new feature we added in Java 8, and you know, it's all closely related to Lambda and streams, so I figured it's worth dropping in a few words about this because these do affect the way you design your APIs. All right, the primary use case for adding default methods to the language was adding the ability to evolve interfaces over time without breaking implementations. And so in the past, before default methods, if you added a method to an interface, and you weren't able to change all of the implementations of that interface, there would be some implementations that would be missing those methods. And if something called those, you'd get an abstract method error. And so in the JDK at least, and certainly in other large-scale software projects, once you created an interface, you could basically never change it. And that turned out to be a real problem, because there's so much pressure built up in trying to evolve interfaces over time. So that's the primary use case of default methods, and I think they work pretty well for that. And so if you have a case where you can't update all the implementations, you can provide a default method. So I think an important point is that default methods can be overridden. For a subclass, the subclass can either accept the default implementation or it can override it. And there are cases when you do and do not want to override. But in either case, from the caller's point of view, it doesn't matter. It just sees a method on an interface. It doesn't care that it's actually a default interface or whether it's been overridden or whatever. It's an ordinary virtual method. Okay, quick example of default method. We've added the for each method to iterable, and it's pretty simple. So iterable, the only thing iterable knows how to do is to get an iterator. And so what this does is provides a default implementation that just does our simple enhanced for loop that iterates over the contents of the iterable and calls the consumer method each time. Now, there are a couple other use cases where default methods turn out to be very useful. So one is if the method is actually optional. So back to our friend iterator, there's the third method that everybody forgets about, which is remove. Now, I think most iterators in the world don't allow the caller to remove things from whatever's underlying the iterator. And everybody who has written an iterator up till today has had to write this remove method. Well, so in Java 8, we provided that as a default method. So if you don't want to support removing, you just avoid overriding the remove method entirely. The default method throws unsupported operation exception for you. Now, of course, if you do want to support removal, you just override it and go ahead and do the removal. And then there's a case where default methods can also be used as convenience methods. And sometimes the implementation is so simple that there's generally no need for the subclass to override them. And comparator.reversed is an example of that. So if you have a comparator, how do you reverse it? Just call the arguments in the other order. Okay, hey, and we're done. So if you're writing a comparator, there's really never any need to override reversed on it. Now, one of the things that, this is kind of the same story with optional here. One of the things that we get into is whenever there's a new feature, people are tempted to say, oh, let me use it for this. And so, well, it looks like we're running out of time, but I'll just say that default methods are not a replacement for abstract classes. There are some important places where classes are still useful. One, classes can contain state and interfaces cannot. And another important point here is that classes can communicate with their subclassers using protected methods and fields distinct from their callers. This is something that's very easy to forget. One common anti-pattern is people will try to share implementations by putting them into default methods on an interface. But what that does is it usually ends up exposing unnecessary methods to your callers. So sharing implementations among subclasses is really something that you want to use classes for, not default methods. So once again, don't overdo it. All right, so we ran through some interesting new language features and how they affect APIs. We took a few questions in line, and I think we're actually out of time. So thanks for your participation.
think we can start, right? Perfect. So hello, my name is Adam Bean, and I delivered similar talk, as of course not the same. It is just, I hope, completely different. Last year, who attended a talk last year about NAS1? Someone? Yeah, you were the only one, and he even used the ideas from the talk to implement some code generators. So it was interesting, and it's very good. So you didn't attend, so I could show you basically the same. I won't do this because it would be boring also to me. So what I'm going to do, I would like to present you some ideas from my daily work, how I use NAS1, with lots of source code, and explain you the concepts. What you have to know is none of my project is pure NAS1. So actually, my project, no one cares about JavaScript. What I'm doing is usually not boring, but usual Java 8 job. This year, everything I did was Java 7 and Java 8, except one project was Java 6 on JDK 1.7 and Glassfish v3. Everything else is up to date. And why we use NAS1 in this project? Because for certain use cases, we were able to save a lot amount of money, time and money. This was always the case, and I would like to present you the use cases. And in some use cases, it would be really hard, or if not impossible, to do it with Java. And my goal is to explain the use cases, and the source code I show you today is open source anyway, most of them. I cannot usually show you my commercial projects. They were boring anyway. Usually are computations or flexible algorithm or something which actually does not matter, but ideas are the same. You can ask me questions whenever you like, and also deep technical questions about NAS1, because I saw Jim Lesky from Oracle from engineering. If I cannot answer the question, I will delegate to him. Ask me whatever you like. So even bytecode questions, and I will delegate to them. I'm a NAS1 user. I never contributed a single line of code. I would like. I have some ideas, but I'm just a user, a NAS1 user. OK, I'm working with Java since 1995 and really like it. And I started at the beginning also with JavaScript because I had to. But right now, I use NAS1 because it's there. OK, the main idea is what I always say in Java 8 projects. I try to minimize external dependencies for speed. It's a nice story. NAS1 is part of Java 8. And this is a huge deal in my projects. I don't have to ask whether I'm able to use it or no. In all enterprise companies, if there is Java 8, I can just use NAS1. If I would like to introduce Scala, Groovy, whatever, I will have to ask architects or I don't know whom, may I use the library, and NAS1 is just there. Before NAS1, I used similar stuff with Rhino. It was in JDK 1.6. Some features were not available, and Rhino was a lot slower. I don't know how much slower, but a lot of slower. I don't know, orders of magnitude slower, right? Orders of magnitude, I don't know, 10 times, 20 times, or whatever. So I have 2 slides with contents. Everything else is marketing. So some URIs, AirHacksDV, I can answer all questions, remaining questions there. If you like, come to Munich in December. And this is an online course. And these are actually the use cases. So before we probably, who uses already the scripting engine GSR 223? Anyone use that in Java? OK, then I should start with the basic probably. But before I start with the boring basics, I would try to implement something completely different. So what I can do, this is it's getting better in a second. Hello. And what I will do, the problem is, yeah. I thought this is the problem. So if in full mode I get here, I will have to quit that. We are the same. I thought in JavaScript session, there are younger developers, so I can go with 18 font, but it's the same as in Java. So I will have to go back to 24. 24, let's see. So hopefully it gets a little bit better. Files and no favorites. So, and what I would like to do, this is the folder I would like, this is just a version. New JavaScript file, hello. Hello already exists, echo. So, and what I did in NetBeans, it will be able to run NAS1 in script mode. So there is, this is the only thing I did. This is stock NetBeans. And you can set script mode, and there is in script mode. What script mode does, I can use NAS1s as shell replacement. And this is, for me, a very good thing. I lost already several hours, if not days, to find out arrays, escapes, or whatever. And in JavaScript, it's at least defined. So how it would work, for instance, I could say here, hello world, of course. So this is not very excited. Run. So hello world. A little bit more interesting, I can do stuff like this and say, of course, 42. Now you see, this is the purpose of the talk, actually. I can go here and, for instance, do inline replacement. This is only available in the script mode, but very useful. So it can just rerun the script. I can just use this one. You see, it's always the same. This now should work. This is already very useful. What we use this for, you can imagine Docker, application server installation, URI replacement, localhost replacement, port replacement. Okay? So for loop in a Docker, you can spin off 5 containers with different ports and different IP addresses, period. The great story is, you can say we can do the same with shell. But what I can do, I can say here, breakpoint, toggle breakpoint, and debug this. And this is impossible with shell, or at least not to my knowledge. So we can say debug. And we'll stop here, and I can evaluate here the value of the variable. And this is already incredibly useful. So how we work with that, we implemented the script that way. It was almost test-driven. By the way, I also wrote blog posts. Sometimes we even have unit tests. So you can use stock unit tests from Chai or whatever assets you like from your favorite JavaScript framework to test builds and automatization scripts in NAS1. So what it actually means is, in our Docker container, this is a mix of Java E and NAS1. And on a very top level, here, this is the base image. We link to the JGS. This is the interpreter. And now NAS1 becomes available. NAS1 scripting becomes available in all images. OK? You got the first use case? The nice story is my current project, the developer's working with Windows, I'm working with Mac, and the server runs on Linux, Red Hat Enterprise Linux 7. NAS1 runs everywhere. Prior to this, we had to deliver batch and shell at the same time. OK? Questions? No questions. Is this useful? It is, right? Very good. So what NAS1 can also come with is the following. What you can do, you can say here exec. This is like built-in function. And say ls. And then out. This is the output. This is built-in variables, and this is extension of JavaScript. So it's not a part of JavaScript, but this is NAS1 extension. And then I can say print, of course, and out. By the way, the NAS1 engineers always tell me, use the back sticks to run the commands. I don't have to use the exec. The problem is it will mess up the formatting of most IDEs, the backticks. With the exec, it just works as a function. So this is the reason why I always use exec and out and never the backticks, because the formatting doesn't work. So so if I run it, now it's debugging on, so I can step. And this is, as you can see, I just go to the Java code, but it printed all the folders. OK? Now you might ask, for what this is, what difference does it make? And I show you one installation script. This is actually a slightly modified script from my current project. What it does, it sets up fully automatically Payara server and domain of your choice. The domain name is here JavaOne, and these are the ports. And it stops the domains, deletes, creates a new one, starts the domain, creates JVM options, create a JDBC pool with different name. And then it prints it out. And the interesting part is this script runs on development machines as well as on Jenkins. So we have the same script everywhere. Okay, and this is very simple. So if we would get, for instance, additional JMS queue or topic or whatever, there will be additional line, and we can debug this. This is actually incredible. So we did this prior to this. A few years ago, I showed you something similar with shell scripts, which always are painful to implement something like this, for me at least. Any questions? This was installation. In one commercial project, we use JavaOne to install UI, JavaFX clients, for instance. My client used this. This was my advice. They asked me, what is a cross-platform installation? They had to download stuff and unzip stuff, and they had to provide shell scripts batch files at the same time. And JavaOne run everywhere. So, of course, if you have Java 8. So I think we covered the installation use case, right? So you can imagine. So if you can script, you can use operating system commands, you can do whatever you like. OK, how to know what's available and what's not available? This is actually a great wiki. This is what I look all the time and search for new things. And this is JavaOne extensions. So what it means, for instance, here we will find the stuff with exec and without. This is the additional features of JavaOne. JavaOne implements ECMAScript 5 and hopefully, I don't know, JDK 9 or 10, ECMAScript 6. So, but 5 is already there. And it's very compatible to my knowledge. Questions? No questions. OK. Then you wanted to ask questions in my prior sessions, and now you can ask questions, and you don't want anymore. So automation. So this was actually, this is another thing. This was a small hack. I'm working now with Docker registry. So we are pushing stuff to the Docker registry. In Docker registry, for unknown reasons, there's really ugly REST interface. Docker is nice. The Docker registry is not nice, the REST interface. So, and the first thing I did, I copy and pasted the URI from the Docker registry doc v2 and created a JavaOne script. And this is typical. What I do here, I use here curl. You could use wget. Instead of using JAX-ORS in Java, it's a thinner. I could use JAX-ORS library, but then I had to set up class path and package this. I don't like to do this. So now, curl is there. And this is almost like magic, because what I get here, I get the command. It is executed. And I parse the string. And what I get back is JavaScript JSON. And this is extremely convenient in Docker, because you get JSON back, so you can extract image statistics. We created, actually, with this, a small monitoring system with a few scripts. And the same scripts can be used in Jenkins to watch Docker again. OK? So Docker is popular, so I'll show you this. But we use also JavaOne to monitor enterprise apps the same way. So each app implements a small synthetic transactions, so emits some JSON. And we use JavaOne to monitor this. OK? What do I have to do? Who cares? It's a command line script, you know? I think the registry could even run. This isn't, I don't even know. Yeah. BlockDB is the registry. There is one image in the registry. So now it's connected to registry. I got the feedback in 0 seconds. So it's very fast. 0 seconds is OK. So another thing, my block. The problem with my block is the following. It runs on, for historical reasons, on HSQL. This is a Java database. And this was just a fun, I don't know, 2006, I started my blog, and so what happens? It was just Java technologies, and then it became popular, and it's still HSQL. And what I would like to do is not to back up my blog as a, I would like to take the file, put it to the Docker container, and use it as backup or for trying new things. The interesting part is HSQL comes with JDBC driver. So what I can do very easily, I can connect to the database and via JDBC script this and redirect the output whenever I like. And I show you a more elaborated, more complex example in a second. This is the simplest possible thing. So it was, I just created command line tool. It says, go here, use Duke and secret. And this is the HSQL command. It says to HSQL, backup. It writes the file, and then I can pick the files later. So it's a very simple script. And it actually doesn't run from command line. It runs from an EJB, a timer EJB. So I misuse EGBs as cron. It's simpler. It's one class with one annotation. Okay? So JavaOne team happens to be very responsive. Last night at Jim's session, I had a question. And the question was, is it possible to have this feature scripting mode using the scripting engine manager, the default API? And it is possible. I got per Twitter a nice answer. And what I did, I implemented a unit test to demonstrate you this. I will blog about this later. I had no time so far. It was just a short night between. So what I did so far, I used this, JavaOne Scripting Engine Manager. Actually, from the technical point of view, it does not make any difference except JavaOne Script Engine Factory probably is a little bit faster than Script Engine Manager because it doesn't have to look up all the engines. But if you use another script engine manager like Ruby, Scala, or whatever, you won't get the script functionality. But what I don't like, be depending on this. Because what will happen one time, we get strange SolarCube rule or whatever, and the QA department will find out that we use internal JDK APIs, and you're always in trouble. So what I was interested is to use stock Script Engine Manager API, and what you only have to do, there is a set a system prop in JavaOne args scripting. If you do this, you can run like shell scripts written in JavaOne, so this, how to call it, JavaOne in scripting mode from Java, not from command line. And this is very good for, I don't know, if you, for instance, right now I'm working with Hazelcast. So what I would like to have, so some like cron jobs and monitoring jobs which run periodically, backup on stuff like this. So I can just package this in a war, store an JavaOne in a database, for instance, load it on demand, execute this, and store it. Very convenient. Few lines of code. I won't skip the EJB because it's trivial. I show it a million times. One class was at stateless and schedule. Agreed? So what you do, you can do this route or this route. And what you can do in Java then, it's say exec ls print out. So this is a very short script as a string. And it will, the script is going to be executed. It will see the same output in the shell. So, and you will see the same output. Questions? Even more usable. Yeah. Yeah, this is what I did previously. This is the default. This is actually somehow new. This is this. So what NetBeans did, I can go to command line. Then what I will have to do. Yeah. Terminal is a terminal, right? So what I only have to do is the following. I know, larger font. So what I only have to do is the following. I have to tell Linux or Mac use this JGS as the interpreter. So and make it executable. And then run it, and you see only this because it is started with -v. If you skip this -v, there will be no output there. This is the default mode. So it runs in one point of time on my Linux like this, on my Linux box, or the project on Jenkins. And the NetBeans are just used for development. And what I usually do, this I show you yesterday, I think, I use Gulp as another hack. What Gulp is, it watches the directories on each change of the script and install the script automatically in a directory with which is in the path. Okay? Now, next use case. Anhydrator. It's an open source project, but it started as a commercial project. I was hired by a company, typical Java EE projects, and they wanted me to use JBatch for data transformations. And I asked, why you want JBatch? So what is the problem, actually? The problem is the following. They implemented like IoT product, and it was shipped worldwide, and some master data was maintained in Excel. And this was a requirement because it was like it is. There was output Excel. There was no way around. And it was slightly different per customer. But internally, we had something like a unified object model, JPA model, and we had to map the Excel sheets to our data. And the problem is this product. What product means is that the customer should not recompile the Java classes. So what we had to do is to separate the core product from the extensions. And I thought, OK, JBatch, Java 7, or I like it, but it doesn't solve the problem at all. In JBatch, I would be able to start 10 Excel sheets in parallel and process them in parallel, but it actually does not matter. So what we did instead, I said, OK, what we could do is just use Java 8. And there was the following idea. And before I do this, I will have to, because probably you don't saw the API yet, so I will have to hack a little Java project to show you how it works. And I will call it basics. And go with a unit test and say US JavaOne basics test. So, and how it works on the server is actually very nice with the concurrency stuff, because what we always do, I write a unit test, but imagine it were a managed bean or session bean. So we have before in unit test. On the server, we have post construct. So the nice story is if you use, for instance, EJBs, they are pooled. And they are created on demand. So if you get 5 parallel transactions, you get 5 instances of EJBs. So what it means, the scripting engine manager, the NAS one, with the whole script, gets evaluated only once. And even a startup, which makes it crazy performant. So there is no need to restart the engine all the time. You can keep it associated with the instance. OK? So how it looks like, we do something like this, new script engine manager. Manager. And engine by name. You can use JavaScript or even NAS1, or you could use instantiate, or you could instantiate the NAS1, the engine with NAS1 factory. And I would like to use here the engine. And then, so this is the initialization phase on the server. So this is a JUnit, but it works the same way. Yeah. And the test, what I can do right now, say here, eval. I could say this engine eval. Print hello. And throw the exception. So hello, it seems to work. So this is a prototype of a EJB or CDI component which would run on the server. So we keep the engine here. So EJBs are thread safe. So thread safe, there is no way that 2 threads will access the same instance at the same time. So we get a parallelism for free. The overhead is, of course, we get multiple engines at the same time. I don't know how bad it is, but usually 5 engines. Is it bad? How expensive is it? Because in the stress test what we did, it was perfectly fine. So we never had a problem with memory or whatever. So it was like, if you hit the database once, it seems like this doesn't matter anymore. OK. Yeah, but it happens at the startup time, where I can configure the application server min pool size 5, and then all the EJBs getting started, and if the server boots and never again. This is what we do. OK, what you can also do, of course, it gets a little bit more interesting. You can say here, this engine, get bindings. No, how it gets set? What is it? How it, no, get put, exactly. This is like hash map. Put hero and Duke. So, and what I can do right now is to have something like hero and run it. Hello, Duke. So what you can do, you can pass any Java object you like that do not have to be primitives to NAS1 and access that. So what we did is not on the slides, validation. You can pass JPA objects and write validation scripts in NAS1, and you have full access to the whole domain object model. What we also did, like optimization algorithms, which were flexible, they could actually modify the JPA objects, and hence, since NAS1 runs in the same transaction as the EJBs, afterwards they were modified, but at commit time they were flushed to database. You got a point? You can pass other entity. NAS1 can modify, depending on algorithm, the state, and after the call, the modified state is get automatically flushed to a database. Okay? So this is actually, this was very useful. Questions about that? So this is the bindings. This is basics. What's a little bit more interesting is this. What we can do, yeah, runnable, for instance. I can say, I think it's invocable. I think NAS1 is always invocable. And this invocable has a method getInterface. And here I can say, this engine eval and say function run print in runnable. And runnable is actually nice, but it comes with JDK. This is one method. It's functional interface, no exceptions, so you can misuse them as a command pattern for NAS1 functions. So what I did right now, I instantiated this runnable on the fly. So what it means is, in my projects, no one knew that we used actually NAS1. It was in one component. It was packaged, made injectable, and what we got, injectable interface, and it was type safe. If this fails, you get null back. So what we did on null, we got a fallback. Fallback was Java Lambda. So if you get null here, you can say, then I create my own runnable in Java, so there's no risk that it won't work. So you should have a default algorithm for this, or default default implementation for this. Agreed? Hopefully it works. No, it won't. This is a unit test. Command, assert not null, command, and then say command run. Is runnable, seems to work. So we never wrote such a script. These scripts were always stored in relational database. So we could easily maintain them and version them. So there was always something like a table with three columns, name of the script, version, and the content. And we provided us a small REST interface to manage that. Questions about this? Please ask questions. If not, I'll show you a little bit more crazy exercise in a second. So What is the deal with the anhydrator? The anhydrator was the following idea. We get input, we transform the input and write the output. And we use functional interfaces from Java 8, just a function. And now the customer wanted to have something like a DSL. So he wanted to say from Excel, modify type, and whatever. And there were data transformations, and there was simple output. And yeah, there's the project anhydrator. It's on my GitHub account. It is basically used already in some hospitals in USA, which is a little bit scary because, but there was no news so far. And this is just unit test. It would look like this. Engine, flow listener, from, source, to, query, build, start, and you're done. And there is some conventions, and the conventions are all the Java code, so all the inputs here are basically lambdas, and then can be replaced by JavaOne functions. So this is your choice whether you put here a lambda in Java or a string. If you put here a string, it will try to find in the local folder a file with the ending JS, will read the JavaOne file, instantiate as a Java function. You saw how. This is no difference to runnable, and run it. And the funny story is, because this is a functional pipeline, we can even run it in parallel. It's a stream. It's actually a stream of JavaOne functions. The problem was it was so fast, so there was no need for optimization, which is a little bit boring. I hoped I could experiment a little bit more. The client said, OK, I'm happy, go away. So now I'm waiting for the next contract. So probably next year we'll show you what I did. And these are actually the functions. This is just, no, it doesn't need the functions. Here are the functions. So there are column transformations. So you can write a JavaOne script like here. There's execute was not run, and you can do whatever you like. So you could transform the entry to whatever you like. And the entry is a Java object with the name column. And there's method like convert string to long to float, whatever you like, rename, or there are some functions what they needed. And the funny story is, I was actually hired to implement a Java 7 batch. And what I did, there's a small library, I don't know how small it is, without any external dependency. It's just Java 8 and lambdas, which is very important in products, because we don't like to ship 50 jars and hope that it works. And it's actually a cool IoT project with, I don't know, several thousand devices and one glassfish. Questions about that? The main purpose, and this happens in all products which I was involved in. So 90% of my projects are just projects. But sometimes I help to build products. And if you build products, they have always the requirement the core has to be sealed. And sometimes they're even sealed, as the jars are sealed. And on the extensions from client's extension has to be separated. And JavaOne is just perfect, because in the core, you are relying on interfaces. And if you load the extension from the outside, it's cleaner separation you won't get, even not with OSGI or whatever. It's just perfect. They can be in jar or outside. There is a script loader, you can customize this. One guy which created the hospital software, I'm waiting for the interview. He will also give me soon the interview, how it uses the anhydrator. I have no idea, I don't know him. He said, thanks for this, and it works well. He aggregating data from different hospitals with that. This is what I know so far. Okay, yeah. Yeah. To my knowledge, because the engineers are here, it's very secure, because it is not interpreted, this is translated to bytecode. And there is one option I could actually activate here. It's called no Java. And then you are not able to invoke system exit. And you can also, no, system exit is, if you install Security Manager, then it's as safe as the application server. So there should be, JavaOne is as safe as the application, right? So what you shouldn't do, accept input with script from the UI. This would be also safe, but you get other troubles. You know, someone can implement an endless loop, for instance. Yeah. Yeah. Almost forgot about this. Another use case. What we wanted to have is we use bin validation, but we wanted to use the same scripts what we use in the front end. So we reuse the Angular validation scripts in the backend using NAS1. This is the same story. And we use bin validation, which was flexible, and we used that. And we also used input validation with JAX-RS. In JAX-RS, you can put the validation annotations on the parameters. We use a bin validator, and then, yeah, it works with Java 7. So absolutely, you can do this. Yeah, this is what I show you in a second. This gets even cooler with the lambdas. This, and there was another use case you remembered. So this was actually a good question, because I got two other use cases. Now I forgot it, but I have to look at the slides. OK, headlands. Then I will have to draw a little bit. So what headlands is, you know JCache. JCache is a simple caching API. The default implementation of JCache is Coherence, Hazelcast, and Infinispan. I used Hazelcast because it was the easiest implementation to configure. You said yes. Very good. OK. So what is possible to do right now, I could fire it up, but I won't. This is a talk about NAS1, not about caching. But I can run in Docker. This is actually Payara with headlands. I can fire up multiple instances, and they use consistent hashing. So what I get with this is in-memory grid. And via JCache API. I show you source code in a second. And what I use it for to store statistics of my block and evaluate the statistics. So what I would like to have is to query the cache. So what I did previously, I implemented this full in Java. So I have to redeploy the whole cluster. So I had rolling update, but it was not really exciting. With NAS1, if you think about this, you get the ultimate agents. What I do right now, I write unit test, which is local. I load NAS1. It instantiates, and I test the interface. If the test passes, I push the string to the grid. Because it is a grid, the query gets replicated to the whole system. On each node, my system instantiates the script, and I can execute the script. So what I get is something like stored procedures with NAS1, without any risk of serialization or versioning. And this is also crazy fast. It's really fast. OK? So with NAS1, this is incredibly easy to implement distributed lambdas without any serialization. We use it all the time in several projects. The only problem is you have to be consequent with testing. And I started with the test. You saw what I did, right? I implemented runnable. It was loaded. And if this passes, after the tests, after all asserts passing, we are pushing to the grid, fully automatically. So there's actually the same type safety as in Java. So, but we don't have to serialize this, and this is tiny. OK? And the source code is checked in. This project headlands. You can clone it, and you have it. At the flight, I pushed it to the repo. I forgot it, actually. I just using my projects. But the first time ever, I had power during the flight. So it was incredible. This was a hyper productivity, 12 hours were 2 projects completed. So headlands. Processors, boundary. There was no performance test because there were just 12 hours. So I will test it at home how fast it is. So what I get this is even crazier, what happens here. This is the query. What this is, the cache has so-called entry processors. So you can push to the cache a lambda, and Infinispan or Hazelcast will automatically distribute this. It could gather the results. So what I implemented is the NAS1 implements all the listeners and entry processors from JCache, So I have a REST interface. I push NASON script to the grid, and the results are gathered. So I get something like in real-time queries in data processing, a MapReduce in Hazelcast. And the whole project is about 10 classes. That's all. This is incredibly, that's all. So I have here view classes, and this is the NASON engine with post-construct. It means per thread, there is one engine, and I'm using EJBs, so what it means, I will have in parallel to start really true multiple parallel transactions. It's really hard without a stress test. Then I get parallel engines. Usually it's just one. And this is this eval script, what you saw here. And what I'm doing is it evals here interface to something. So I use just generics. And I'm able to instantiate whatever I like. So there is one NASON engine. And this component is able to instantiate all interfaces on Earth. And I use all interfaces from JCache API. OK? Questions? I think this is really powerful, right? This is like agents, what you wanted to have always. So you have a moving code. Yes?
So my team did something not as sophisticated.
This is not sophisticated. This is crazy simple if you think about this. What's here, the only complicated thing is the interface, a little bit complicated, the entry processor, but this is from JCache.
The idea is quite cool, but that's why I meant by sophisticated. Anyway, we did it back in Java 7.
Yeah?
And I think with the older JavaScript engine.
Mm-hmm.
So we run into the problem that every time you compile one of these scripts, you're creating a new class. As you're creating a new class, and a new class, and a new class, and then you run out of the permgen.
Permgen, I think in NASON is configurable, right? How many classes you can, I think 50 or whatever. There's a settings how many classes are pre-cached, right? So you can have this is running for 200 days or something on my server, and no issue so far. Okay, in Java 8 you cannot get permgen. You get another exception then. Okay, we have 20 minutes. Is it true? Okay, then SPG. This is what I showed last year, and this is also cool and also popular for unknown reasons. It's the following. This is actually one script, also open source. So and this is a NASON script, which is executable with conventions. There is an input folder and output folder. And I use Java.io. And what I do, I load mustache. And I think this is what you saw last year here in the course, and you're using for code generation, something similar right now. And robots. When is your session tomorrow? 2:30. So there's a speaker here. Will you present this or not?
Yeah.
5 minutes at the beginning. You can show it and then say, OK. OK. So what happens here is the following. You know what mustache is? It's something like GSPs in HTML5. So you get placeholders, for loops, if, and whatever. It's a templating for HTML. Has nothing to do with Java. So I just downloaded the library. I can download I show you the library. So just from GitHub Mustache. And this is just templating engine. There are Mustache and Handlebars, two libraries. And if you used ever Angular or Knockout.js or whatever, there's placeholders which are replaced. So, and what I can do with that, this is static page generator, SPG. So what it means for static pages, also in enterprise projects, pages which do not change frequently, we do not have JSF, we do not have JSPs, we have plain HTML pages. And because we know when the database changes, we have like a hook. When the database changes, we fire up SPG, and it generates all the static pages. So, and they are offloaded to Apache. So there is actually nothing on my server. And actually, all my registration pages on my blog are also this way. It's just they're on Apache server, not on Glassfish, because there's no reason to run it in Glassfish. It never changes. They change exactly 3 times a year. So we know why to dynamically generate the code over and over again. We can save power with NASON even right now, right? So So I can show you it's my block. And this is this SPG. And if I say here gen, so it would generate all the workshops, the static page. And why I have to generate? Because the date here, it varies. It is once here, then at the form is on different places. And I always mess up the dates. This was actually, it's always redundant. And what I have to do instead right now is the following. There's up here JSON HTML. This HTML is the template, and JSON is the input. Could also come from Java. It doesn't matter. So if I open these, and so you see this is the input. And you will find here somewhere the templates. And the nice story is the templates, they are well documented in the Mustache framework. There's nothing to do with JavaOne. It just works out of the box. And what is also nice in real-world projects, we were able to use closely with designers because the designers were well aware of the syntax anyway because it comes from HTML5. And what I got a feedback, this project is used a lot to generate configuration of application servers in the cloud. Because what they do, they use this SPG and have placeholders, I don't know, JDBC names, whatever, and then feed the JSON, and it generates Whitefly, for instance. I know it's used for Whitefly, and it's generated on the fly. And the feedback is, of course, is great, nothing to install. It's Java 8, and Whitefly needs Java 8, so there's no additional library, no risk involved. Someone said crazy use cases. I think they are not that crazy. It's very stable. Questions about this? So we can leave SPG, right? So TPCamp, probably. There's a startup, and I can talk about because I'm still. Interesting story. If you would like to hear the story behind this, ask me. This is a startup running on pure Java EE without any dependencies. And one day, what they are selling is like campground management, everything as a service, even with Raspberry Pis, whatever. It's completely crazy project and runs on a Whitefly without any dependencies. But what he had a problem, occupation management. He wanted to have price different or occupation different prices. The more full it gets, the more expensive it gets. And the problem is, it's not one client, it's a product. He sells it all around the world. And he asked me, okay, what to do? And he implemented something which was enum based and command based and whatever. We say, look, push the context to NAS1, store the NAS on the database, and you are set. And we were able to remove, I think, I don't know, 500 lines of code and remove it to a simple script. And the great story is there was one table for all the tenants, and it just worked. OK? I don't show you the source code because it's obvious right now. So we have script, is the algorithm, is the context, we get the occupation name or whatever, and each tenant can implement own algorithm. Yeah, it is a little bit nicer because what we did, there was, we just provided the function body and the end, and the middle was just implemented. So just the plain algorithm was actually created, and even it was compatible with Excel. So what you could do, you could use Excel to implement. Why not? It's just the algorithm. And this is also a use case. Before you create your own parser, use NAS1. There's also a swing. Oh, this is what I wanted to mention. A boring swing application, default table model. There were cells. Cells were big numbers. No, how it's called? Big integer. Big what? What is the class with big decimal? Yeah, big decimal. We say, okay, each cell is the big decimal, and what we could do, we name the cells like in Excel, and then we pass this to NAS1. If you say B1 plus, what NAS1 did, it converted the big decimal and invoked the plus. And you find out, right, that it did actually because of auto-boxing. Yeah, but what you could do, you could invoke plus. But anyway, it was like Excel. OK? So this was the TPCamp story. And the last thing was an email, which was in, it's interesting. This was a comment on Google+. And all my Google+ comments are in spam from Google. So they are not accepted, which is, I don't know why. And he said something, and he is actually right. I didn't recognize this. For performance reasons, I only show you the 5 recent entries, because otherwise my server will break. No, my server, the connection would break. And he wanted to see everything. It's like, OK, he's actually right. What I did, I chained nhydrator and SPG together. So the nhydrator connects to a database, pulls everything as JSON, and this SPG gets the JSON, have a simple HTML template, and it creates everything. This is actually this is a true use case of, and we also use this similar things in projects. And I would like to show you how it looks like. So first, there is a script, and what the script does, it uses nhydrator, and it just gets, it gets more or less for each cell in JDBC, the result set gets converted to a row of columns. And this gets passed here. And I can manipulate the columns. And I say, OK, and I would like to write the file index.json. And this is actually a huge file. So if I go here, if I would run this. So now 1,473 articles from my blog. The whole blog was exported, processed by JavaOne, and written out in, how fast was it? 1 second. And this is actually a lot of content. If you go to my blog, this is the entire history from the whole blog. And what happened here behind the scenes? Actually nothing, because it didn't write it as a JSON file. So what I could do, I can fire up the real application. Oh, I have it already. Yeah, it's big. So, and what it creates then, it just extracts the title and the link. Title, link, title, link. And it's fully customizable. And this is the input for SPG, and what it creates is a simple page. So what I did, this was also the flight. So hopefully I have a power again in the flight. This is the best thing on earth. So and now it created, this was the full cycle. Fetch everything from database, JSON. JSON reread and create the page on the fly. So performance is incredible. And the database runs on Docker. I just cloned from my server to my notebook, the database. Yeah. And then if you go here, in one, yeah, it even works. OK, so you see there's a very, and this, I will push it after the JavaOne, you will see the page. So mission completed. But usually, in JavaOne is so fast in my project, there's never a problem. So in all these stress tests, if you have database or whatever, it doesn't matter. If this will be real-time processing, this would be. But if you are in contact, if you put it, if you compare it with I/O, NoSQL, or Oracle database, transactions, whatever, then it doesn't matter whether it executes in 10 milliseconds or 50. If you have to wait 10 seconds for a database. OK, we have 5 minutes to go. So any questions, also from Oracle engineers or whatever? Yeah. What I'm putting in the database, in my case, it's a flat file, the script. In all my enterprise project, it's a database for a reason. So what we always need is kind of management interface. And if it's a relational database, it's very easy to implement. You fire up, create JPA entries from tables, create JSF pages from entities, and you have very, very nice management console. And the problem is if you put it on disk, and the server is far away, you will have to redeploy anyway. So you don't have always access to the server. So I think it's a good trick to store the JavaOne scripts in enterprise project in a database. We always did it. Okay. Yeah. This is what I sent several emails to Jim already, and I had that chat with Attila, and I look at the code, and the code looks already multi-threaded. I don't know whether it is a bug or not. So yesterday night, I looked at the process code, which implementation of the exec, And it uses threads to read the output. But what happens is, if something takes a long time, we have to wait until exec executes, and then we see all the output at once, which is annoying.
No, it's one of these things that we just wanted to keep it simple. And
What we can do, yeah, you sent me the code. But your code was almost identical to the code which is already in JavaOne. Ah, I didn't got it. It's like, okay, you sent me the code, and I went to JavaOne. It's almost the same code. Yeah. But would it be that hard for you to implement it in?
well, I don't know how you could basically see, you say,
I would see every line immediately in the console, not wait until exec completes. Yeah.
so just send things to NAS1-dev.
Could you do this for me? And I will vote for this, and everyone else as well, please. The problem is, what you said is really annoying. So it works, so if you something Docker container can take creation 20 seconds of the base image. So you have to wait 20 seconds and you see all the output at once. This is what he's saying. Yeah. Yeah, of course. But you will find the issue, and Jim will implement this then. Who asked question?
You were showing the NetBeans script interpreter.
Yeah.
Is there any way to like tap into like the NetBeans API and start automating non-editor things, but IDE things with like a natural script or something like that?
To automate NetBeans IDE? Yeah. Yeah, you could absolutely do this. So another project was also extensions. What we did, we've wrapped our API of the server in a simple accessible class, which used JNDI lookup and injection inside. And we passed the class to JavaOne. So basically, in the script had full access to our public API. What you could do in NetBeans, the same. You pass whatever you like in NetBeans to the JavaOne environment and then script the environment. Yeah, of course. Very simple. Very simple. What I plan to do as well, but with Docker is less interesting, is you could do the same with Glassfish. So you can pass the ASAdmin API or Payara to JavaOne, but now with Docker I don't care because I rebuild the Docker and just new image. That's less important. Monitoring will come again. So we will use JavaOne for monitoring. So I can create a JavaOne script, push it to Glassfish, and it will return things which I'm interested in. Okay, other question? Yeah. JavaOne. JavaOne. German word.
Does it also have like the native API, like say, or to manipulate the date, calendar, those things, or for that you get into Java, use that?
Oh, native API. You can native API. Whatever is in JavaScript is in JavaScript. So JavaOne is full JavaScript compatibility. And what you can always do, you can instantiate Java objects in JavaOne. That's what I did with file. You can instantiate local time from Java 8, whatever you like. Then you get Java object back. And there's a way to convert, or not to convert, to convert string, JavaScript string in Java and vice versa. And if you have a Java, you are actually invoking a Java object. Annotated, you could instantiate Java class with annotated classes and usually access the annotation via reflection. But there is no way to put annotations on function in JavaOne, right? But because there is no annotations in JavaScript, so you cannot write annotated functions.
There's no construction in like Java keywords to instantiate it to go to the annotations. I mean, if you use JavaOne, you have this Java word, which is provided by the container. There's no way through these Java words to go to place the annotations.
No, it is. I mean, if I get the Java object back, I can say in NAS1 object.getMethod, get annotation, and you have it. Very simple. So this works. This has nothing to do with NAS1. So a little bit confusing at the beginning. What is Java and what is JavaScript? But all the complex classes are always Java, right? So whatever your scripting bindings is just plain Java class, no tricks. You can. The only thing what is nice in NAS1, if you have something like get name, you can do in NAS1 dot name or array and name. The two. Yeah, and this is really nice. I did it here in the, for this, it was really nice because instead of method chaining, it looked very, very concise. And you have full Lambda support. I saw it already, yeah. Yeah. And someone asked me, is it possible to use NAS1 to use in JSPs? Even cooler, this MVC Java 8 specification 1.0 comes out of the box with NAS1 support. So you can use NAS1 in all the views already. And of course, with this template. So you can use SPG with HTML5 templating on the server, and it's going to execute as Java and as fast as Java. Why you should care? Because server-side rendering is better for SEO. Way better. Any questions? For what?
For the two projects you did like within 12 hours, you mentioned that you did not have time to do the
Stress test.
performance or stress test. So I noticed that when you execute this code, majority of the code basically you are actually executing the JavaScript. So in your mind, you do the stress test, and then basically.
Okay, I didn't create it as stress test from the entry processor. But if you hit my blog, there is a pipeline of filters written in JavaScript on each request. And this is fast enough. So I have to measure, but I measured the performance difference. It was almost no difference. So NAS1 gets how it's called, compiled into bytecode. So at one point of time, it should be as fast as Lambda, right? Yes. So there should be no difference if it runs often enough. Yeah. And it runs since 200 days, so at least should be often enough. Any questions left? Yeah, sorry. Then thank you. See you next year with more use cases. If you like, take a sticker. They are crazy heavy. So stickers would be nice if you could take one.
presentations be available online, later in the week?
Yeah, I'm gonna. Let's see. Are you on Twitter? Do you have a Twitter account? I will post the slides to my Twitter account later today, and I think you can get them off the JavaOne. Somehow you can get them off the JavaOne site. I'm not sure how, but I've already posted them there as well.
Yeah, I was just curious if a lot of all the presentations I've been to, I'll be able to access it. Because I've been taking a lot of notes.
Yeah, no, definitely. All right, hello everyone. Welcome to my session on Safer and Faster, new JDK security features and performance improvements. So my name is Sean Mullen. I'm the tech lead of the Java Security Libraries team at Oracle. I'm also the lead of the OpenJDK security group. And if you want to follow me on Twitter, my handle there is Sean J. Mullen. I tweet quite a bit about Java security. I'll also tweet a link to the slides later today so you can download them if you want to. Okay, I need to show the obligatory safe harbor statement to start things off. So here's my agenda. First of all, how many people are familiar with Java security? Raise of hands. Okay, at least half. So I'm going to start off with a very sort of brief overview of Java security, which will set the stage for the rest of my talk. Hopefully this will be, for the people that aren't that familiar, it'll be useful. The rest of you hopefully will be a nice refresher. I'm then going to talk about secure by default and some of the improvements that we've been doing to make Java more secure by default out of the box, and also some of the challenges that are associated with that. And then I'm going to talk about some of the amazing, and I mean pretty amazing performance improvements that we've been doing, especially in the area of cryptography. And I'll wrap that up and then talk about some of the pretty cool security features we're working on for JDK 9. There's about 7 of them, and they're coming out next year. And then we'll wrap it up with a conclusion and a Q&A. Okay, so this is my one-slide overview of Java SE security. Let's see if the laser pointer works. Yeah, it's working okay. So Java SE security can basically be broken down into 3 different areas. At the bottom, we have Java language and runtime security. Then above that, we have a large set of APIs and libraries. And then at the top, we have a small set of tools. So let's talk about each one of these in a little bit more detail. So the Java language and runtime security component, those are the things, the security features that are built into the language to help you write more secure code. So things like access modifiers, automatic memory management, no pointers, so forth. And then at runtime, there's additional security controls, things like the bytecode verifier that ensures your bytecodes are well-formed, have not been tampered with. And then optionally, you can run your application with a security manager. And the purpose of the security manager is to guard access to your sensitive resources and not allow any malicious code to do any damage. So above that, we have a large set of libraries. I don't know if this is orange or red, but it looks more orange to me. So probably the most prominent component is JCE. That stands for the Java Cryptography Extension. And those are our APIs for cryptographic operations, things like digital signatures, message digests, ciphers, and so forth. To the right of that, we have a PKI component, which stands for Public Key Infrastructure. And here we have APIs for parsing certificates, validating certificate chains, building certificate chains, and so forth. Above that, we have our JSSE component. That stands for Java Secure Socket Extension. And those are our APIs for SSL and TLS. To the right of this, we have a probably less commonly used component. It's an API for the secure authentication and session layer. That's a standard, another standard for establishing a secure transport between client and server. And then finally, at the top, we have APIs for validating and generating XML signatures. We have an API for the standard GSS API and Kerberos. And the last one is an API for JAS, which stands for Java Authentication and Authorization Service. And that allows you to do things like plug in different login modules. You can build up a single sign-on solution and things like that. Now, all of these APIs are designed to be abstract in that you can implement service providers, which implement different cryptographic algorithms or other algorithms associated with these components. So the JDK itself includes a number of service providers which support all of the well-known algorithms. So we support SHA-256, AES, all the recommended algorithms, and many more. But you as a developer can still implement your own algorithm, plug in your service provider, or as a user, you could choose to use a different service provider if you want. So it's very flexible and extensible in that way. And then finally at the top, we have a small set of tools. We have Key Tool, which allows you to manage key stores, create certificates, secret keys, public keys, all that kind of stuff. We have Jar Signer, which allows you to create and verify signed jar files. Policy Tool, which is a graphical user interface for editing policy files. And we have, we reship the 3 standard Kerberos utilities, Kinit, Klist, and Ktab. So that's Java SE security in a nutshell. Okay, so I'm going to start with the first main topic in my talk today, which is secure by default and some of the challenges that are associated with that. So first, I think it's necessary to take a step back and ask ourselves, what does secure by default actually mean? So I went on the internet and I found a couple of definitions. The first one is from Wikipedia, and it says, security by default in software means that the default configuration settings are the most secure settings possible, but which are not necessarily the most user-friendly settings. And then there's another one from OWASP, which stands for the Open Web Application Security Project. And they say something similar. By default, the experience should be secure, and it should be up to the user to reduce their security if they are allowed. They both go on to say something different, something interesting. Wikipedia says, in many cases, security and user-friendliness are evaluated based on both risk analysis and usability tests. This leads to the discussion of what the most secure settings actually are. As a result, the precise meaning of secure by default remains undefined. And OWASP says, it is important to understand that by no means does secure defaults mean turning off all possible network applications or sockets and services, and neither do secure defaults mean a 100% secure environment, but they should ensure the least number of possible loopholes and fewer drawbacks. So what can we take away from this? I think it means that getting to a 100% secure environment is just not realistic. And there are certain challenges associated with this, usability being one. So what I want to do next is look at what are some of the challenges that we face when trying to provide a more secure by default environment. So, challenges. First and foremost is probably compatibility. We try really hard not to break backwards compatibility, but it's not always practical or possible. If there's a security vulnerability we have to fix, sometimes we have to break compatibility. If there's a weak algorithm that's completely broken, sometimes we have to break compatibility. So what do we do in those cases? We try to give advance notice to customers, or we try to come up with a phased approach to give you more time to adapt to those more secure settings. And I'll give an example of how we've done that in the past a little later. Probably closely related is interoperability. So we may want to introduce a stronger algorithm as a default, but if most of the servers on the internet still don't support that stronger algorithm, we usually have to wait till the interoperability risk gets a little lower. Now, thankfully, usually there's pressure from the industry and other vendors and so forth. So usually that interoperability risk goes down quite rapidly, and we're able to make it secure by default with not too much time in between. And then, as mentioned previously, is usability. There's always this push and pull between security and usability. So finding the right balance is really tricky. And then there's one size does not fit all. So Java is used by millions of applications. We basically provide a cryptographic toolkit. So what we'll see later, what we'll try to do is we try to keep the lower layers as flexible as possible, but make the higher layers more secure by default. Phased approach, which I'll talk a little bit about later, some of our ideas for using a phased approach. And then finally, it's just we have to incorporate the ability to quickly adapt to changes. Some of these new vulnerabilities happen overnight, so we have to really react quickly. And sometimes we have to take into all those other concerns I noticed, I talked about previously, but we really don't have a lot of time. We really have to fix that vulnerability really quickly. So it's always a challenge. Okay, so let's talk a little bit about the history of Java Secure by Default. If you go way back, to maybe JDK 1.1 and 1.2, our initial focus was to provide protection against untrusted code. So unsigned applets were all the rage, and we wanted to make sure that those applets, when you run them in the browser, couldn't do any damage to your system. So we came up with the idea of a security manager and a default sandbox policy that only granted permissions that were safe, that wouldn't do any damage to your system. The security manager also restricted access to internal packages, so it didn't allow those applets and applications to use internal APIs that they weren't meant to use and weren't standard. So just to make this point, protection against untrusted code is just as important today as it was back then. But over the years, as the scope of security APIs expanded, so that orange-red layer that I showed before, as those APIs expanded, we realized that new defaults were becoming necessary. Cryptographic algorithms were weakening or becoming broken, so what was secure back then was no longer secure now. We had to do something about it. And especially in the last few years, TLS has been increasingly under attack. There's been a lot of high-profile, very visible TLS vulnerabilities, and we've had to go into emergency mode, act quickly, and provide a more secure experience when you're using TLS both on the client and the server side. So going forward, the module system in JDK 9 will actually introduce additional safeguards. I'll talk about them a little later. And this is not just for code running with a security manager. So those safeguards are going to be enforced regardless if you're running a security manager or not. OK, so let's talk a little bit about cryptography and the defaults that we provide there. So as I mentioned earlier, direct access to cryptographic algorithms via JC we do not restrict. So this ensures long-term compatibility. If your application wants to use MD2, which is totally insecure, go ahead, but you do so at your own risk. We're not going to stop you. We do provide restrictions at a higher layer, which I'll talk about a little bit later. However, in the area of cryptography, one thing we do is we have a set of required algorithms which every Java SE implementation must support. These are evaluated at each major release, and we look to industry recommendations and guidelines to sort of come up with a list of what should be available on every SE platform. So today, if you want to use SHA-256, it's guaranteed to be available on every Java SE implementation. It's part of the TCK. We test for it. So if it's not there, that SE implementation is in violation of the TCK. And then some APIs actually have defaults. So a couple of examples. KeyStore has a getDefault type method that used to return JKS, but in JDK 9, we are changing it to PKCS12, which is a more secure KeyStore format. It offers security benefits. I'll also talk a little bit about that later. So we look at these API defaults over time, and we will change them if it makes sense. Another example of a default API is secure random, the getInstance_strong method. So there's a lot of secure random algorithms. Brad could probably tell you there's probably a dozen or so. And it's hard for the developer to remember every single secure random algorithm. Which is the best? I don't know. So we have a new method. We added this in JDK 8 called getInstance_strong. And it actually reads the secure random strong algorithm security property, which the value can vary per platform, because some platforms have different secure random implementations. And it returns the strongest secure random implementation on that platform. So you can use this method and be assured that you're using the best that's available on that specific operating system or platform. OK, so I mentioned earlier that we do provide protection at higher layers. And I'm going to give some examples of both the PKI and TLS layers. So we basically do this via security properties. We have 3 security properties that control algorithm and key size restrictions. And the values here are shown for the just released JDK 8U65. The first of those is JDK cert path disabled algorithms. And that contains a list of algorithms and key sizes. If any of your certificates violate those algorithms or key sizes, then it will be blocked. Basically, the certificate validation will fail, and you won't be able to authenticate the certificate chain. It also applies to revocation information like CRLs and OCSP responses. And these restrictions are enforced by any other component that uses the cert path API. So TLS, when it's validating certificate chains, it uses the cert path API to do that, as well as when you're running signed applets and signed web start applications, it uses the cert path API to validate the code signer certificate chain. And the second property is JDK TLS disabled algorithms. This is similar to the one above. It contains a list of protocols, algorithms, and key sizes. If any of those are used within a TLS handshake or negotiation, the TLS handshake will fail. The connection won't complete. And then the last is JDK TLS legacy algorithms, and that's a list of algorithms, cipher suites, and so forth. And in this case, the algorithms and cipher suites listed can be negotiated, but only under a couple conditions. Only if they're enabled by default or explicitly enabled by the application. This is kind of a last resort mechanism. So it's if you're connecting to a really old server and it only supports this really old algorithm, then as a last resort, you'll still be able to make that connection. The idea is that over time, many of these algorithms will move up to the TLS disabled algorithms when the interoperability risk has gone down a bit or the algorithm is. Yeah, I can take a quick question, but I'd like to really leave them to the end if that's okay. 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 So here's our restricted algorithm matrix as of JDK 8 and 9 for the cert path and TLS components. On the, let's see if I get this working again. On the left, we have the algorithm and protocol. So we have MD2, MD5, SHA-1, so forth. And then whether it's been disabled in cert path, whether it's on the TLS legacy list, or whether it's on the TLS disabled list. I'm not going to go through this in real detail. This is a good thing to get on the slides later for future reference. We continue to work on this list, so it's not fixed or anything. We'll be adding more algorithms to this over time. One thing to note is MD5, it's been disabled in 9, and it's targeted to the next release, 8U71. So hopefully none of you have any dependencies on MD5 anymore, but be aware that it's coming in January, so make sure you're prepared for it, and that's disabling it in certificates. SHA-1 is known to becoming insecure, especially in digital signatures. So we're looking to industry guidelines, and we're working on a plan for that. We hope to be able to share that with you over the next few months. Okay. Okay, so you can extend those properties if you want, but it's a little awkward. You have to go into this security properties file and extend them, or there's another way you can override them. Another way you can do it is through the algorithm constraints API. So applications can use this API to implement their own application-specific restrictions. And here's an example of extending TLS to restrict certificates with SHA-1 signatures. First thing I do is I create an SSL parameters object. I call the set algorithm constraints method, pass it in an instance of algorithm constraints, and then I override the permits method. The permits method takes 3 parameters, a set of crypto primitives. So this is what's being checked, whether it's a digital signature, a message digest, and so forth. The actual algorithm that's being checked, and then an optional algorithm parameters object. It's very simple here. We just check if the primitives contains crypto primitive signature, and it starts with SHA-1. If both of those are true, then we return false. And when if TLS validates a certificate chain containing SHA-1, it won't be allowed. So pretty simple, pretty basic. Okay, so because TLS has been increasingly under attack, those properties are simply not enough. We had to do more things to make it more secure by default. So let me go through those in a little bit more detail. First thing we did was well, not the first thing, but one of the things we did was we disabled the SSL v3 by default. That is pretty much known to be a totally insecure protocol, not recommended for use anymore. And we did that in January 2015, and we added that to the JDK TLS disabled algorithm security property. RC4 was a trickier one. The interoperability risk was quite high. There were still a lot of servers using RC4 at the time, and we wanted to we didn't want to turn it off overnight because we knew that would break a lot of customers, and a lot of customers would be unhappy. So we did that. We used a phased approach to disable RC4. First thing we did was we lowered the position in the enabled cipher suites. This was done in October 2014 in JDK 8U25. So that meant that higher cipher suites and enabled cipher suites would be tried first, and RC4 would be tried towards the end if nothing else could be negotiated above that. Second phase, we removed it from the default enabled cipher suites. So now an application to use RC4 had to explicitly enable it by either using the set enabled cipher suites method of SSL socket or SSL engine. At the same time, we also added it to the JDK TLS legacy algorithms property, which basically meant it's going to be used as a last resort. And then the third phase, in August 2015, we disabled it by default. We added it to the JDK TLS disabled algorithms property. So there's an example of how we used a more of a phased approach for a high-risk change like RC4. And we believe SHA-1 is going to be, we're going to have a similar phased approach that's a high risk. Supposedly 25% of SSL servers out there still use SHA-1 certificates. So that's a pretty high percentage. Okay, we also try to create secure defaults for our security tools. So when you're using our security tools, you're often creating security artifacts like certificates, signed jars that have to last a long time, maybe a few years, maybe even more than that, up to decades. So we want you to use this more stronger algorithms at the time that will survive those years. So for key tool, we have the following defaults. For DSA keys, our key size in JDK 8 is 1024, but we've bumped that up to 2048 in JDK 9. Similarly, the signature algorithm for DSA, SHA-1 with DSA, and we've bumped that up to a stronger algorithm in JDK 9, SHA-256 with DSA. For RSA, the default key pair size is 2048 bits, and the default signature algorithm is SHA-256 with RSA. So those are still acceptable algorithms to be used as the defaults. And then finally, for elliptic curve keys, we have 256 bits as the default key size, and SHA-256 with ECDSA as the default signature algorithm. Jar signer is similar. We have digest algorithm is SHA-256, the default, and the signature algorithm defaults are the same as key tool. Okay, so a little bit about the module system and some of the security features that are coming in there in JDK 9. So first is strong encapsulation. With the module system, a module's packages must now be explicitly exported for its public types to be accessible to other modules. So here's an example, the java.security.sazl module, and it exports the javax.security.sazl package to all other modules. That means all other modules can read the public types in that package. Now, it may have other packages with public types, but those can no longer be accessible by default by other modules, which is a new security feature. In JDK 8, they are still accessible, but not with the module system. Building on that, qualified exports allow you to export public types to one or more modules. So here's an example, again, module java.security.sazl exports the com.sun security sazl util package to JDK security JGSS. So only that specific module can read the public or access the public types in that package. So that's a nice security feature that provides an extra layer of security. So building on that feature, the module system is going to be encapsulating most internal APIs. And that in more details is defined in JEP 260s. So with a few carefully considered exceptions, all internal APIs inside the JRE will be inaccessible by default. That's even if a security manager is not enabled. When a security manager is disabled, you'll get an illegal access error at runtime if you try to access one of those classes or types. If a security manager is enabled, you'll get an access control exception. And the reason it's different is we want to preserve compatibility. So today, if you do that and those packages are restricted, you get an access control exception. So you want to make sure that applications that were already expecting that exception would continue to work. So here's a little example demonstrating how this works. I have a simple test which tries to instantiate a X509 cert impl object, which is inside a package that has not been explicitly exported. If I try to compile this, I get an error. That package does not exist. I can then use there's a new add exports option to basically tell the Java-based module to export that package to all unnamed modules. And the test program here is part of the unnamed module because it's not part of any specific module. So I get it to compile. OK, I'm all set. Now I can run it without a security manager. And I get this pretty long exception. It says exception in thread main, Java lang illegal access error, class test in module, unnamed module, cannot access class Sun Security X509, X509 cert impl in module Java base. Sun Security X509 is not exported to the unnamed module. So that's a really long error message, but it's actually really useful. It tells me exactly what's going on, exactly what the problem is. So I personally like it. And then just for kicks, we can run it with a security manager, and we get an exception in thread, Java security access control exception, access denied, because we don't have runtime permission to access that class in that specific package. So one other really cool security feature of the module system is the feature to deprivilege modules that do not require all permission. So prior to JDK 9 and JDK 8, if you run your application with a security manager, everything in the Java runtime or in rt.jar is granted all permission. So that's a huge attack surface. Most of that code doesn't really need all permission. It probably only needs a few permissions, if anything. So what we've done in the module system is we've moved a number of modules in to be loaded with the extension class loader instead of the boot class path loader. And what that does is it enables us to grant them only the permissions that are needed and not all permission. So the list so far, I believe this could be evolving, is the following list of modules that have been deprivileged. And this really allows us to apply the principle, the well-known security principle of least privilege, and only grant the permissions that those modules actually need. And this is a real example, the JDK crypto EC module, and we're granting it just the permissions it needs, just a handful of permissions. And it's much more secure than granting it all permission. OK, so I hope that helped. Talked a little bit about our challenges and some of the things we were doing to continue to make Java more secure by default. I'd like to now switch gears and talk a little bit about the performance improvements that we've been adding to Java security components the last couple of releases. So in JCE, since JDK 8, we've implemented major performance improvements to several cryptographic algorithms. Most of these leverage JVM intrinsics. So who here knows what intrinsics are? OK. Not many, 10%. OK. So I myself, I'm not an expert on JVM intrinsics, but I'm going to just kind of tell you how I think it works. If you want more details, definitely go to one of the compiler or JVM sessions, and they'll be able to tell you some more about it. So how do intrinsics work? The hotspot JIT compiler can compile bytecode in two different ways, normal compilation, or it can use intrinsics. And these are actually handwritten assembly code for specific methods that are then embedded in JVM code generation logic. So for some performance critical code, normal compilation is not able to generate optimal code or use platform-specific instructions. So what happens is before compiling a method, the JIT compiler will check if there's an intrinsic defined for that method. And if it is, it uses it instead. And basically, intrinsics allow JCE to leverage ISA-specific hardware-accelerated instructions. And there's quite a few of these for cryptographic operations. And this is how we're able to get dramatic performance improvement on different types of architectures. So a little bit of history of all the improvements that have been using intrinsics. First one came in JDK 8. We added intrinsics for the AES block cipher on x86 systems. That was done as JEP 164, and the title was Leverage CPU Instructions for AES Cryptography. Then a little bit after that, in JDK 8U20, we added similar intrinsics, but this time for SPARC systems. That was for AES, again, AES block cipher on SPARC systems. T4 systems and beyond, I should say. In 8U40, we continued on this trend, and we added intrinsics for SHA-1 and SHA-2 message digests on SPARC systems. That was done as JEP 207, and the title of that was Leverage CPU Instructions to Improve SHA. And for JDK 9, we're continuing on this trend again, and we've added intrinsics for GHash, used in the AES GCM mode, for both x86 and SPARC systems. And we've also added intrinsics for RSA on x86 64-bit systems. That's being done as part of JEP 246 by Tony, right over there. And it's already been actually pushed to JDK 9, so you can actually try it out today. So everybody wants to see performance charts, so I've got a few. So my first performance chart is for SHA-256 on SPARC. In this chart, what we're doing is we're comparing the speed or the throughput of 3 different providers. In the blue is the Sun provider, which implements the SHA-256 algorithm without intrinsics. In the green is the Oracle uCrypto provider. So the Oracle uCrypto provider is a provider on Solaris, which is basically a JNI bridge that then uses the native SHA-256 implementation on Solaris. And then in the red is the Sun provider using the intrinsified SHA-256 algorithm. So as you can see, the intrinsified implementation handily beats the blue one. And it also beats the Oracle uCrypto. Oracle uCrypto almost catches up at larger data sizes, and that's probably because at that point the JNI overhead becomes less of a factor. So this is pretty cool. And I'm not showing SHA-1 here, but you should see similar performance improvements. It's using similar intrinsics. And the nice thing about this is that anything that then uses SHA-2 or SHA-1 is going to have a performance improvement. For example, secure random algorithm, SHA-1 PRNG algorithm shows a 48% improvement in performance. Okay, the next performance chart I'd like to show is for HTTPS, and this is the performance on SPARC. We used a HTTP servlet benchmark that was developed in-house. Response size was 1 kilobyte. Cipher suite used was TLS, ECDHE, RSA with AES 128 CBC SHA. Number of users was 90. Now, as you can see, there's a lot of different algorithms associated in that cipher suite. There's elliptic curve Diffie-Hellman, RSA, AES, and SHA. And that means that in order to provide all those algorithms, we need more than one security provider. So in this chart below, we're comparing the performance of different security providers that we've tested against. So the first row, we're using all Java providers, and none of them have intrinsics. And as you can see, that the performance of that is the slowest throughput. The second row is we're using uCrypto for, I believe, SHA and AES, and then Java for everything else. That's a little bit faster than using the providers without intrinsics. The third one is we're using Java providers with AES intrinsics and Java providers for everything else without intrinsics. And that's a little faster. But the fastest one is using Java providers with AES and SHA intrinsics and Java providers for everything else. That is the fastest performance. So basically, to summarize this, AES and SHA intrinsics significantly improve performance of HTTPS, 99% faster in throughput over pure Java, and much less CPU usage, which is also important. My third chart compares the performance of RSA using a standard spec JVM 2008 crypto RSA benchmark, and this is on Solaris. On the left, we're comparing it on, we're using, measuring the performance on Spark systems, and on the right, we're measuring it on x86 64-bit system. Now, if you remembered earlier, we haven't implemented intrinsics for Spark, but this chart shows that the performance is already pretty good. This is, it's a pretty fast system, but still, it kind of proves that we don't really need intrinsics here. It's pretty good performance overall. On the x86 side, we can see that the intrinsified algorithm is only slightly faster than ucrypto, but they both handily beat the implementation without intrinsics. They're both at least 2 times as fast. Now, for those of you that don't use Solaris, you'll be glad to know that these intrinsics are for x86 64-bit systems. So if you're using Linux or something like that, you're going to see a similar performance boost by using RSA, somewhere around 2 times as fast or greater. So one last chart is AES GCM performance. And this is, again, this is using the work that's in JDK 9, the G hash intrinsics. So on the chart, we have, we're comparing 3 different providers. The Sun JCE provider in JDK 8 GA that has no intrinsics for GCM. And then we're comparing the blue or the purple, which is 8U60. That includes some performance improvements for GCM, but no intrinsics. And then in the yellow is the JDK 9 with the intrinsics. And the JDK 9 implementation is 62 times as fast as the 8GA, up to 62 times as fast as the 8GA implementation. I think earlier or later, last week I tweeted that it was 34 times as fast. Well, I actually underestimated that. It's a good thing I didn't overestimate. So the good thing is if you're using 8U60, you're in pretty good shape. You're gonna get a pretty good performance boost. But still, when JDK 9 comes out, you'll get even a much bigger performance boost there. So that bug will tell you about why 8U60 performance has improved, if you're curious. So pretty cool, a lot of good stuff. Cryptography isn't slow anymore. It's getting faster and faster. So one other performance-related improvement I'd like to talk about is one that's going at JDK 9, and that's improved secure application performance. And what do I mean by that? That means applications that are run with a security manager enabled. So over the years, we've had a lot of users complain, well, I don't want to run my application with a security manager. It slows things down. It's just, I can't take that hit. So what we did was we decided to focus on that a little bit for JDK 9 and see what we could do to make it better. So the area that we focused on was the policy and permission checking area. Much of that code was written many, many years ago. It had not been adapted to take advantage of things like concurrent collections, new things like that. So in a multi-threaded environment, there were lots of bottlenecks and hotspots, and that was affecting performance, especially in server environments. So we went through the code, we reduced or eliminated a number of synchronized blocks, and then we also adapted synchronized collections to use concurrent collections to cache different security objects. We also improved the speed of the check package access method of Security Manager. That's used quite a bit inside the JRE. And finally, we eliminated the name service lookup from code source hash code. That's more of a startup performance improvement, but it's still a nice performance improvement nonetheless. This overall increased the speed and throughput of permission checks. There are a couple of the hotspots that are remaining. We know that stack walking and access control or do privileged are both known to be hotspots. We have some ideas how to improve that. Probably not in JDK 9, but we're looking at it definitely in the next release. So here are some results. Different methods. We use the SpecJ Enterprise benchmark. That's a standard benchmark for measuring performance of Java EE application servers. So we measured that with a security manager enabled, both before and after the changes. And we noticed some nice speed up in the inclusive CPU time of different methods. 22.7% on access controller check permission, 64% access control context check permission, 65% on protection domain applies, 35.9 on permission applies, and 29.6 improvement on security manager check package access. And actually, the overall overhead of enabling a security manager in response time is only 4.68%. So you hear people say, oh, it's 10, 15%. That's not what I'm seeing. I'm seeing 4.68%, which is pretty reasonable. If we can get down to like 2%, I think there's a lot less excuses for not running a security manager. We're never going to be able to get to 0. You know, you can't get anything for free, but we're getting close. Okay, so the moral of the story, Duke running team intrinsics, he wins the race. Okay, so I'm going to talk about my last topic, which are some really cool features that are coming in JDK 9, the next release of Java. So hope you find them interesting. So here are the 1, 2, 3, 4, 5, 6, 7 features that we're targeting for the next release of JDK 9. Each of them has an associated JEP that you can find out more details about them. I've gone over a couple of these before already, previously, so I won't go over them in more detail, but I'll talk about the ones that I haven't talked about yet. So the first, JEP 229, create PKCS 12 key stores by default. The overall feature here is we're going to transition the default key store type from JKS to PKCS 12. This has two benefits, improved security and flexibility. JKS is based on a proprietary format. It's never really, been an industry standard. PKCS is an industry standard. It evolves. It's supporting stronger algorithms. So we really think that's the way we should be going forward. And it's fully featured. It supports secret keys and attributes, certificates, and so forth. And it's also based on a standard, so you're more likely to be able to interoperate with other platforms that support PKCS 12. We've tried really hard to maintain compatibility because we knew that people would have all these key stores that they've created in JDKs that are already JKS, and we didn't want everything to break overnight. So what we did was we added compatibility hooks such that a JKS key store can now recognize a PKCS 12 key store and vice versa. So things won't break if you have different key stores that are already JKS or PKCS 12 and vice versa. So basically, the get default type will now return PKCS 12. And another really cool feature of this is we've added new get instance methods that will automatically probe the type of key store and then return you an object of that type. So you no longer have to know that this is a JKS key store, this is a PKCS 12. We'll figure that out for you. And I'll show you an example of how that works. So here we're creating our default key store type, specifying the default type. If we print out the type in JDK 9, it's going to say PKCS 12. We then continue to load our key store, pass it the file name, and then we specify the password, and now we're loaded and ready to go. Now we can do all of those previous lines, except that print line, with a single call. Just call get instance, pass it the file and the password. This will automatically instantiate a key store of the PKCS 12. It'll be fully loaded and ready to go. So it's quite nice. It's always good to get rid of redundant code. Okay, so the next feature, I've already talked a bit about leverage CPU instructions. There's actually a really small feature there that's really significant and really cool, and that's called improved provider configuration. So some of you may be familiar with how you order security providers today. So it's in the Java security list. There are properties called securityprovider.1, securityprovider.2, 3, 4, 5, so forth. And the JRE algorithm, when it's searching for a specific cryptographic algorithm, all it does is iterate through each of the providers. Says, do you support this? Do you support this? The first one that supports it wins. So most cases, that's fine. But there are limitations with that approach. It's insufficient for providers that offer large performance gains for some algorithms, but not for all algorithms. So a perfect example is in JDK9. We're intrinsifying the AES GCM algorithm in SunJC provider. But the SunJC provider is not as fast as other algorithms that are in the Oracle uCrypto provider. So there's no way we can order those providers right now to get the best of both worlds. We're either going to get we're going to have to take a hit. Either we have to hard code the provider name in our code, which is not really recommended. So JDK9, we have a solution. We've added a new JDK security provider preferred property, which will allow specific providers to basically be nominated or chosen before others. It's a simple property. It takes the name of the algorithm and the name of the provider that you want to always use first. And then if it doesn't find that algorithm in that property, it'll just fall back to the regular search order. So it's quite nice. We'll actually be shipping Solaris with a default value for this property that will give you the best performance overall. Okay, another feature is DRBG-based secure random implementations. Here we're adding implementations of the 3 deterministic random bit generator mechanisms described in NIST 800-90 AR1. So these are new random bit generator mechanisms. They use modern algorithms as strong as SHA-512 and AES-256. Each of them can also be better configured to match user requirements. And support for these mechanisms are becoming very important in some environments, such as the US government. So it's something we definitely want to support going forward. To do that, we had to add a few new methods to secure random to support new DRBG-style operations. And we've also added new APIs for specifying entropy input. So here's a simple example. This one is still under discussion. It hasn't been pushed to JDK9. So it's likely that the API will change a little bit before it's final. So here we create our secure random object, and we specify one of the 3 new mechanisms. One of them is called hash DRBG. Optionally, then we configure that DRBG. If we don't, it's going to use sensible defaults. We'll document what those defaults are. So to configure it, we create a new DRBG spec object with some additional parameters. And then we call this new method that's been added, a secure random, the configure method, pass that in, and then we generate our random bytes as usual. So pretty simple. Datagram transport layer security, that's probably our most significant feature as far as size and scope that's going into JDK9. So here we're extending the JSS API and implementation to support DTLS, which is defined in RFCs 4347 and 6347. Now, non-datagram-based TLS, or regular TLS as I call it, must run over a reliable transport channel such as TCP. DTLS, on the other hand, allows applications to use TLS over an unreliable transport channel such as UDP. And an increasing number of application protocols are using UDP, things like SIP, CoAP, SRTP. So it's really important that we evolve Java to support DTLS, and we've done that. To use DTLS, you'll use the familiar SSL engine programming model. There's an examples of that in the JSSE reference guide. I don't have time to show an example today, but over time, we're going to be updating those guides to include examples for DTLS as well. Okay, I have a couple more features to talk about. They're all in the TLS area. JEP 249 will add support for OCSP stapling to TLS. And that's one that's been on my list for a while, so I'm very happy. This is going to be implementing the TLS certificate status request extensions, RFCs 6066 and 6961. So if you're not familiar with OCSP stapling, there's basically two ways to check if a certificate has been revoked. The first is CRLs, and the second is OCSP. OCSP has advantages over CRLs, takes up less bandwidth than a CRL, and you can often get a more up-to-date revocation status than CRLs. However, client-side OCSP checking incurs significant performance overhead. With client-side checking, the client has to make a request to the OCSP responder, wait for the response, and then verify that response, potentially for every certificate in the certificate chain. So you can imagine what kind of network overhead that adds to a TLS session. With OCSP stapling, the server is now responsible for obtaining and sending the OCSP response to the client. And this has several benefits. The most obvious is performance. These responses can now be cached by the server and periodically refreshed every so often, and then sent to all clients. So instead of each client making that request, the server makes it once, and the client just has to verify the response that comes in. It also has security benefits. So if many of you are staying in local hotels, you've probably used a captive portal to access the internet, where you type in your hotel number or name and you get access to the internet that way. The problem with that is with client-side OCSP checking, you can't check if the certificate has been revoked. There's no internet connection yet. So you kind of get this chicken and egg problem. So who am I really talking to? I could be talking to a server that's using a revoked certificate. I don't really know for sure. OCSP stapling addresses that. So it allows that stapled response to be sent by the server, and then the client can verify it. It also avoids client-side privacy leaks. So with client-side OCSP checking, the OCSP responder knows the server you're talking to and potentially your IP address. Now, the CAs may say they don't do anything with that information, but you never know. OCSP stapling also addresses that. To use OCSP stapling, it's pretty actually easy. On the client, OCSP stapling is enabled if revocation checking is enabled. And to disable it if you want, you can set this system property JDK TLS client enable status request extension to false. So there are basically two ways to enable revocation checking in TLS. First thing is we get our SSL context, then we create a trust manager factory. We want to use the PKIX type, which is the more secure one. And then to enable revocation checking, we can do either two things. If we're using the init method of the trust manager factory, which takes a key store of our trusted root certificates, we want to set the property com/son/net SSL check revocation to true before we do that. Alternatively, if we're using PKIX builder parameters, wrapping that in a manager factory parameters and then passing it into the init method, it's automatically enabled by default. You don't have to do anything. So revocation checking is enabled by default, and you're ready to go. On the server side, it's even easier. All you have to do is set a single system property, JDK TLS server, enable status request extension true. And yes, that's really it. The server will actually start contact to the OC responder, caching those responses, and then if the client requests them, it'll start sending them back to the client. Optionally, you can set other system properties for advanced usages. You can set the cache lifetime, or you can set the cache size, and there's a few more. We'll be documenting those in our security guides going forward. Okay, I have one last feature to talk about, and that's TLS application layer negotiation extension. This is basically, we're adding API support for the ALPN TLS extension defined in RFC 7301, which provides the means to negotiate an application protocol used over a TLS connection. And an important or a critical consumer of this feature is the HTTP2 client, which is defined in JEP 110, RFC 7040. Did anyone go to Michael McMahon's talk before this about the HTTP2 client? Okay, Brad did. Oh, he did mention this extension. That's something that they need. And just a very simple example of how it's probably going to work. It's not quite in JDK 9 repo yet, but hopefully it push it in soon. So on the client side, we're going to get our SSL parameters from the socket. We call this new method set application protocols, and we specify the protocols that we support, that the client supports. In this case, we support HTTP 2 and HTTP 1.1. Optionally, then, we can set other parameters, cipher suites, and so forth. Then we set those SSL parameters back on the socket. We start our handshake. Then after the handshake completes, we call this new method get application protocol to find out what application protocol was actually negotiated between the client and server. So if it's HTTP 2, we might do one thing. HTTP 1.1, we might do another thing. If it returns null, that means no protocol could be negotiated, and then you either have to throw an error or something like that. Okay, so conclusion. Security is still really important. We continue to take it seriously. We continue to make Java more secure, faster, and incorporate new security features. And we really want to let you guys know what is important to you. That's how we actually use that data to help us decide what to work on. So I encourage you to participate on the OpenJDK Security Dev Alias. That's where we do all our work. We do all our reviews of features and code reviews and so forth. And definitely, if you're interested in contributing, you can look at that link at the bottom, which will tell you how to get involved and eventually become a committer and so forth. And just a few acknowledgments. I'd like to acknowledge the Solaris Performance Application Engineering team within Oracle for providing some of the performance charts I showed earlier. And of course, my fellow members of the Java Security Libraries team, Julie Fan, Francis Ho, Jamil Nima, Jeffrey Neiswanger, Valerie Peng, Vincent Ryan, Anthony Scarpino, Wei-Jun Wang, and Bradford Wetmore. These are the people that worked on most of these features, and I would not be able to give this presentation today without them, so thank you. Questions, 3 minutes. If you can speak loudly, I can maybe answer them here, or you can come up afterwards. It's up to you.
If we are implementing our own web algorithm, should this service provider still need to be digitized by Oracle authority?
Yeah, if it's an algorithm that's yes, export controlled, yes.
If it's a cipher
So,
algorithm,
encryption algorithm, yeah.
algorithm, or a key agreement algorithm, yes, you need to have it signed. If it's a message digest, signature, no, it does not need to be signed.
Yeah, those are still in place. Any other questions? Well, feel free to come up and ask questions afterwards. I'm free to hang out for a few minutes.
Welcome to this session about the Java Date and Time API. My name is Roger Riggs. I work for the Java Products Group in the Core Libraries team at Oracle. The Java.Time API was created with the help of Steve Coburn over many years. He developed the JOTA.Time API prior to working on the Java.Time API as part of JSR 3.10, and I helped integrate it into the JDK and get it to be part of JDK 8. So today we'll do an overview of the basic core API that supports ISO time zones. We'll look at the calendar neutral API that supports regional calendars for Japanese and Thai and the Islamic calendars. There's a section on formatting and localization, and then we've got a section at the end of ticks and trips. Some of this will be familiar. A lot of the material is very similar or identical to last year's, but we've got a new audience, so it should be interesting. The presentation is informational, so I hope you take away something useful and can make use of it yourself. The JSR 3.10 started actually now quite some number of years ago by Steve Coburn, and it went through a series of iterations as part of the JSR process. He took a lot of the basic information and the knowledge expertise that he'd gained from working on Java Time APIs and JOTA.Time in particular to form the new Java Time API. It was released as part of JDK 8 last year, and it's been very successful since then in being a replacement for the sort of aging and problematic APIs of Java Util Date and Java Util Calendar. Both of those APIs are still present in the JDK and probably will be indefinitely, but they each have their problems, and many of you probably experienced them firsthand. So there are 5 packages as part of the Java Time API. For many uses, all you need is the basic Java.Time package, which includes classes to support local times, local dates, dates and times, zone dates and times, which sort of brings it all together, and then the concept of clocks, which can be system clocks or there's some clocks you can use for debugging. There are types for durations, a period of time, or durations, period, zone IDs, and then individual types for day of week and month, et cetera, and we'll see more about that. The second package is dedicated to formatting. There's a new formatting package that is sort of predictable and immutable so that it doesn't have some of the pitfalls that exist in the current date and time, the previous date and time formatter, and we'll see more about that. And there's a separate package for the detailed time zone information if you want to know when time zones are going to change or compute things elsewhere. There's access to the time zone database. The fourth package is a package of calendar neutral APIs. There's a framework to be able to create arbitrary calendars, and then the JDK supplies 4 specific calendars, regional calendars that are sort of the most useful and widely used globally. And finally, there's a package that includes a lot of the types that are used to build the framework underlying the Java Time API. There's quite a bit of extensibility possible within the API, and this framework package provides the basic fields and types you need to do if you wanted to extend it. Most users will just be able to use the core package and be very happy with it. Here's a quick summary of the sort of the core types for local times and the fields that are in each of them. Obviously, it's pretty straightforward. There's no real magic to the date and time in terms of the fields that are needed or how they're mapped to strings. There is a distinction between what's sort of human time types, the date and time, local date and time, et cetera, and machine time. The instant at the bottom is dedicated to sort of to a particular sort of machine time. It has no it's seconds since the beginning, since 1970, and nanoseconds. It doesn't know about months. It doesn't know about days, years. It's not customized to a particular calendar. It really is just an instant in time. And there's ways to map between them to make it easy to use. But it is, if you want to put something in a log, using an instant is the way to do it because it won't shift around based on time zones or where you are in the world. Just to compare sort of the current Java Calendar API, date APIs versus the new Java Time APIs, they had suffered we picked up sort of a set of new design patterns that make the types be immutable, fluent, so you can string together a series of method invocations. They're thread safe, mostly by virtue of the fact that they're immutable. And there's strong types that are fit for particular purposes. In the Java Util Calendar API, there's sort of one basic type that had a lot of state in it. It was mutable. You had to worry a lot about if somebody else changed it and the interactions within the type. So we'll see how all of that plays out in the new API. Just to sort of give you a mapping of the Java Util Calendar types to the Java.time types, the ones on the right are mostly calendar and date because they only had a few types in that API. On the left are things like instant, which maps directly to a date, which is just milliseconds, local date and time. The more interesting ones are down in the middle where we want to talk explicitly about time zones, zone offsets, and the rules around time zones, maps to the time zone class in the calendar package. A couple of specialized enumeration types for months and days of the week. We think it's an improvement to use the ISO 8601 calendar and to map, to have the week start on Monday with the number 1 through 7. The current Java Util calendar starts at 1 through 7, but they start the week on Sunday. The international standards in ISO 8601 seem to prevail and be a better base to work to build out of Java.time. Similarly, the months run from 1 to 12. It seemed more natural in terms of what people use than the 0 to 11 counting in the calendar API. So that's sort of basic framework for types. One of the big things in any new API design is naming. So there are quite a number of naming patterns that were present in Java.time, and as we iterated through the design for Java.time, it was really valuable to be able to have a consistent use of these sort of keywords in every API. So for example, in any of the static factories that creates one of these type, the of method, it always takes its arguments and validates them and produces an instance. It's consistent regardless of which package and class you're talking about. Similarly, the from method takes data out of an existing object and creates a new one, possibly transforming it. Some of these are sort of self-evident, but they make the API very usable. And in the case of you're using an IDE, it makes method completion be very, very easy and it leverages the tool to show you the possibilities when you're trying to write code to these types. So just a quick example, sort of side by side between the Java Util Calendar, existing ones on the right, and the Java.time API on the left. The current calendar API is very field-based, and so there's get methods with particular fields. The pattern on the left uses individual methods for the different fields, and since they all return well, this is get, so they return the values that you're interested in. Most of the API is fluent, so the return type can be passed on, and we'll see that in the next slide, where instead of, since all instances are immutable, the mechanism for creating, for setting a field really produces a new instance with the one field that you're trying to modify, or that you want to modify changed. So the with method name, all the methods start with, replace some field in the object with and return a new instance of it. So for example, here in the zone date time, you want to, with second number 1, it'll reset the second field. It's fluent in that it returns, each of these methods returns the same, it returns this, so it returns the same type, and you can chain them all together. There are the usual set of arithmetic operations on time for adding and subtracting days, months, nanoseconds, and the underlying calendar does all the right arithmetic, as you would expect. So the API is just a little different, but it has the desired effect. We'll come back to some of the details related to the calendars later. Here, we're going to jump in and talk about the calendar neutral APIs and the regional calendars. Besides the ISO 8601 calendar, globally, there are quite a number of other calendars that are used regionally, And at least for Oracle, it was very important that we be able to support the calendars, in the native calendars. Anybody who's worked with date and time for very long knows that there's a lot of different calendars, and they have different rules about. Some of them are pretty wacky in terms of, there are 13 months in this calendar, or the number of, there are, in one calendar there's 12 months with 30 days, and then there's 5 or 6 extra days that are somewhere in the calendar. So part of the API design was building a framework that could allow the introduction of a particular chronology and then build on top of that chronology to build an API. So the assumptions that have showed up in people's code earlier about the number of months in the year or the number of days in the week, which actually is pretty constant, so that's not less of a problem. But assuming, for example, if you want to advance to the next year that you add 12 months, that's not really valid when you're working with a wide variety of calendars. So the calendar neutral API is focused on, it's a slightly different model of the calendar, but it's focused on making sure that all of the primitive operations on the calendar elements are handled by the implementation so that the mathematics of the calendar mathematics work out correctly. And part of that is introducing a chronology type, which sort of represents all of the particular calendar mathematics under the covers. So here we'll compare using the current calendar API, which also does multiple calendars, but it does it based on locale, and there's some subtleties in using it, with the java.tame API. So in both cases, you can find from the current locale, you can find the appropriate calendar that you want to use, looking up the chronology. On the left-hand side, from the chronology, you can ask it to get the current date, date now, and it returns a chronolocal date, which is independent of in the current calendar, but it doesn't really tell you what the calendar is because you've looked it up. It's sort of very abstract at that sense. The access to the fields in this calendar are more field access like the current API. There was sort of a deliberate design choice to make the regional calendars have a different feel to them, partly to get people to use the ISO calendar predominantly and not be distracted by the regional calendars unless they really had a strong requirement to use them. So at the bottom, there's an example of being able to get from a current date to the next month by setting the day of the month to 1 and then adding a month to the value, and you get to the beginning of the next month. Similarly, on the right, you would have done that by by setting the fields in a calendar object, and under the covers, it will do the right math. So even with regional calendars in the calendar neutral API, you don't want to be able to handle time zone differences and be able to handle the time zone changes. So there's the names get a little bit long because there's more and more functionality being layered on. The chronolocal date is a generified class parameterized type that embeds a date. With the regional calendars, the time elements are the same worldwide. Fortunately, we're good for 24 hours a day and 7 days a week. But the date is parameterized. So with the chronolocal date time, you get to embed, you have a type which represents a particular calendar, though here it's wildcarded because we don't have any static type information about what the particular calendar is. You can extract the local time or the date out of the chronolocal date, the sort of holder of all the pieces. You can, the at zone is one of these modifier methods which says, I have a date and a time, but I want to associate it with a different time zone. So it returns a chronolocal zone date time, a chronozone date time. They do get a little bit awkward, but the naming was important to be able to communicate everything that was buried in the. And then finally here, the example shows setting the time to midnight in whatever that date and time was. So all of the types do have two-string methods, so they produce some output in some format. As usual with two-string, it's sort of for debugging. It's not the official format for something. And it's better that you use the deliberate formatters for that. As I mentioned, both the current JavaUtil calendar and Java.time use sort of a field-oriented access to the values in a particular time element. It just sort of compares the naming between the two. The types are all disjoint, so you won't really make any mistakes in mixing them up. Here's an example of being able to look at the regional calendars that are embedded, that are implemented as part of the JDK. You can enumerate all of the chronologies that are supplied. The API is extensible, but there are built-in implementations for the Islamic calendar, the Hajj calendar, the Thai Buddhist calendar, Japanese calendar, and in Manungo, as well as the standard ISO calendar, which fits neatly in under the API of the calendar neutral. So there you can convert easily back and forth between the regional calendars and the ISO calendars as needed. So in this example, we're going to, chronology.of looks up the Hajj calendar, and then there are two ways to look it up. You can look it up by sort of its common name and by its CLDR name. There's sort of this dichotomy of naming that comes out of all of the databases that come along with the common database, locale database. The other ways to select the chronology are to look them up using the BCP47 encoding of locales. There's sort of the current system, there's sort of a lot of ways to get to the right calendar depending on the context that you're operating in, and all of them are supported in the new API. And once you've got a chronology, you can create a date at a calendar neutral date based on the proleptic calendar, which goes based on 1970 and is sort of a common thread between all the calendars. There's also support for the Japanese date and the eras. The Japanese calendar is a little bit unique there in that they started the calendar over again to match up with each of the emperors. So the concept of an era comes into play in the Japanese calendar more significantly than in the other APIs. Here it shows an example of using the BCP47 syntax to look up the locale and then deriving the calendar from that. You can also just use the explicit types for the Japanese date and Japanese calendars. And if you're writing an application that runs specifically in that environment, using the most specific concrete types is preferred because you're being as specific as you can in the code. It'll be easier to read and easier to maintain. There'll be no sort of confusion about, well, which kind of calendar system is this? It's very explicit. There are other examples here of just using how to build the types from the basic Japanese date into a local date and time, or a Japanese date and time with the time, or adding a time zone to it. And in this case, you can see that it is the parameterization of chronozone date time can express the fact that the date is a Japanese date as you manipulate it, and the type system sort of supports all of that. The bottom of the page has an example of the format, using the formatter to take the particular date and time and construct which we'll see some more formatting in a minute. You can construct a formatter from a pattern, the usual set of pattern letters, and associate it with a particular locale and print it out in sort of the very locale-specific result. The code on the right is just what you would, a similar sort of equivalent code if you're using JavaUtil calendar. I'm sure that there's people who've done this will find some of this familiar, and they probably use slightly different techniques to get to the similar result. The Islamic calendar is another one that is important in the Middle East for quite a number of sort of commercial uses. It's a little bit more idiosyncratic than some in places, but it has one significant value that's global, that's worthwhile globally, which is it's a lunar calendar. It's based on the phases of the moon. So if you're ever curious, if you ever need to do some computation where you sort of want to know what the phase of the moon is, you can take a date, convert it into the Islamic Hajj calendar, and pull out the month and where you are in the phase of the month. So even if you're not, if you just want to get a good fix on what the moon is doing, the Islamic calendar can really help out there without reverting yourself to all the computations about, well, where is the moon today? It has the same characteristics as the other APIs, where there are specific types for the Hajj date and but then the time and the calendars fit right in, and the chronozone date time aggregate type can express the fact that there's a Hajj date nested inside of it. And obviously all the formatting works in concert with all the locale information that's embedded within the JDK and every runtime. So let's move on to the formatting package, which is the other sort of powerful addition to the API. There were sort of in reaction to a lot of the problems with simple date formatter. JOTA-time also had a lot of these the same capabilities for being able to create a formatter. Creating the formatter is essentially a template for mapping the fields of an object into how those should be represented in text. Formatters are used, the template applies both for printing and for formatting and for parsing. So you can print something out and parse it right back. The templates, the date time builder can embed obviously literals. It can embed numeric values that are taken from a field or that when they're parsed are set into a field, along with the requirements for, is there a leading sign, are there leading zeros, how wide is the field, etc. The formatting characters also, formatting primitives that are assembled into this template also have access to all the localized formats that come along with a locale. For example, is the month a one character or two character month name or the day of the week? What are the actual values that go along with days of the week in a particular locale? So there are a bunch of, part of the power of the formatter is that it uses the lookups of the current locale information to both parse and to print. You get control of fractions and printing, and there's some specialized functionality for zones and for instance. Now we'll see some examples after a couple of more aspects. So you create a template, this template parser, and then while it's actually parsing, you can control whether the strings that are found are case insensitive or case sensitive. You can express the fact that there may be optional fields in the input. If you're parsing something, then you can express as part of the template that this part of the input may not be present, and there's some ways to default it, and we'll see details in a minute. And then there's a setting for strict or lenient parsing that allows the parser to be, well, lenient in the case of if you're trying to read in the month of a date for the month, day of the month, and it's in February, and somebody types in 30, you can tell the parser that, well, it's okay. He meant the end of the month. So the lenient will can help pull the data back to what the calendar really expects. And then another powerful piece of the formatters is that you can, since they're sort of field-oriented and templates, you can concatenate them. And so if you have a really complicated set of parsing you need to do, you can build it up from the pieces and assemble them. So let's see an example of using the formatter builder to parse a time where the time is 1 or 2 digits, and then there's an optional pair of colon and minutes, and then another optional for colon and seconds. And in this example, so it's pretty straightforward that you append the notion that there's a value that comes from the hour of the day field. The width is a minimum of 1 and a maximum of 2. And in this particular case, there's never any sign. So the parser will not accept a sign and won't take it into account. The optional start is a trigger into the builder to say what follows may not appear in the input. If there's any sort of parsing failure after that, it's okay. We'll just sort of skip it. And we're going to first look for the colon, the fixed field of the literal for the colon, and then parsing the minute of the hour. So it specifies exactly which field the value will go into, and it's 2 characters wide. And then the next little bit is sort of the optional, building the optional piece for the seconds field with a colon and optional parsing something into the seconds, and then ending the options. So that gets you something that will parse most of the fields, but if the minutes or the seconds isn't present, then what value does the field have? So there's additional ways to default a particular field if it hasn't been encountered in the input by that point, to default it to a particular value. And then at the end of it, since we're in a builder pattern, the last thing is to actually create a date time formatter from the builder. So then there are a couple examples here at the bottom that if you have just the digit 9, it parses out the full time. Since there was no minutes field in that input, it defaulted it to 1 and defaulted the seconds to zeros. So this model of assembling a template as part of a parser is very powerful. Similarly, the same template is used on output. So if you go to format something, a date and time, or a date in this case, or time in this case, it will produce the right output. So you can do, it's symmetric. There are quite a number of sort of different pattern, sort of a lot of formatting things are based on pattern letters, and there's at least 3 different systems of pattern letters. This is sort of a too dense chart of the mapping between the formatting characters that are used in JavaUtil format, those used in the simple date formatter, and the ones used by date and time, the date and time formatters. But there's quite a bit of breadth and options there. Part of adopting the Java.time API was figuring out the relationship between the new APIs and the new formatter and the existing date and time calendar classes and those formatters. And we wanted to be able to have a bit of crossover in both directions. So the JavaUtil formatter was modified so that it will accept as input the new date and time types, anything that's a temporal. I didn't mention temporal, but all of the date and time types are sort of have this temporal interface which provides field access. So with the standard string.format call, the JavaUtil formatter, you can use the new date and time types. You don't have to go back to calendar. So that's easy to use. If you've got a bunch of formatting code that uses these rather cryptic % and $ strings, and you don't want to change it, you can still use the new date and time types to keep track of time in the calendars effectively. There are, as part of the formatter package, a set of predefined templates for parsing dates and times that have familiar names. Many of them are most of them are ISO based, but any application can create their own if there's one of the predefined ones doesn't suit it. There are also the first one on the list in the upper left finds formatters based on the current locale. So some locales are configured to have the short form of the day of week is 1 letter, and this particular letters are filled out there. So there's a way to look up all of the locale sensitive format strings and use them deliberately. The formatter, as I mentioned, is very powerful. There's some examples here of using the different predefined formatting patterns, or building your own with the from of pattern. You can build formatters that have both literals and field accesses and so it's very convenient to get the right kind of format that you need for your application. The other aspect that we wanted to be able to do was to be able to have the new date and time formatters be used with existing calendar and date types. So that people could get away. We've had problems with simple date format and its statefulness have a place to go. So the technique here is mostly that from a calendar instance, there's a method on calendar that will produce a zone date time. So it will convert from from the old form of the API to a new instance, which then can be used with the new formatter. You get the same results, but you get to switch and use the new API a bit more flexibly. About the time we were developing this, JavaFX was filling out their set of controls, and we had some help from the JavaFX folks to embed a date picker that uses the Java Time API. And they came up with one that's really powerful that allows you to pick which chronology you want to use. And they show you the calendar in the right format and everything. So we were very fortunate that that's now part of FX built on the new date and time API. And I haven't used it since 2013, as you can see from the slides. So that's sort of a little bit of a lightning overview of things. Part of the experience of using the date and time APIs is helping people convert from their existing code to the new code, and to pass on some observations about the sort of problematic areas that show up in applications. So here's just a few tips and tricks. One of the things about an instant is that the comparison between a date and an instant, they're sort of the equivalent types. They both have just a spot in time without really any notion of time zone that's really robust. So if you're converting, you can convert easily from a date to an instant. But if you want to convert instance into a zone date time, which has a full sort of human time, you have to remember that an instant doesn't have a time zone. And so converting from an instant to a zone date time requires that you supply a time zone. Sometimes it's as easy as saying, well, that's GMT or UTC, but it still needs to be an explicit step that an instant is converted to sort of human time with a specific time zone. There are a couple of ways to do that. The instant.atZone method will return a zone date time with a particular offset in this case, or you can create a zone date time from an instant with supplying also the time zone. But one of the more powerful methods in the API is the from method. It shows up on a lot of different types. But if you try to create a zone date time from an instant, it will valiantly attempt it, but when it looks inside the instant, it can't find the time zone, so it throws an exception. Maybe the exception message could be a little more informative, but there are some types that you just can't convert between because there isn't enough information. We saw that if you've got a Gregorian calendar, so a Gregorian calendar actually has a specific calendar. Just the calendar type itself, the static type, doesn't really tell you what calendar it's working with. But there are methods on Gregorian calendar to convert to and from from zone date time to make it easy to get back and forth. So one of the questions that came up was, well, how do I format durations? The formatting package is very good for full date and time or for pieces of it, but it doesn't have a good model for duration. And the normal duration, according to the ISO spec for duration, has this sort of awkward PNT, a period, a time, hours, minutes, and seconds syntax. So this is just a quick tip to say, well, if you take the duration and you add it to midnight on the day, just working with the time, you can get it back into a time of day, which then is easy to format however you want using the normal formatting characters. And maybe that would be obvious, but there's one question that came up. So another problem that some people had was when they've got some input and they don't actually know, it's not sort of clear exactly what format it is, so they wondered whether the parsing mechanisms could deal with, disjoint but separate forms of input. With using just the pattern letters, the square brackets are another way to say the start optional, end optional piece that I introduced earlier. So you can actually provide a pattern, a total pattern that consists of each of the patterns you might recognize being optional, and then tell it to parse some string, and the parser will valiantly try to parse each of them according to the inner pattern, and if one of them succeeds, it's done. The only sort of wacky thing here is the patterns have to be disjoint. You have to be able to tell from the input. In this case, they use, hyphens are used in one case, slashes in another case, and then just the numbers in the last case. It's a bit of a hack. There may be some room in the API to try to come up with a more explicit sort of exclusive OR of parse this or this or this formats. We'll see where that goes. Another use of the API is trying to figure out, sort of digging around in the time zone database. So here's a quick example of using the time zone class. We'll start with the current time. We'll get the zone ID from it. There's a set of rules that are data configured from the time zone updater format that define when all the transitions are in each of the time zones. You have to look up the set of rules. From the set of rules, there's a method that says next transition, which is really convenient because if you pass it an instant in an instant, it will find where the right spot is in the current set of rules, and then from that you can get the duration of the time zone change event and the date on which it would occur. And the rest of the code is just sort of printing the format.
How the rule get updated? If the country change, some country change their visualization, how the rule get updated?
Okay, so today, this code uses the same database that's embedded in every JDK. So there is a time zone database, TZDB, that is it's a data file that's in every JDK. There is an application called TZ Updater, which is available, I think, for every version of the JDK that installs a new version of the time zone database. So it's at the moment it's a sort of a manual step, right? Because you want to be very careful about in your application environment when the time zone data changed. We did spend in the JSR, or when we were talking about it, quite a bit of time in saying, well, how real time can we make the updates to the time zone database? But there are problems of expressibility of, in your code, what are the assumptions around holding a particular time, and if the time zone database changed underneath you, what that means in terms of the semantics of the API. So at least in the current implementation, we don't deal with that. The updating the time zone database is an explicit action that happens as a management function. Yeah. How do you guys handle leap seconds? Caught me. Well, so leap seconds have been a problem, and through many layers and sort of gnashing of teeth, and a lot of other sort of conventional usage, it didn't seem useful to expose leap seconds in the APIs. In particular, so the Java Time API is built on top of the operating system's notion of time, which frequently is built on top of some basis of network time. If we were to go out of our way to try to expose leap seconds in the Java API, we could potentially get out of sync with what the operating system thinks the time is. And so that would pose a problem. And you certainly don't want two applications, one of them running at the operating system level and then running in Java, to get different ideas of time. So effectively, we dodged. We said the operating system has to produce a sensible version of time. it seems like in many cases the sort of adopted practice is around leap seconds. There's actually been several protocols for defining this, but you want the network clock to slowly mush the time, either accelerate it slightly over the last 20 minutes of the day, I think is one algorithm, and then so that it approaches, it's not the true time, but it's close enough to keep applications from getting all upset about time jumped, right? You want to avoid the discontinuity. So I believe like the Google time server uses an algorithm to smooth the actual, real time versus an atomic clock is different over, across where a leap second would occur. I'm not sure that's an entirely satisfactory answer, and for somebody doing scientific computation or knowing exactly where, the planets are, it's not going to be satisfactory. But for most application uses in systems that all have to sort of be consistent, it's a much better model than trying to say, this API has to expose the fact that there will be a leap second event. Actually, I think there was one in June this year, or July 1st, sorry, July 1st. So we ducked, but it was convenient, and I think it makes things easier for everybody if you don't try to push that leap second handling into everybody's app. Okay. So there's ways to get visibility into this time zone database if you need it. Mostly you won't. It is used in the computation of all the time zones and the zone IDs and mapping back and forth. Another important topic is comparing dates and times. The sort of the normal. There are sort of three sets of things that work together. The object.equals method usually is a very simple thing. It says basically the classical definition is all of the fields of each of the objects are the same. The values are the same. The compare to interface allows you to say an ordering, but it's based on the same model where there's some set of fields in each of the objects and the fields are compared, and if there's some sequence of greater than or less than that makes sense. Now with time, and especially with time zones, you can't just compare the fields because some times actually have there's two different kinds of offsets. There's a zone offset, which is actually some number of minutes from GMT, and there's also the zone ID, which is more of an abstraction that's looked up through the time zone database. So the field-by-field comparison doesn't really work for time. And the primitives that you really want are things like, is this time before that time or after that time? And effectively, those operations, those methods, convert everything to an instant globally, worldwide, and compare the instance. So it deals with, is my time zone New York, this time zone New York, and that one be London? And it will really sort of dig through down to the instant value level to say whether something is before or after. And it was another sort of problematic place in the API. We really wanted it to be that compare to would be timeline order. However, the convention for the comparable interface is such that it was really a field-by-field comparison. So there's two sets of compare operations. And when you're comparing times, you really should use the is before, is equal, and is after methods, or use the comparator that are supplied. Sort of a quick example of where this can bite you. In this example, we'll take the zone ID of New York. We'll find the time now. We'll turn it into a zone date time, so it's sort of fully qualified. And then we'll pull out the time zone offset from that time. I work on the East Coast, so New York is a more familiar city for me. But it comes up with a fixed number. If you create a different zone date time with that offset, zone offset, and now run the comparisons, you'll find that object equals says they're not the same because a zone offset is not the same as a zone ID. The type is even different. Compare to also has the same problem because a zone ID isn't the same as a zone offset. But if you use is equal, it will convert them both to instance and compare the instances, and you'll get the desired notion that I think when this was written, that's off by 4 hours, or that New York is in the, with the time zone of America and New York, it's 4 hours off. It really is the same time, but it's not always sort of literally equal according to this. And maybe I've belabored that too much. One of the powerful features of the framework that underlies all these times is this notion of temporal adjusters. A lot of the types, the underlying mechanism is referred to temporal because it has to do with time. And there's an interface that provides access. So a temporal adjuster is basically a function that can be applied to any date and time to compute a new date and time. So there are a bunch of them that are supplied as part of the API, as part of the implementation. For example, I've got some date and time, and I wanted to move it to the end of the month, the last day of the month. So there's a predefined temporal adjuster that looks at that. It's a piece of code that looks at the current date and finds the last day of the month. Similarly, there's one that says, find me the next day of the week or the last day of the week. Or actually, in this example, it's find me the last Friday of the month. And you apply the function to a date, to either one of the powerful things is it can be applied either to just a date, a local date, or it can be applied to a local date and time, or a zone date and time. So there's the same function that, because it's looking at the underlying information embedded in the object, the same function can work whether it's dealing with just a time or just a date. Actually, this particular example of last and month can only work with dates because the time is irrelevant for its function. So functions can be created to go forward or back. There's a previous Wednesday. Real simple, it's really simple, for example, to compute when Thanksgiving is here because there's a predefined temporal adjuster that will find you the 4th Thursday in the month. The temporal adjuster framework is extensible. You can write your own, and we'll see here that it's a little more complicated because you have to delve into the underlying representation. I had this questions like, okay, so when do I get paid next? Well, paydays are the 15th or the last day of the month, unless either of those days falls on a Saturday or Sunday, in which case it's the previous Friday. So this temporal adjuster gets passed in something that looks like a date. The algorithm it uses is to advance by at least a day, but skip Saturday and Sunday. So we always start on a weekday, which is a plausible payday. Then we're going to look to see whether we're before or after the 15th of the month. If it's before the 15th of the month, then the payday is the 15th. If it's after, then it's the last day of the month. So part of the meta information that's available for all of the types is this, for each of the fields, you can ask, what's the minimum and the maximum value for this field? So here it just asks, what's the last day of the month in this particular type? So now we've got a date which is either the end of the month or the 15th, and there's a final sequence to go back and say, well, if either of those is Saturday or Sunday, then we need to subtract a little bit to fudge back to the Friday. But you can write this, you can write it as a temporal adjuster. It's reusable, and there's probably plenty more possibilities in a particular application to build chunks of functionality around dates and times. So Jota Time, I think, is still pretty widely used. It's not like it's going to go away. It's a very good package, very, very functional. It's got a lot of use. So we want to encourage people to use the Java Time API that's in the JDK. So just some notes. Many of the existing method or classes in Jota Time also exist in Java.time. They're pretty directly mapped for local date, local time, local date and time. There's some other renamings that happen to make the Java.time APIs more consistent. There are a few differences in functionality. The Jota Time period goes all the way from years down to seconds. The Java Time one is just dates. And there's some name changes. Duration is the same. But Java Time is, well, thanks to Stephen and the work that we did developing the API, the Java Time API is sort of easier to extend than Jota Time and easier to customize. At least that's an opinion. So just very quickly, recap. The Jota Time API, most of the types are immutable. The design is fluent, so it's easy to string things together and make it easy to read. It's thread safe. The types that are provided are specifically designed for particular purposes, so there's no confusion about something that is, is this here because it's a date or is this here because it's a time? Or if I have a credit card expiration, which is a month and a year and a month, well, there's a day thing that I'm supposed to ignore, but not really. So there's actually is a month-year type. So there's specific types that are specific to purposes. There's extensibility for both the units and the fields it can be embedded in a time. So we haven't really had an occasion to use that, but if you need something besides nanoseconds and milliseconds, you can create that, and it'll factor into most of the computations. There's a lot of interoperability between JavaUtil calendar and date and the new APIs to make it easy to transition and to make it easy to cross-use the formatters and the data types. The regional types are useful in a lot of parts in the world, maybe less so here in the US, but there's a lot of value there, and in the calendar neutral API that lets you build a new calendar that will that'll fit into the same environment. And obviously the core packages, the basics that you need for building an ISO calendar in the global business community. And if there are any questions, I'd be happy to answer. There is some reference material online. I think some of it may be a little bit dated. There is a tutorial that was put together by the Oracle doc writers. The Java doc is in the standard places for JDK 8, and there are some additional links to JSR 3.10. There is I guess it was sort of called a backport. There is a version of an API very, very similar to this that's usable with JDK 7, I think, but it's not identical because of sort of various standardization issues. Yes?
Can you say anything on the performance of the new JTime API? Because the old JTime API was notoriously slow. How is that with the new?
So we didn't, it's better. In fact, I think it's vastly better. I don't think I can point to specific statistics where we've done a side-by-side, but nearly all of the operations that you see operate on just a couple of fields to do what they do. The things where things wrap around, the comparisons, especially since the core API is not trying to do every calendar and every different calendar system. The code is written, the ISO calendar is written, for ISO. So there's very little indirections and ambiguity. Probably the only downside of it is because every type is immutable, it's likely to produce a bit more garbage. It's not garbage if you're still using it, but it may use more memory. Yes?
Are you adding anything in Java 9?
There'll be some small things and corrections in 9, but nothing major. There aren't any new calendars on the list. If there's some need that you think is there, let me know or file a bug. It's pretty complete.
So how many time zones are there? Do you guys have a thing to fill in a drop-down list or something?
Well, there are as many time zones as the time zone database says there are. So there's at least 24, but there's more than that. I mean, all of the named time zones that are in the time zone database are accessible here. So, yes?
Is there anything that's added that would notify your application if the underlying system costs change?
No, we haven't tried to surface that. I'm not sure how you could do that reliably without sitting on top of it and knowing that it was changing. And having some independent notion of time versus the system clock. Do you have a particular application for that in mind, or just it's a worry? Yeah, I think in this case, you're going to need to build that into your infrastructure, not. Now, one of the things you can, that you could build pervasively is the notion of clocks. So all of the types that you get at, like, there's a clock, the clock is an abstraction, and you potentially could build an implementation of a clock that kept track, that followed some other time source. Then in your application, you would need to consistently use that clock to create instances of, like, now, time.now, so that every place where you needed to know what the current time was, you got it from your clock source. So there might be something there where you could leverage that within your app to hook your abstraction for what the underlying clock should be to the rest of the system. All right, anything else? Thank you very much.
Good afternoon. Welcome. Thanks for coming. My name is Stuart Marks. I work in the core libraries team in the Java platform group at Oracle. And I'm appearing today as my alter ego, Dr. Deprecator. And so thanks for coming to hear about deprecation. So here's the standard Oracle safe harbor statement. The fact is, even though deprecation seems like it's about old stuff, there actually is development going on in this area. So I will be making forward-looking statements about future products here. So this is actually serious. So in contrast to other talks that I've given and that others have given at JavaOne, where all the new technology talks are packed, you are the dedicated few who talk about the trailing edge of the technology lifecycle. And that is very, very important. And in fact, most people underestimate its importance. So thank you for coming here. It's very important, and I'm glad we share this enthusiasm for it. Because this whole issue is about the technology lifecycle, and in particular, in Java SE, the lifecycle of APIs. And so this is Java's 20th anniversary year, and over the past 20 years, many, 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 many things have been added to the platform, but very few things have been removed. Now, it doesn't necessarily follow that for everything you add, you have to remove something, but you might think that after 20 years, there's some things that are older, obsolete, no longer relevant, no longer necessary, and so forth. And at a certain point, you might think that those things would be taken out of the platform or retired. And so that's what deprecation is all about. So deprecation, as a matter of fact, was a concept that was introduced very early in the JDK's history, all the way back in JDK 1.1. A bunch of things were deprecated, but actually there was very little follow-through. So it just sort of sat there, and that has been a problem. So my claim is that if you have a platform that does not have a life cycle where new things come in and old things are removed, that platform is in an unhealthy state. So you can trust me on that. I'm a doctor. So I'm going to be taking questions on Twitter. I think the attendees are small enough. We can probably have a conversation at some point if there's time at the end. But if you have questions after the fact, you can tweet on this hashtag Java deprecation. And I believe this is streaming to the internet as well, so remote people can also ask questions on Twitter. All right, so let's talk about a little bit of history first. So I ran a few statistics, and this is just kind of background about the statistics. Consider the number of features in a library. So this is really just for ease of statistics gathering. It's the number of classes and the number of members in each of those classes. And if you total up all of those features in the standardized parts of Java SE, that is the Java, JavaX, and org namespaces that are part of Java SE, and you count all those up, what numbers do you get? And so here on this table, I have a bunch of numbers for the history of all the JDK releases. And so it's pretty amazing. In 1.0, which was introduced nearly 20 years ago at this point, there were about 2,200 features. And in Java 8, released last year, there were nearly 52,000 features in the sense of classes, methods, fields, and so forth. And so that's enormous. Now, if you look at the number of things that have been deprecated in each of those releases, there was nothing that was deprecated in the first release, because deprecation didn't actually exist in the first release. Deprecation was introduced in 1.1, and a whole bunch of things were deprecated. And over time, handfuls of stuff were deprecated. And so if you put those on a graph, the comparison is basically the number of things deprecated is insignificant to the growth of the entire platform. So I think they were a little overdue for deprecating some things. All right, I mentioned that deprecation as a concept was introduced in Java SE JDK 1.1 in 1996. This was only 1 year after 1.0 was introduced. And so the people who worked on 1.1 realized at that time that they were introducing new things, and so there was a need to eventually pull things out, or at least mark things as, okay, these are old things, you should shift to the new things. So basically, the designers there, actually, I'm trying not to get too far ahead of myself, but there's pressure even then, there was pressure on the system to evolve not only by adding new things, but also by taking things away. And so the mechanism that was introduced in 1.1 was JavaDoc tag. So at the time, JavaDoc was mostly, well, fairly well full-featured, but basically it was a tag markup language in source code comments that was used for generating documentation. And so a new tag, @deprecated with a lowercase d, was introduced in JavaDoc. And so that produced some changes to the documentation to let people who read the documentation know that particular class, method, or field, or whatever was deprecated. Now, later on in Java 5, there was a new mechanism added to the programming language, which was annotations. And at that time, the @deprecated annotation with a capital D was added to the language, added to the class libraries. And so essentially, though, that means the same thing as the deprecated JavaDoc tag. So the deprecated, there are two things here. There's a JavaDoc tag, and then there's the annotation. And they basically mean the same thing. And in fact, it doesn't make any sense to have one present on a class or method without the other. And so in fact, the compiler will issue a warning if one is present but not the other. So they basically mean the same thing, but they're actually kind of different constructs. One is for documentation purposes, and the other is annotations are for source code level tooling, and actually program tooling. All right, so we've been talking about deprecation a lot. What's the definition of deprecation? You can actually find this definition in the Java language specification. In this particular section, it basically says, okay, there's this annotation, @deprecated. Warnings are issued unless, and then there are a few rules about, well, if warnings are issued when something that is deprecated is used, unless, and then there's some particular rules about, whether the use is within the same top-level class, or if there's suppress warnings, or so forth. But that doesn't actually say very much about what deprecation is. So let's look at the in the API definition for the @deprecated annotation, and there's a link to it there. And so here we have a hint at something. It says a program element annotated @deprecated is one that programmers are discouraged from using. Okay, so that's pretty important, typically because it is dangerous. I'm not sure that's true, but sometimes things actually are dangerous. I can talk about that more later, because that is an important concept. Or because a better alternative exists. Okay, so there's some things there going on. Compilers warn when a deprecated program element is used, etc. Okay, so we're starting to edge towards a little bit of the concept about what deprecation actually is. All right, so if you look through the documentation further, you can find in the JavaDoc generated output, there's a list of deprecated APIs. There's a link to the Java 8 one. But basically, this is just a list. It's just a raw listing of everything in the system that's been deprecated. But it doesn't say anything about, well, it doesn't say very much about deprecation itself. If you look in the JavaDoc, the documentation for the JavaDoc tool itself, there's a description of @deprecated, the JavaDoc tag, as opposed to the annotation. Sorry, I have to keep having to be specific about that because they are two separate things. But the documentation for the JavaDoc tool tells how to use this tag, but it doesn't really say when you should use it and what to do it or anything about API lifecycle. Now, linked from the JavaDoc tool page, way down in there, in fact, I didn't know this was there for a long time. You have to search for it pretty hard. There's a document called How and When to Deprecate APIs. And it has some vague definitions about what deprecation is, but it basically says, oh, if you want to deprecate something, use the @deprecated JavaDoc tag. So really, to get the best information about what the original intent of deprecation was, you have to go find a document that no longer appears in the JDK. This is really terrible. I guess it itself was deprecated or something. Although I think, I'm not actually sure why it got dropped. I think it had some text that was specific to JDK 1.1, but this document is called @deprecated mechanical help for abandoning old APIs. And it was authored by John Rose. And some of you may be familiar with John Rose. He's a JVM architect, and he's still active working on Java and JVMs today. But anyway, so he wrote this document, which was added to JDK 1.1, and it described, as near as we can tell, the original intent of what deprecation was supposed to be about. And so you can find this document by going to the Oracle download site, and you have to go to the Java archive, and in one of the old documentation bundles, you can unpack it, and you can actually find this document. So it still is available, but it's some important history here. And so what I've done is I've pulled out some key quotes from it. So one is, and so again, this was written from the perspective of JDK 1.1 in 1996. It says, Java 1.1 introduces many new APIs, some of which supersede older ones. Okay, that's a very important concept. Introduce the new thing, so what happens to the old thing? So the old thing is now superseded, so something needs to happen to it. Okay, valid reasons for wishing one's users to migrate. Okay, actually I should call that out there. There's this notion of migration. The old API is insecure, buggy, or inefficient. The API is going away. Well, that's sort of circular. You're saying, well, we introduced the new API because the old API is going away. Okay, and the old API encourages bad coding practices. So here is, at last, a little bit more concrete information about what's going on. But there's this idea of things being superseded, things being dangerous, things being encouraging bad coding practices, and so forth. I say, note the words abandon and supersede here, but also migrate is a very important one. So what I'm going to do is reformulate this notion of deprecation, which is basically deprecation is how we as the authors of the platform notify our developers that we would like them to migrate the code away from using deprecated APIs. And I think the main thing is away from. In many cases, there are new APIs to migrate to, but sometimes old APIs simply don't make any sense anymore. And so mainly the issue here is migrating away from these APIs that there is something about them that causes us to want developers to migrate away. So I have some details later on about what those somethings are. All right, now, so let me shift a little bit and talk about what happens when an API is deprecated. So basically, it's this idea of notifying developers. So there are a few things. The compiler will issue warnings, as was mentioned in the Java language specification. The compiler will issue warnings when deprecated APIs are used. IDEs will also issue warnings or give little squiggly lines under code that, or present code differently if it is deprecated. And the JavaDoc output, in fact, this was the original effect of deprecation, was that the JavaDoc output is modified when the @deprecated tag is added to an API. All right, so here's what happens. I have a class here, which I'm not even showing the source code, but it basically calls a deprecated method, I think thread.destroy. And the compiler says, note, myclass.java user overrides a deprecated API. Now you have to recompile it with additional flags in order to figure out what the error actually is. So if you recompile with -xlint deprecation, that enables a new class of warnings, and it says, aha, warning deprecation, destroy in thread has been deprecated, and it echoes the line there. It's simply thread.destroy. So there we have a clear message from the compiler. This line is the point of use of the deprecated API. All right, now, so a little bit of details about exactly when the compiler issues a warning, and these were the ones that were listed in the JLS earlier on. It seems maybe a little too detailed. On the other hand, people are actually people who do work with deprecating things are often surprised by these, so that's why I wanted to cover it here. But there are some fairly subtle rules about when a deprecation warning is actually issued. So here I have a class deprecation test, and it has a nested class A, which is annotated as deprecated. Okay. Now, inside class A, it uses class A. Okay, so no warning is issued there, because presumably if you're working inside a class that's deprecated, it's useless to have warnings about, you know, a class needs to use itself. And that's unavoidable. So no warning is issued in that case. Now here's a different one. So in nested class B, which is a peer to class A, there's no warning of the use of class A here either. And that's because of this rule in the language specification that no warnings are issued if the use of a deprecated API is within the same top-level class. And so that's interesting. The language specification does not talk about compilation units. It talks about the top-level class, because it is absolutely clear that things within the top-level class must be compiled at the same time. You cannot compile different pieces that are inside the same top-level class separately from each other. So the assumption is if it's within the same top-level class, well, they're closely related, and you know you're using something else in the same top-level class. So these are closely coupled. So it's pointless to issue deprecation warnings for things that you're closely coupled with, even though you're not actually implementing something that's deprecated, but they're closely coupled enough. Yeah, sure, question here.
Is there a story of deprecation inside packages? Like you can mark the package as being deprecated. Anything inside it will not issue warnings?
Well, actually, two things. So the question was about deprecation of packages, and actually the deprecation story on packages is not very strong. I think it is syntactically possible to deprecate a package, but nothing actually happens. Now later on, I'll talk about, well, actually on the next slide, there's a mechanism to suppress deprecation warnings, but that doesn't apply to packages either. But there are no warnings for deprecated packages anyway. So, okay, so here's a different case. So I have a different top-level class, class C, and so that uses deprecation test.a, which is a class nested inside there. That's the one that's deprecated. There, the warning is issued because that's in a different top-level class. But here, class D, it's a similar situation, but I've put the suppress warnings deprecation on there. And that causes the warning from the compiler to be suppressed. All right, now let's talk about what IDEs do. So here I have a snippet of code in NetBeans, as it turns out, but I believe the other IDEs are similar. So in NetBeans, deprecated APIs are displayed in strike-through. You can see their thread.destroy, and there's a nice strike-through font there. And then there's also, and this is something I enabled, if you go into the options and enable warnings, you get this little, you get the little light bulb with the warning triangle in the left margin, and the pop-up for that is basically the same text as the compiler emitted. Thread.destroy has been deprecated. But that's kind of nice because, of course, with the IDEs, you know, as soon as you type something like that, you can see it right away. And then this is what the JavaDoc output looks like for something that has been deprecated. You can see the deprecated annotation there, and then there's an extra paragraph that has a deprecated heading and some text, some descriptive text about why it's been deprecated and what to do differently is listed there. That's basically just something that the developer has to type in JavaDoc. The only thing that's auto-generated is the deprecated heading. But all the rest is just free-form text that is formatted into the output. Okay, so after all that, let's get back to the fundamental, which is the API lifecycle. So at a certain point, you introduce a new API, and it becomes actively used by applications or consumers. And as the API evolves, as the system evolves, new APIs are introduced, and old APIs are deprecated. And so, like I said before, deprecation is notifying developers to migrate away from the old API, and perhaps in this example, onto the new API. So deprecators all dutifully go ahead and migrate their code, and then the old API is removed. All right, now what actually happens? Okay, so we go through this stuff. Deprecation notifies developers via warnings documentation. Well, what happens is everybody just ignores that. Okay? And so, well, ideally, developers would migrate their code from the old to the new, but nobody's doing any code migration. And you know, ideally, again, at some point, it would be safe to remove the old API. But the fact is that virtually no APIs have ever been removed from the JDK. But, and this is a forward-looking statement, in JDK 9, a very small number of APIs might actually be removed, probably for the will be removed. Oh, that's a forward-looking statement. That's our system architect there, Mark Reinhold. He says they will be removed, so I guess that's definitive. But don't make any stock trades based on that information. Okay, so it'd be a little easy to say, you know, you developers, you haven't been migrating your code and stuff, but you know, this is on us, right? Because the real world ain't so simple. Just, you know, marking something deprecated and then having everybody migrate and stuff like sheep or something. You know, there are people out there, they have real applications, they have lots of code, there's maintenance costs. So there's a lot of things out there that make things a lot more difficult in the real world than ideally. And so we have to face up to that. But the other part is, on the JDK side, we have not really followed through on this. This is what I mentioned earlier on in the talk. In 1.1, the deprecation mechanism was introduced, and in Java 5, it was enhanced with this annotation. But basically, a bunch of things got deprecated and nothing. So basically, we haven't driven the API lifecycle, and so, you know, not much is happening. And part of the problem is that this has caused a lot of confusion, I think, in the developer base. People don't really know what deprecation means. People don't know what the developers of the JDK, that is us, Oracle, intend to mean when we deprecate something. And so that's our job to make that clear. In fact, this is why I'm doing this. One of the problems is if you, it's like leading by example. If something is deprecated, then the idea is that applications migrate away from using that. But the JDK has a lot of deprecated stuff, and it still uses a lot of its own deprecated stuff. So the JDK itself has not led by example and migrated away from its own deprecations. So why should anybody else? And, you know, fair point, right? So, you know, we have to understand that. So really what's happened is over the past, what is it, 18 years since deprecation was introduced, basically it's been confusing. And so when, you know, I've started to talk to people a lot about deprecation, and you know, I basically get gut reactions from people about what deprecation is and what the responses are. And in fact, it falls, you know, there are a bunch of different reactions, but some is, oh, if you deprecate something, that might be removed at a moment's notice, so you can't use that. So some people take it really seriously. And then other people are saying, they've never removed anything, why bother? I just ignore it. And it's like, you know, I can't blame anybody for having any of those reactions. And in fact, based on our track record, we can't say that either of those is right or wrong. And so that's what we're here to fix. Now, I keep flipping back and forth between deprecating things and removing things, and they're not the same. But there's a lot of discussion about when things are removed. But it actually is very difficult to remove things from the JDK. And the reason is that removal represents the ultimate incompatibility. It's binary incompatible, source incompatible, and behaviorally incompatible. And worst, the failure modes for those incompatibilities are they're not very forgiving. So if you compile something and it uses an API that's been removed, it basically says, you know, cannot find symbol or something like that. Well, what happened to it? Well, you go look in the documentation and there's nothing there because it's been removed. So how do you fix this code, right? So you do a web search and you find out some answer on Stack Overflow or something like that, right? I mean, that's what you have to do, right? So I think, you know, simply removing stuff, certainly removing stuff summarily is very, very unfriendly, and so it makes it difficult for people to migrate their code, especially after the fact. It's binary incompatible. I think you get very unfriendly linkage errors when this happens, and so you have to do a bunch of debugging, and again, you have to do the research to figure out what you need to change if you encounter one of these. And then, so there's a documentation thing. It's all well and good to say, okay, this is deprecated, and so some warning messages appear in documentation or whatever. And then if it's removed, what happens after that? Does it just vanish into a puff of smoke? Or, so there's something missing there. There needs to be more documentation about stuff that has been removed and what to do about it, because that needs to be persistent, because people are going to be migrating their code over the long term. So there's definitely more we need to do here. So continuing on the theme of notifying developers, the notice we're giving to developers through today's deprecation mechanism is insufficient. So one of the things is we have this nice mechanism. We have the deprecated annotation, compiler warnings, IDEs, and so forth. But this is essentially only at compile time. So and one of the big features of the Java platform is that it's binary compatible from release to release. So we tell people, you don't have to recompile your code. But if you don't recompile your code, you never see any deprecation warnings. So that's a problem. So if you have an old binary that uses deprecated APIs, how do you find out about that? So we have to do something about that. Yeah, question.
I mean, you will eventually recompile some of your code. I mean, deprecation is not like next week or next month it's going to blow up. Not see, like having to recompile to see it is not. I don't see it as being a big issue there.
Yeah. Okay. Well, it's comment on code gets recompiled eventually, and I suppose that's true, but it's there's some heads shaking further back, right? So I think everybody's different. I think there are people out there who have these old binaries, and they expect them to continue to work unless there's some compelling reason for them to recompile them. So, and I think that's part of our story. If you're recompiling regularly, great. Maybe that makes sense for you, but that might not make sense for other developers. So, all right. So I'm a doctor. So one of the things I can do is write prescriptions. So here's what we're working on at the moment. The first thing is to work harder on the concepts about deprecation. So I did this fairly thorough research about in the past about what deprecation was, but there wasn't that much that was specific about it. There were some interesting concepts in there like migration and abandoning APIs and APIs being superseded, but those are just kind of hints. There's very little specific, and also it's fairly difficult for somebody to look at that and decide how to take action in response to that. So we need to work harder on some fundamental concepts. Another point is, as things stand, deprecation warnings are issued only at compile time, and so we need to move that. We need to figure out how to do something at runtime as well. There are also potential for doing static analysis on whatever container, like a jar or module you might have. Those are amenable to doing static analysis, and it would be quite useful to be able to say, I have this jar here. Does it use any deprecated APIs? Or specifically, does it use any APIs that are deprecated in this release of the JDK? There's also some things, we can tune up the documentation a little more. There are, the deprecation, such as it is satisfactory. If you happen to know that thread.destroy is deprecated, you can go find out why it's deprecated and what to do about it. But if you don't happen to know to look at thread.destroy, you'll never see it. And if you look at the list of deprecated things, like if the new release comes out and you look at the list and say, do I use any of these? And there's this big long list with hundreds of elements, and it's like, I don't know, right? So I think we can do better at organizing the documentation to deal with deprecation better. Yes, question here.
It would be also nice to know when it was deprecated in which version.
Yes. Question is, or the comment is, it would be nice to know when it was deprecated. And absolutely right. Yes, we have a solution for that. Okay, so and then there are more things to do, and so in the Java platform group, we don't control the IDEs, but we talk to those guys regularly, and it would be nice to have them tune up their behavior a little bit to deal more effectively with deprecated APIs. All right, so here is the sketch of a proposal for how to enhance the deprecated annotation. So the first thing is to add an enum, which is a reason. And so we have some specific reasons here, which I will define on the next slide. But importantly, there may be one or more reasons listed for deprecation. So that's a first few bits of information about why something is deprecated and the consequences of continuing to use it. And then there are, it's an annotation, and I'm not going to go into too many details about the annotation mechanism, but it's kind of like fields in a data class, even though they're actually methods. So the reason is one method, or is one value in an annotation. Another one is a link to a replacement API, or actually potentially multiple links. So it's a common case to say, all right, there is this API, it is deprecated. What's its replacement? Well, if there were some kind of hyperlink to elsewhere in the documentation, or some well-defined name for a different method in a different API that, say, the documentation could use or IDEs could use so that you could jump directly to it, that would be useful to have right in there. And then, as the gentleman over here noted, it would be nice to know when something was deprecated. And in fact, we're considering adding some additional information about that. It's kind of in the same namespace as the javadoc @since tag that tells when something was added. And so when something becomes deprecated, well, let's use the value of the JDK release at which it became deprecated. Okay, so let's talk about some reasons here. So unfortunately, there are many, many, many things out there. The first thing here is unspecified. So there are many, many things out there that just say @deprecated, and so we have to provide kind of a fallback default for when somebody just says deprecated. And so it's unspecified, so there's no reason given. But what we want to do is go through the JDK and actually upgrade all of the existing deprecated APIs to use one of these other reason codes that is specified. So, so other reasons are, it's not necessarily reason, this is actually a disposition, but another code here to put in the reason is condemned. And this is condemned in the sense of a building that is marked to be torn down. And this is a very specific thing that says this API will be removed in a future release. And so to contrast that with things, I mean, today there's this confusion about, well, will the deprecated things actually be removed, or will they be, just sit there and just people told not to use them anymore? So here the idea is we will mark something condemned if we are certain that we are going to remove it in a future release. So that's a clear indication that this is going to go away. And contrast that to other things that might be deprecated that are not condemned. And there are other reasons for deprecating something, but not actually taking it out of the platform. So that's a clear distinction there. So another reason here I've listed is dangerous. There are the typical examples that you may have heard about, like thread.suspend, resume, and stop. There's a big essay. Those were deprecated very early on. And in fact, it might be that deprecation was introduced specifically for those methods. It is effectively not possible to write a safe program using those constructs. But there are other things too, like I have an example later on of something that deals with string processing, but it fails to deal with Unicode properly. And so you might think, that's not really dangerous. But I would argue that in fact it is, because it depends on your input having certain characteristics. And so if you feed Unicode data to one of these things, you will silently get the wrong result. And so if you think hard about correctness and if you care about correctness, getting the wrong result with no warning or error is a very serious problem. So I would consider that dangerous. So it's not only things that might crash or deadlock, but getting the wrong result silently is something that I'm very concerned about. Obsolete and superseded are a couple other reasons. I don't know if we need to make a distinction here, but this is might or might not be necessary. But well, actually, I describe obsolete as retired. Maybe it should be retired. But the point here is that there are some things in the system that you don't actually need to use at all anymore. Therefore, there's no replacement. So just take that out of your code. On the other hand, there's a fairly typical case, but by no means always true, that introducing a new API will replace an old API, or really a new API supersedes an old API. I think this is fairly common, and so we would expect to see a lot of things that are superseded, and this would also have a link to its replacement. So what I expect to see is there's an old API in there, it's marked as superseded with a link to the new API, and so if you see that in the declaration, then that's a signal for you or your IDE to do some migration to use the new thing instead of the old thing. There are a few things sitting around that are actually unimplemented. Actually, I have examples of all of these later on, so I'm not going to go into too much detail. But in fact, there are methods there, and you can link to them, and you can reflect on them and so forth. But if you call them, they do nothing, or they throw an exception. So if you use one of those in your code, it's probably not doing what you think it's going to do. So it's probably worthwhile getting a warning there, and also bringing to bear these new tools we hope will be developed to let you weed out code like that. Question?
Like an enum set? Because I can think of several APIs that have at least 3 of these characters.
Yes. Okay. So the question is this an enum set? Actually, well, so close. It's an array of enums. So you can specify one or more of these reasons. Thank you. That's a question over here. Oh. Right. Yeah, so that's what I mentioned earlier. So condemned is kind of different. It's more of a disposition. And I guess the question is, is it worth having a separate field with a separate type to have this, or, I don't know. But actually, I think that is conceptually true. It is somewhat different from these others. Yeah, question here.
For superseded, would it be useful sometimes to provide a link to another one, like a strongly typed, perhaps, method or other class? If the signature matches, the IDE would provide automatic refactoring for that.
Yeah, so the question is, for superseded, would it be good to have a link to a method that an IDE could use for refactoring? Yeah, so I think there's potential there. I think that's on the right track. I think that's what we do want to enable. One of the difficulties is the annotation mechanism does not allow you to actually reference a method directly. I think strings are the only useful type here, and so basically you would have to come up with a way to link to another method, say in another class, using a string, and then the IDE would have to interpret that in a particular way. But I think that's definitely on point, which is if you have a superseded API, it names its replacement, and we want to enable automated refactoring to let people migrate their code. That's exactly what we're after here. So, question over here. Yeah. Okay. Yeah, so the comment was about having a separate disposition, because there are effectively two. There are at least two. There's ones where we intend to remove it and ones where we don't, and maybe there's some in between, and I think that's a matter of I think conceptually that's true, and if we were to have a full-blown object modeling about this, yeah, it would be separate and so forth, but I'm a little concerned about making things too complicated as well. So, but thank you for the feedback. Question in the back.
Yeah, so in addition to condemn, it might also be interesting if you gave some hints as to when. Condemn for removal from JDK1.
Okay.
I mean, obviously you don't know that for a fact. You can hint whether or not it's likely to be the next release or further out.
Okay. All right, so the question was, or the comment was, in addition to condemned, have some indication of when in a future release it is likely to be actually removed. And I wish, I wish you could say something more useful about this. But remember that safe harbor slide that all the Oracle people have to put up? So it's one thing to have a disclaimer around a talk at a conference. It's another thing to have a disclaimer around something that actually gets compiled into the source code. But practically speaking, I mean, it kind of makes sense, but you know, I don't know whether it makes sense to say, oh, okay, I'm going to condemn this method, and it's going to be removed in JDK 11, but not JDK 10, right? And so, and then when JDK 11 rolls around, it's like, you know, actually removing it is a bad idea, so maybe we won't after all. So it's not clear. There's a whole bunch of future stuff in there. I mean, it's a nice idea to be able to schedule things like that, but in practice, it seems to be very difficult to do that. Actually, I'd like to move on here a little bit, and then I think we'll have some more time at the end. So, but thank you. Oh, quick question. Okay, so is this going to be in 9? Well, we hope so. Yeah. But you know, it's all a matter of under development. Okay, and the last thing here. Okay, so unimplemented I talked about. Last thing here is experimental, and so you might think, well, experimental. That's sort of the beginning of the API lifecycle, not the end. Why does that belong here? But experimental is actually kind of a different statement. But the lifecycle of an experimental API is very short, so it might be introduced and then removed and replaced with the real thing very quickly, or maybe not replaced at all. But the point is, at the time at which it's introduced, it is quite likely to be removed soon. And so it's not quite the same as condemned, but really it indicates that this has a short life cycle. And so it's a caution to, it's a different piece of information, and it's a caution to say, well, don't form any dependencies on this that are critical, because it is potentially likely to go away. And one of the things we need to work on is when it is actually possible to go away. Currently, we do make very sparing incompatible changes, but only in major JDK releases. But if there are experimental APIs, you might also think that either minor or update releases might make incompatible changes to experimental APIs. So there's kind of something different going on there as well. We haven't decided the exact timing of things. But you know, if something really is experimental, maybe it's subject to change at any time. So anyway. All right. So here I wanted to talk about some of the way that they interact. In particular, I think the main issue here is the distinction between dangerous and condemned. And so, for instance, it's clear that thread.suspend, or thread.stop, I think is a good example. The thread.stop with no argument. That is potentially dangerous. And the reason is that it causes the target thread to throw a thread exception in the middle of no matter what it's doing. And so if it's in the middle of updating a data structure, that data structure could unavoidably be left in an inconsistent state. And there's no way for the program to deal with that possibility. So that's why I would consider it dangerous. But it doesn't necessarily follow that, well, since it's dangerous, obviously we don't want dangerous things in our platform. It doesn't necessarily follow that it should be removed. And in fact, there are some use cases of thread.stop. Some customers, if there's some container, they load some jar in, they have some runaway thread, they might want to say, you know, yeah, it's not safe, but we need to try to get our system under control so that we can do recovery. So we want to use thread.stop. And so that's why I think these are separate. It's not necessarily for me to say, you should never use thread.stop because it's dangerous, therefore we're going to take it away from you. I think if somebody is using thread.stop, they should full well know the risks and then make the assessment of the risks themselves. So there's a distinction to be drawn here. So there are some things that are condemned because we want to take them out of the platform. And there's some things that are dangerous, but those are not the same thing. Sometimes something's dangerous, we do want to take it out of the platform. But sometimes it's dangerous, use this at your own risk. And at least that's the way I think about it. I think condemned, just one more thing to say on that, is that historically just having something deprecated is not sufficient notice to say this is going to be taken out, because the fact is some subset of the deprecated things we want to take out, but some other subset of the deprecated things we don't intend to take out. So condemned is the clear marker that marks that intent. All right, so here's an example of how we would update the deprecation annotation on a particular method. This one is the one I was talking about before. This is string.getBytes. And so what it does is basically it takes low order bytes of char values, and it totally botches Unicode. And so anyway, so the proposal is to say, okay, this is dangerous because using it may involve data loss. If you can guarantee that your input is only ASCII, okay. But what happens if your input isn't ASCII? Okay, well, if you're willing to take that risk, you can go ahead and call it. We don't necessarily want to cause a major incompatibility and force you to rewrite your code if you're using ASCII and you have no possibility of using anything other than ASCII. This works just fine. Okay, so it's dangerous, but it's also superseded because I didn't put a link here. Okay, well. There's some other method on string that gets bytes out of a string in a Unicode safe way. I'm sorry, I just forgot to add that. Oh no, sorry, there is a replacement there. Yeah, it's called replacement. String get bytes with no argument. That's the one that does the proper Unicode handling. And so you can see here, value is the annotation kind of field name and that's what we're using for reason. And here it's an array of dangerous and superseded. And this was deprecated in JDK 1.1, so that's the since value there. Okay, more examples. All right, so superseded, there are a lot of things in the JDK that are floating around, like our old friends vector, hashtable, dictionary, enumeration, observer. Anybody use observer and observable? Remember those things? No. Okay, deprecated dangerous, I talked about the thread methods. Unimplemented condemned. So thread.destroy actually, I forget which exception it throws. Not the obvious one, but I think it unconditionally throws an exception. And then thread.stop with a throwable unconditionally throws some different exception. But basically, they do nothing. And so at a certain point, we might say, they're sitting there, they're just junking up the API. Right now, they are unimplemented, so if you compile code that uses them, you should get a warning because they don't work. And in the future, we will remove them. So that's what this, I don't know if we've actually made that decision yet, but that's my proposal for how to mark these. Now, and then there's some other things where, early on, when deprecation was introduced, there were a bunch of things that were deprecated. And in retrospect, they probably shouldn't have been. And so the example here is AWT component show and hide. And so, well, if you've ever programmed in AWT, there's early on, well, basically you'd show and hide a component. And this was replaced with set visible Boolean. And so it's like, oh, our preferred coding style is instead of saying show, say set visible true. Unfortunately, everybody out there had written component subclasses that overrode show and hide already. So it's like, okay, well, we actually can never, take them out. And furthermore, we have to continue calling show and hide because that's actually part of the subclass or interface. So, all right, if they're never going to go away and there's no reason not to call them, there's no reason to migrate away, maybe they should be undeprecated. Okay, so now I wanted to talk a little bit about providing deprecation warnings at runtime. So all the stuff so far has been deprecation warnings at compile time. But there's a use case, which is the old binary. Now suppose in some release of the JDK, you compile your application and it compiles, you turn on all the warnings and it compiles completely cleanly. Okay, so now you have a working binary that does not use any deprecated interfaces from, from the current JDK. Well, so we come out with new releases of the JDK periodically, and over time, more things become deprecated. But if you don't recompile that binary, you'll never know about that. So the idea here is, okay, we need a way to say, taking the old binary and running it on the new system, the JVM can tell when you use an API that happens to be deprecated. I mean, in principle, it can. I mean, it needs to be implemented. But right now, there's no such mechanism. So you can, we can deprecate a bunch of stuff, and we can condemn some stuff, and then eventually we take it out. And so when you're migrating your binary forward, all of a sudden, the API just disappears. Well, that's no good. So we want to say, if you're migrating forward and you're using something that's deprecated, let's figure out how to get you some warnings at runtime. So the things we're thinking about are add some JVM command line options that enable some kind of deprecation warning at runtime, and then have some hook in the system class loader or some JVM agent or something like that monitor class loads or method calls and issue warnings when there's usage of deprecated API. And so you might think, well, gee, there's going to be a performance hit on that, and probably. So this is definitely only going to be something that you opt into. If you run it normally in production, no warnings and no slowdown. That's the goal here. And there's another thing. There's another thing here too, which is that there are some things at the library level that are also sort of deprecated. So if you're familiar with the libraries, in one of the previous JDK releases, I think it was JDK 7, there was a change to the sorting algorithm. And that was sensitive to the way people wrote their comparators. And a system property was added to say, OK, if you have problems with the new sorting algorithm, you can restore the old sorting algorithm. And that was by setting a property called JavaUtil arrays use legacy merge sort. OK? And then even there's that's documented somewhere way off to the side, and it says this will eventually be removed. And so I don't think it's officially deprecated because there's no API on which to hang a deprecated annotation. So that's kind of a problem. And so having, blah, 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 this is deprecated in some release note somewhere is not going to be able to tell people whether this actually impacts their code. So the idea of the runtime warning is not only does it enable JVM to issue warnings, but it also sets some flag that the library code can check as well to say, oh, yeah, this guy is using the legacy merge sort, checks that flag, and then the library itself issues a warning to say that this is going on. And this is something that our libraries don't do very often, is issue warnings. So that's kind of a new thing, but I think we need to work on that because there are these weird features in the corner of the library that we want to have evolve with the same life cycle as the APIs, and so we need to be thinking about this. And then one interesting bit of trivia here I wanted to throw in is that the annotation mechanism has what's called a retention value, which is whether it's retained in the class file or whether it's actually retained all the way through runtime. And interestingly enough, the deprecated annotation already has runtime retention. So today you can load a class and go in with reflective code and find out the things that are annotated with deprecated. Okay, a little bit of stuff on static checking here. But basically, in the migration to Jigsaw, there's this tool called JDEPS that will analyze static dependencies and try to flush out things like dependencies on internal APIs. It's easy to see some similar kind of tool will check dependencies against deprecated APIs as well. So that's an alternative. Instead of actually having to run your binary and make sure that you have enough test data to exercise your program, do some static analysis over the binary and see what static dependencies it has. There's not really much to say about documentation, just some ideas for how to organize things more effectively to present deprecated methods. I think the main thing is JavaDoc now has several tags that will group the various members of a class. So you see here all methods, static methods, instance, concrete, and deprecated methods. So this is great. You can go look specifically at the deprecated methods. But what would be nice is to have something that contains only the non-deprecated methods. And there's this question about whether that should be all or some other tab. But the problem is having all the deprecated methods in there displayed by default kind of clutters up the documentation and makes things more complicated than they need to be. But also, well, you know, it'd just be nice to say this is the currently supported API. And then, of course, if you really want to look at the deprecated stuff, you should be able to look at that in the documentation, but just not necessarily display it by default. I think I want to move through this. Thank you. All right, some potential IDE enhancements. We did talk a little bit previously about some kind of automated refactoring tools that would be supported by IDEs. I think that's a fine concept, but the warning here is that there are some very, very subtle things going on that make this a little harder. Because the IDEs, you know, it depends on the developer, the IDE, but they can be very sensitive about breaking your code. So for instance, you might say, okay, let's deprecate vector and stop using vector and have an automated refactoring that replaces it with a call to array list. Okay. So if you're iterating over a vector, you use vector.elements to get an enumeration. So let's replace that with a call to ArrayList.iterator, or even a for each loop, or even a stream, and do that. Well, the problem is those actually have different semantics. One, a vector is thread safe, and an array list is not. So you know, that might not be a problem, but it might be, and IDEs generally don't like to break your code. Another issue is that if you use an old enumeration to enumerate the elements of a vector, that does not have the same fail-fast properties that the standard collections framework does. Interestingly, if you get an iterator over a vector, it is fail-fast. If you modify the vector during an iteration using an iterator, that will throw concurrent modification exception. But enumerating the elements of a vector and modifying the vector while you're enumerating it, it has some behavior. It is not fail-fast, but your program actually might be depending on its specific behavior. So if you refactor that away to do something else, that'll probably break your code. So I think the notion of having an IDE do automated refactoring for this stuff is a fine one. I certainly want to pursue it, but it actually seems really hard. So I'm not sure. I mean, it's something that we are going to explore. All right. So let me recap quickly. This is all about API evolution and migration. So we want to be able to tell people more effectively how to migrate their code and bring in more tools, runtime analysis, static analysis, in addition to compile time warnings to do that. There's a lot of confusion historically about deprecation. So what we're trying to do is refine the definition of that and make things more clear so that people can say, aha, I understand what's going on with this API, and I can make decisions about how to change my code, or that I don't need to change my code, or maybe I don't need to change my code right now. And I think that's what developers need to know. A question I get asked regularly is, when are you guys going to remove all those deprecated APIs? And my answer is, the doctor's preferred tool is a scalpel, not an axe. So we're not going to get rid of them all. We are very carefully going to mark a few of them as condemned and remove them, but that's not going to be true of, certainly not all the deprecated APIs. And I'm happy to announce that just today, a new JEP number 277 on enhanced deprecation has just been posted, and you can go look at this there. You can go look at that link there. That basically is the development that is currently underway that we are trying to work on for JDK 9. So it includes the enhancements to the deprecation annotation, the enumeration of reasons, and things like working on tooling and runtime warnings. And so I'm happy to continue this conversation. I am Dr. Deprecator on Twitter, so go on to Twitter and say hi. Thank you. Yeah, question.
Do you want to enhance suppress warning also with, say, I want to suppress the deprecation of superseded, but I don't want to suppress dangerous?
Yeah, so the question was about enhancing suppress warnings to deal with the finer grained reasons. And I think since suppress warnings is at a particular use site, it's not clear to me that's necessary, but I think something is necessary in there, right? So because right now the compiler warnings flag says turn on all deprecation warnings or not. And so maybe you might want to have a compiler flag that says turn on condemned warnings only or something like that. So there's definitely some things like that that we need to think about. Yeah, question here.
How do you feel about the opposite of deprecation, like marking a specific API as being stable or being core or something?
Okay. So the question is about what's the opposite of deprecation? Should we mark something that's stable or core or whatever? And I think the answer is anything that is not deprecated is stable. That's a presumption in the JDK. So if we have something that appears in the Java SE specification, that is, the underlying assumption there is that is stable, that is something that has long-term support, and we intend to remain compatible with. So I think that really we don't want to. I think we want to mark the things that are specifically in some danger of not being in that category.
Well, for JDK maybe, but for some libraries that's
Yeah.
hard to live. Like
Okay.
like, I'm not too sure about the specifics, but this is the core foundation of my library, like
Okay.
event manager or something.
Okay. So the question was about other libraries that have kind of different policies from the JDK, and I think that's an interesting one. I hadn't thought about that, so maybe that would take further discussion. So we're out of time here. So yeah. Okay. All right. Thank you.
All right, doors closing. So I guess that's my signal. Hello and welcome. Thanks for coming that late on a Wednesday. I'm in a way competing with Elton John, right? Don't get to say that every day. So thanks for coming to the session. I'm pretty sure you will like this. This is typically a very popular topic. I'm talking about Java performance today, and I'll try to do it on a very basic level without looking at machine code or without looking at bytecode. And not because I don't think that you wouldn't get it, but the simple thing is that you have to spend some time to get used to these concepts, and actually they're not important if we talk about performance. What I'm trying to do today here is that I'll look through some concepts that are important, that are very crucial for the hotspot Java virtual machine when the Java virtual machine runs your programs. And hopefully you will learn how you can apply some rules to your daily working to help the JVM to optimize your code. Because ideally the Java virtual machine would be this magical box where you can put in any source code or bytecode rather, and then out comes super performant code, super performant machine code, and no matter what you do, it will run very fast. And that's unfortunately not true because it's impossible to implement, right? So it often helps to write code in a certain way to help the JVM to let you help you, right? I have a disclaimer slide here that everything I say today might not be true in the future at least, right? So of course I do my best, you can always be wrong. But what we talk about today is, first of all, it's only true for the hotspot virtual machine. That's what is running in the Oracle JDK and in the Open JDK, right? And I think most of you work with hotspot. But there are many, many Java virtual machines. There are, for example, the Delvik virtual machine is a very different virtual machine for Java, and it has different performance metrics. So unfortunately, it's very difficult to write a program that's both optimized for Java, or like default Java, and for Android, right? And also these things change. We talk about implementation details today. That's something that isn't specified anywhere. There's no, the Java virtual machine specification doesn't say you have to optimize code in a certain way, right? You can do whatever you want. You can write your own virtual machine and make it do whatever you want as long as it obeys certain rules, but performance is not a criteria here. So please keep that in mind, because if you go on Stack Overflow, for example, and you ask is reflection slow? That's like one of the typical urban myth that is still around, right? Reflection is not slow. That spoiler to the rest of the rest of the session. But it was slow many, many years ago. Java 1.3, Java 1.4, they didn't have the heavyweights that the Java virtual machine has today, right? So please keep that in mind for the future life. Okay, so what we want to look at first is how a Java program is run. And you probably know that already, but just to be all on the same page, let's just quickly walk through it, right? So we all write, for example, Java or any other JVM language, and then we have a compiler, in this case Java-C, which translates source code to so-called Java bytecode. And if you came to my session on Monday, you heard a bit about bytecode. And the thing with bytecode is that it is fairly similar to the Java code. The Java-C compiler that you all use for compiling your Java program is not an optimizing compiler. It does close to no optimization, right? And the thing is that it doesn't need to. The Java virtual machine is a way more powerful compiler where this bytecode is later either interpreted or at some point it is translated into from bytecode is interpreted to machine code. And even after the translation to machine code, we still have a step of optimization because modern processors, they have their own optimization layers, right? A processor is, for example, reading prefetching memory, right? If you in your Java program read a field, for example, what you do is you read data from somewhere in your memory. The processor might be smart enough to figure out that at some point needs this information and might just load it already in some cache, right? So we have two layers of optimization, the JVM itself, the just-in-time compiler, and the processor, which is doing some optimizations. And developers don't like to look into these layers because it quickly gets a bit complex and complicated, and it's also difficult to obtain this sort of information. It's not really exposed to us. We can look at source code, we can even look at bytecode, but already obtaining machine code from a JVM for the programs that we write is rather difficult compared to other things, right? And today I want to break through this layer with you and look into the JVM layer and the processor layer, right? Also, one thing I should mention is like Scala, for example. If you compile Scala code, the Scala compiler might have to do certain optimizations. They might have to do certain performance optimizations because the JVM, as I mentioned before, isn't this magical box where you can put in anything. The JVM itself recognizes certain patterns and makes use of them, and it's capable of transforming them in a more efficient manner if they resemble the output of the Java compiler, such as what Scala not necessarily resembles to. Tail optimization, tail call optimizations is an example. The JVM doesn't support resolving recursive loops, right? This is a very functional concept, so you have to basically translate this because the JVM doesn't know how to do it, so it's the responsibility of the Scala compiler to do that, right? Okay, so once again, this is Hotspot. How does Hotspot run your code? When you start a program, the JVM has three ways of running it. It starts out with an interpreted mode, and then it has two different compilers. These compilers were formerly known as the client and the server compiler. And you could actually specify which compiler you would want to use by a parameter, which was -client, -server. Modern JVMs don't do that anymore. Modern JVMs, since Java 8, I think it's default, use so-called tiered compilation. So both compilers are used at the same time. So the JVM, in a way, looks at your code and decides if it wants to step through your program or if it wants to translate your program into machine code, right? And most programs start out to run in interpreted mode. And the thing about Hotspot is it's a method-based compilation. Dalvik, for example, on Android, is not compiling methods as one piece of code. It's compiling loops in a way. So it's not important. I'm not going to talk about Android much, despite I have mentioned it twice already. But as I said before, this is Hotspot. Right? So we start out in interpreted mode. And interpreted mode is so-called level 0. That's if you look at compilation logs and you read level 0, that means interpretation. So the C1 compiler has three different modes. It has level 1, 2, and 3. And the Hotspot virtual machine is doing compilation at runtime because it uses profiling. And profiling means that the Hotspot virtual machine looks at your code. It looks how it looks like when it when it is actually run, and then based on the experience of running your code for a while, it will basically get to know your code in a way, right? How it's actually behaving, and then it will optimize based on that information. And it's a very powerful concept. If you write a program in C, for example, then you compile it statically. You compile it once and only once, and then you have translated it. And this basically doesn't allow certain optimizations. The C compiler, when it translates something, has to be absolutely sure that this one rule that it applies, this one optimization, doesn't ruin your program in a way. The hotspot virtual machine is able to wait until runtime and look what's actually happening and then judge based on that information. And as a matter of fact, C1 is collecting this information. And it then later gives it to level 4, the C2 compiler, which uses the created profiles to do optimizations based on that. So what this implies is that C1 on level 2 and 3 collects information that might make your code slower than when it, for example, runs on level 1. And that's what makes it really difficult to talk about performance when you observe a program, because normally you don't know what mode your code is currently running in, right? So, but how does this look in practice? Let's say you start a program, public static void main, right? And you enter, what will happen? You will often, you will always start out at level 0. Let's say we walked a bit through the call stack of your program already, we arrived at some method. And this method is used a lot. And that's why hotspot, the virtual machine, is called hotspot. It determines what are the hot areas in your code. And hot in this case means it's run a lot. And then it will, after a while of interpretation, start to profile this hot code. It will say, okay, this seems important, so I have to make sure this is run fast. And then it will be handed over normally. In the typical case, it will move from level 0 to level 3, where the JVM collect some information about your code, like what kind of classes do objects have. Like if you have a parameter of type object, it will look, okay, what actual arguments are assigned to this parameter, right? And then after a while, based on this information, it will compile it to level 4. And then basically your code is as fast as possible. C2 compilation is, however, an expensive operation. So for a virtual machine, it is always important to make a trade-off between how much time do I spend running code and how much time do I spend optimizing code? Because once the JVM is basically trying to analyze what you're doing, what your program is doing, this is time and energy that it cannot spend on actually executing the instructions of your program, right? And that's why some optimizations aren't performed by the JVM. Every optimization comes with a cost, with an overhead. So you have to make a trade-off. And that's what the just-in-time compilation people at Oracle are basically doing for their living. They consider what is a typical Java program, what does a typical programmer do. And if you do strange things in your code, then someone might have said, okay, we could optimize that, but we won't, because normally that's not happening, right? That's the first rule. Apply common sense. Basically, if you want to write performant programs, write good programs, and yeah, you'll see later what good means in practice. But it's a good first rule. It's basically the best. I mean, it's a lame tip, right? Write good programs, and then they will be fast. But in a way, it's true, right? Since C2 compilation is so expensive, it might, however, happen that if there's a huge queue of optimizations, that the virtual machine decides to only go to level 2. Because level 3, where profiling information is collected, collecting information also causes an overhead, right? So you might just go to a mode where you can collect a minimal amount of information until the C2 compiler has capacities again. And then you move over to level 3 and then to level 4. This might just happen because your processor is busy or your C2 compiler is busy. Or, what also a typical case, let's think of a trivial method, a getter, right? What does a getter do? It reads a field and returns it. This is a no-brainer, right? That's not much to optimize here. What happens here, it goes to level 3, it says, okay, this is trivial. I won't even compile this. I won't spend the energy in C2. I'll just drop back to C1. And this is the typical patterns that you see in a compilation log. Compiling to level 3, compiling to level 4, or the other ones, right? Okay. So much for the theory. That's basically the general framework of what hotspot does, right? But let's look at something more practical. And this is the central building block of hotspot, of the JVM and how it optimizes code. And the concept is called a call site, and you might have heard of call sites, right? So what's a call site? Well, this is a call site. For example, every time in your program where you call a method, in performance speak, this is called a call site, or not only performance speak. The closer you are to the VM, you often refer to this as call sites rather than calling a method, right? It's probably more exact. And what you all know about Java is that all non-private methods and non-static methods are dispatched virtually, right? So when we call bar here on an object foo, we don't know if we actually observe the class foo up there, if we actually observe an instance of foo, or if we observe a subclass, right? And many languages have therefore chosen to make methods non-virtual by default. If you wrote C++ code, or if you wrote, I think C# also has non-virtual methods by default, they decided to not make methods virtual by default. And the reason for that is not that it's a bad feature necessarily. It's always good to have the possibility at least to override methods if you need to, but this is slow. And why is that slow? It's because you have at runtime or at compile time, you have to determine first what method you will call when you reach a call site. Can you just print hello, like in foo bar, or is the method overwritten? So we have an indirection, and indirections are bad because every time we reach a call site, we have to determine what class is responsible for dispatching the method. And it might not sound like much, and it won't be much, but look at a Java program. What is it assembled from? It's basically method calls. In an object-oriented language, that's what a program consists of, right? So if something happens as often as a method call, calling a method better be as fast as just possible, right? However, this is actually not such a big problem, especially not in Java, which is single inheritance. And single inheritance actually has implications of how you can implement a runtime for a language. In this case, we have so-called virtual method tables to dispatch, and all like non-C++, which is multiple inheritance, also has virtual method tables, but they look a bit different. So internally, the JVM keeps track of a table where it basically enlists all methods by an index. In this case, we have, to look at my screen, bar at index 8. And what we then have is a machine address where we reference the code to this method. And there we will just point to this println instruction, right? So if we go to a call site and we observe a class foo, which is actually an instance of this class, a direct instance, then the JVM just goes to this class's virtual method table, goes to index 8, and calls the code there. So this is 3 indirections. Checking out what class has an instance as a call site, go to the method table, and go to the address of the method in question, right? 3 indirections. That's a lot for something that happens as often as a method call. A good thing about single inheritance is that if we have a subclass of foo, then we will find the bar reference again at index 8. So at least the JVM can point to a certain index in a table, so we save us some extra trouble. If every method would be dispatched that way, if we would always go to a virtual method table for every method, Java would be a very slow language. And in the earlier days, Java was a rather slow language because the just-in-time compilation, I think they added hotspot only in version 1.3, right? And it improved a lot ever since. So how can we improve this? And this is not what the JVM does, but this would be a way. We could get rid of one optimization, one indirection by just maintaining a cache of classes, right? You could just say, okay, the class foo has a certain address for this method bar, right? And Smalltalk, for example, was implemented that way. Smalltalk kept inline caches at every call site. The problem is that these caches are pretty big, first of all, in a way, and consume a lot of memory. The second problem is that we still have 2 indirections. So this is not something that is very feasible for hotspot. Because this is you still have to check the instance of a class and then check the cache for this instance. And if we don't miss the cache, right, then we have to do virtual method lookup. But in case that we always hit the cache, then we can just walk directly to the method implementation. So what we rather want to have, and this is something that is very crucial to performant Java programs, is a call site that is, one says, monomorphic or linked. A monomorphic call site means that there's only one possible class that is ever observed at a certain call site. So all instances for val will always be of class foo, right? Only foo and nothing else ever. And what the JVM then does is it says, okay, we just go to the call site, to this system out println directly, right? We have basically what the JVM does, it adds a guarding instruction that makes sure, okay, this is really foo, and then we jump to the system out println thing. And this is something a C program cannot do. The JVM makes speculative optimizations. The JVM looks into your program and just says, okay, let's just pretend we don't have a virtual method here. Let's just pretend that we can dispatch this as it was a static method call. This will never be overridden. And only if this assumption is never true, then we have to have like an assert, and then we fall out and do something else. The JVM can do that, basically say, okay, what I tried to do didn't work out, but if this works out most of the time, and it does work out most of the time, then I win a lot of time for not having to dispatch methods virtually, right? So, and this is also profile-based information, right? When we run in C1, we can collect information about what object we actually observe within this foo method here, or the do something method here, I mean. And we can see, okay, is this really always the same class that we observe here, or do we have a lot of polymorphism here? And based on that information from the profile, we can run C2 compilation where we can then put this assert in. All right, so what is there? The JVM knows monomorphic or so-called link call sites. And as a matter of fact, in a general Java program, about 90% of all call sites are monomorphic. Think about getter methods, for example, or setters, or most methods that you write, right? You have classes that are never subclassed. The JVM will just consider these classes as non-virtual after a while, and it will just apply this monomorphism that we just saw. There won't be a virtual method dispatch. It would be as if we had a C# program or a C++ program where we always correctly said, okay, this method is non-virtual, right? This is the same result in the end. However, for example, specifically for data structures like sets or lists, we sometimes have bimorphic call sites. And bimorphic call sites means that we have a call, like let's say we call size on a list object, and then sometimes it's an array list and sometimes it's a linked list. And then we have a similar optimization. And what we don't want to have is so-called megamorphic call sites. And this is basically the first way of avoiding slow programs is to avoid megamorphic call sites where the JVM actually has to do the virtual method table lookup that I showed you before. But since the JVM is an adaptive model, a call site might be in different states throughout the life of the application. So what will happen is that once we start out a program, we probably have to look up the target of a method. And then when we go to the JVM node, the JVM gets confident enough that the method is actually monomorphic, we just collapse the call site into being a directly inlined method call. However, if this assumption doesn't hold anymore, we just fall back, we de-optimize the program to do a virtual method lookup again. This is constantly happening. Your Java program is constantly moving. It might be that you have a long-running application that has been online for a month, and then you change a configuration property where different code gets triggered, right? And then the JVM will learn, okay, something has changed. All of my assertions that I put into the application suddenly fail all of the time. And then it will de-optimize your program, but after a while it will optimize it again. And most of the time it's okay, but for some people it's not. If you're, for example, a trading system and you have to be really fast because otherwise you're losing a lot of money, then you don't want to have a de-optimization happening while you're in the heat of the market, right? So some people have adapted, they fire fake data at the application at certain times just to trigger a certain de-optimization and re-optimization of the JVM, right? But again, this is why when you write your own benchmarks, for example, and you look at how code behaves, you never know what's happening, right, in your benchmark. Maybe the JVM is learning about your program while you're running a benchmark and might start optimizing, which takes a lot of time. And you think that something is slow that is actually very fast. So this is something that is important to know about JVM. Or not only about hotspot, actually, this is basically any Java virtual machine that uses just-in-time compilation. Okay, we've seen this before. Why is this? It doesn't sound so important, but monomorphism is referred to as the Uber optimization of the Java virtual machine. And not only monomorphism, it's so-called inlining that is important. The thing is that inlining is almost always only applied for monomorphic call sites. If this assertion holds, we can optimize the program further. We can just copy the system out println into the do something method. And now we can just run this as if we had copied the code there ourselves. So we don't have to do it. We can just write nicely object-oriented programs, and the JVM does the optimization work for us. Since we could prove that we will always end up calling system out println hello anyways, why not just copy this information to where we otherwise would have called the method? And this often gives a lot of space for doing other optimizations. Once you have a lot of code in a method, you have a lot of stuff to think about. And as I said, the hotspot regards a method as the compilation unit. It treats as a main point. If you can copy a lot of code in one method, you can do further optimizations. And that's the easiest to understand, actually. Oh no, I have something else before. So now we have, this is the first really practical advice. So we have learned that monomorphism is important. And what you should learn from this is that you should not introduce types into your program when these types are not really used for modeling actual complexity or actual behavior. Let's say you have a list call site and you call list size, right, on this call site here, size being the call site. And let's say normally you either have an array list or a linked list. Then this is bimorphic, right? Bimorphism still means that the JVM does a lot of optimizations compared to a megamorphic call site. But now, not you, of course, but a colleague of yours puts in this array list here. And this is a fancy style of initializing a list, right? And you shouldn't use it because it creates an anonymous class which carries a reference to its outer class, which might cause a memory leak. But in this case, the worst part is that if the list size call site now observes this array list subclass here, we have a third type. And the JVM will fall out from bimorphism to megamorphism. And that forbids more way to trigger certain optimizations that we have seen before, right? So this isn't a real type, right? But the JVM will regard it as a type because it said, okay, normally people don't do these things, so we don't have to take into consideration that people just create a lot of anonymous types without using them. Also, if you refactor a program to represent the same things as fewer types, but in a better delegation model, for example, this might cause your program to trigger certain optimizations, because fewer types means more inlining, more monomorphism, right? So avoid types at all costs, actually, and that might sound strange, but if the problem with polymorphism is that if you actually use it, it might forbid certain optimization. And if it's necessary, then there's complexity that you have to model, right? So then it's okay. But if this complexity is only there because you haven't written like clean and clear code, then you pay for it by performance losses, right? So let's look at another practical example. Let's look at this. Yeah. Yes, please. Yeah.
We hardly use linked lists. So we use array lists most of the time when we're dealing with a database. So should we not write code as list string equal to a list? Should we write array list because JavaOne, like, based most code?
No. First of all, we're talking about very small performance gains here, right? You should write a good program. It probably pays off more to write a good program than it pays off to do these sort of micro-optimizations. It's just what I'm trying to teach you here is that this has implications for performance. You should model, if you really need a linked list, the linked list might have so much better performance implications for a certain use case that this pays off, right? And compared to losing the monomorphism. And actually another thing, it's just stay with me for this example, and then I'll refer back to what you just said, right? Let's look at this log method, right? This log method is very generic, and log methods are normally very generic because they run random arguments, right? And if with the knowledge that we just gained, this is a terrible method, right? We have an array of arguments, and then we iterate over them and call toString on every argument. And probably we will observe a lot of different types here, right? Within this loop, by design already. And toString here will be super megamorphic, right? This will be a blocker in our application. So let's say we call log from somewhere, right? The log method call here itself, it's a static method call. Static call is always monomorphic. A static method call will always arrive at some target. It's never virtual, right? And we just learned that for non-virtual methods, we can inline code. So what happens is that this will be inlined, probably, right? What we now also have is that we know the arguments in advance. We know the 3 arguments that will always ever appear at toString here. What the JVM does for small loops is so-called loop unrolling. So it will replace the loop with a copy of the method body, like this. And what we have created now is that we have reduced this megamorphic call site into 3 monomorphic call sites. So the JVM will be able to do further optimizations by basically specializing each system out println for a certain type, right? And that's very handy, because of course we could otherwise argue if we have very critical code, like an algorithm that runs for hours, then this is something we should otherwise do ourselves. But since we wrote our code in a way that the JVM is able to perform these optimizations, we're lucky, and this gets there for free after a while. Think, however, about what would happen if the log method would not have been monomorphic, if you had some weird logging logic where the actual logging code is very nested somewhere, and the JVM cannot figure out how to copy this code into your actual do something method. This optimization won't happen. And that's why monomorphism is so important. If you have a monomorphic list, there's very little code entailed, right? But if you have a monomorphic algorithm that is like a huge piece of runtime code, then not being able to do optimizations by merging this algorithm with the actual data might have a very severe impact. However, if it's a very small, if it's a very small segment of code that is behind your inlining, then it's not that bad most of the times, right? And also, what will happen, maybe if you use a linked list instead of an array list, maybe in these cases you call your algorithm from a different method, right? And then this might be copied into the algorithm and basically create a new call site only for the linked list, right? So in a way, if you structure your code properly, then most of the time everything goes well. All right. So I have these performance rules, and I try to ridicule it a bit, because these advices, like, right, you would go out now and say, like, this guy told me to never use linked lists. That's not what I'm trying to tell you. Take these performance advices very relatively. You write good code, and only if you ever have a problem, you think about the performance implications. Or if you have to argue with a colleague while certain things should be done in a certain manner, then it's good to know about these things. But never actively think about performance while writing code. So of course, one type is good and many types is bad, right? This is true in a way, right? But it doesn't mean that you should put all your code into static methods and not write object-oriented programs, right? That's important. Okay, and this is something I'm a strong advocate for static typing. I've always been one. I never was a big fan of writing huge business applications in dynamic languages, and here's why. It's a lot about performance again. And what I'm quickly want to do, I know this is JavaOne and we talk about Java, I want to look at a JavaScript program and V8, the engine that's running Chrome and that's running Node.js, right? So how does Node.js optimize code? Can it use the approach that we just explained? Can it use monomorphism and these concepts? It cannot, because there aren't types. But that's the only way to optimize programs. So what V8 actually does is that it introduces types to your JavaScript code. So let's say you have this object foo, which doesn't have a type, and you add 2 properties to it. Node.js will then create a type. The star is basically the type of the empty object. And Node.js, or V8 rather, knows an inheritance model. If you define x first, it will define a type x that inherits from star. And then with y, it will introduce a type xy that inherits from x and star. And this is in a way a subclassing hierarchy. So if you have bar, another object which is exactly identical, it has 2 properties, y and x, but this time we define them in a different order. We will get a different type. We will get a type star again for the empty object, but now we will get y inheriting from star and yx inheriting from y. And the V8 won't be able to basically connect these two types together and do basically a monomorphism optimization for observing these two different objects. And in a way, computers are strictly typed, right? You shift bits and bytes on the hardware, and then people like to refer to this as mechanical sympathy, right? You should think you write software that's run by computers. Computers can just do so much. And if you write a JavaScript program, the only way that the JavaScript program will be performant is by basically being very strict about the shapes of your objects, which are in a form types, right? So even if you don't write typed programs, you will have to have structure in these programs, right? If a program doesn't have structure, it's difficult to optimize. And that's true that's why I'm telling the story, right? Structure, predictability is good. Computers can work with that, and JVMs as well, right? So you want to avoid a mess, and explicit typing is a good way of doing that. All right, so what we could do now, and this is basically just another side of the same coin, we could argue that if polymorphism is bad, we just do branching. And branching is a word for if-else, right? So we can just say if that is true, instance of, call, instance of, and we have created two call sites, right? However, branching is another form of unpredictability, and the JVM has also measures to improve that, and also the processes especially. So let's just quickly look at this program. What we're doing here is we create an array with 20,000 elements and with a random value between 0 and 99. Okay, this is what this program does. And then we 1,000 times iterate over all these values and calculate the sum of it, but not the actual sum, but we will add the number if the number is bigger than 50, and we will subtract it if it's lower than 50. And you might wonder, how can you optimize this program? And there's a surprising answer to that. Because one problem that we have here is that this is inconditional. The JVM is basically forced to do a different thing based on a random value. And since the values are truly random here, chances are 50-50 to either do a plus, like add something, or subtract something. And simply the same thing as with polymorphism, if the JVM doesn't know what's happening, it cannot do certain optimizations, and that's a problem here. So in order to, and the processor cannot predict stuff either. So in order to improve the performance of this program, we can sort the array. And despite us doing additional work, this program will run faster. And the idea is that if we know that the array is sorted, we will probably just jump to the sum, like to adding a number for the first 500 values on average, and then we will jump to subtracting a number for the next 500 values. And since we basically, the JVM will be able then to figure out, okay, we do now for 500 values, we add the numbers, so we can just basically start adding without the conditional, right? And then it will at some point say, okay, this is not longer true, this condition bigger than 50 is not longer true, I have to fall back to subtracting. And then we can also fast track this operation, right? So as with polymorphism, for branching, so if else, it's just the same thing. Be predictive. If you can reduce the complexity of your domain to an extent that the JVM can figure out for most of the time how branching works, you will be able to gain a lot of performance here, right? Okay, so in a way, prediction is good. If the JVM can figure out what you're going to do, it has a lot of stuff to look forward to. And it can say, okay, this is going to happen, so I'm going to crunch all this to a smaller operation, which is resulting in the same thing. If the JVM cannot say more than 10 steps ahead what's happening, there's very little to go through, right? The JVM will not be able to tell what's going to happen in the next future, and it doesn't have any information about your program that it can optimize. And that's very important, that's very crucial. If you actually, like if you have an algorithm, right? And your algorithm is alternating all of the time between two different states, the JVM will have a problem. Rather do one thing first and do it all the time, and then change to doing something else. That's, of course, again, a very abstract way of giving performance advice, but that's why people perceive performance as difficult. But this is basically the moral you can learn from this. Okay, let's look into a different optimization that the Java virtual machine does for you. You probably have heard already, this has been true for a long, long time, that object pooling is not a good idea. Object pooling means you keep objects around for as long as you can. And the thing about objects is that they are expensive. Objects have to be allocated on the so-called heap of the Java Virtual Machine's memory, and that is basically in away space. It requires synchronization to a certain extent because multiple threads can access the heap, so you should be careful with whenever you create an object. If you look at this example, you will see that there's an object created because this is more or less synthetic sugar for this instruction, right? We create an iterator and then we iterate as long as there's new elements and print out every element from the list, right? And we allocate an iterator and we want to avoid that ideally. So how can we do that? We could of course do the old form of iteration. We could just iterate over an index and avoid the allocation. However, escape analysis helps us to avoid this. If the JVM can determine that an object will not live very long, it can often say, okay, then I won't allocate it in the first place. And opposite to what was done in the old days of Java, where you would keep objects around for as long as you could in order to avoid an allocation, today you can try to keep them around as little as you can and have an even better benefit by not allocating the object at all. The JVM will in a way erase the iterator and just implement the same logic that it represents directly in the method. So it will rewrite your code to not have this iterator allocated at all. So you shouldn't worry about these small iterations. Keep scope small, and the JVM will honor that by deleting objects that you don't actually treat as an object. At some point, we will get value types in Java, and then hopefully this heap allocation problem is reduced heavily again, but it already today is reduced to a certain extent by escape analysis. All right? Okay. So the stack is good, object allocation is bad. That's a general advice. Again, don't take it too seriously. Don't write programs that never allocate objects. In the end, the JVM hopefully can optimize your code anyways. Okay. Let's look at another concept. Let's look at dead code elimination. Dead code elimination is often a very big catch in benchmarks. And what we do here is we have written a benchmark. We want to measure how long it takes to add 20,000 random values. So what do you think will happen here? Well, the JVM will look at this code here and say like, okay, wow, we're iterating 20,000 times over an object and we're computing a sum. But then it says, okay, but we're never going to use this sum, so I cannot execute this. I can just throw this away. So what your benchmark is doing now, it basically measures how long it takes to call current time millis 2 times. And there's another mistake in this program, so this code will also be deleted. So there's another problem in this code, and that is that current time milliseconds is synchronized with the time of your system, but it is not constantly synchronized, it is only synchronized that and that many clock cycles. So what can happen is that you call current time millis for the first time, and then the operating system tells the JVM, you're out of sync with your time, and it will reset the time to a smaller value, and this system out println will actually print out took -1 milliseconds, right? Or even bigger numbers. So in most cases, we'll just print 0 milliseconds because there's a certain granularity. So you shouldn't use current milliseconds anyways. But the main part is that your code isn't actually run. And that's all, again, a very powerful optimization. Let's say we have a method that doesn't do anything. And what the JVM will do at some point, it will just say, okay, I'm never going to call this method again, right? I'm just going to remove this piece of the code. There is, however, a better way to writing benchmarks. You shouldn't write your own benchmarks, but let's look at this example where we fix this. And if you have looked at benchmark code, this is what you will see, right? You have, in this example, what we first do is we do a so-called warm-up. And I've shown you profile-based optimization before. What we basically do is that we ensure that the JVM has learned as much as possible about a program. So we iterate about our actual benchmark code, which is now contained in its own method. And by doing that, we give the JVM an opportunity to learn as much as it can. Then also we use nanotime. Nanotime doesn't have a big advantage, but in a real application. But nanotime isn't synchronized with the operating system. So if you compute differences of time, nanotime is always better. And then also what we do is that we print out the result of our computation, because that way we basically force the JVM to actually compute the sum. Without doing that, the JVM could just, again, discard our code completely, but it can't say, okay, you're not actually reading the console, right? This is a benchmark, so you don't ever look at your console, I won't print it. That's nothing that the JVM can legally do. And then we print the time. So what we basically do is we have a warm-up, and then after 10,000 times, we can be rather certain for Hotspot that all optimizations were triggered, and then we can actually print the results. So this time we have written a benchmark that we can actually use, and this is how people write benchmarks, more or less. Most benchmarks look like something like this. There's, however, a better way. There's a framework called JMH, Java Micro Benchmarking Harness. JMH is a part of the Open JDK, and it is basically a canonical way of implementing benchmarks. So what JMH does all the hard work for you. You basically have a setup method where you initialize your code so that you are ready to run the benchmark. And then you run the benchmark, you implement it just in one method, and JMH will take care for you that no optimizations outside of this method is triggered. So for example, you return the sum, and then JMH figures out for you how this value is escaped in a way such that code elimination is not applied. And it's a really, really good framework. I use it for all of my open source projects. If I have crucial code where I care about performance, it is a really easy way compared to what you had to do manually in order to ensure that the way you implement things are the ideal way to solving a problem, right? Okay. So one problem about measuring performance is that if you run a micro benchmark, and people like to do that because they like to prove that one way of doing things is the fastest way. If you run a micro benchmark and you have two operations and you benchmark them both, you cannot tell that both operations chained together will actually take the time of the sum of these two benchmarks together. Because if you run code together, the JVM can, for example, in the worst case, you're doing two heavy operations twice, right? If you do the second time, the JVM, if you run it in a row, can then tell, okay, this is the same thing, I just reused the results from before. So you cannot really tell from a micro benchmark if something is fast or slow in a certain context. You have to be really careful what you're measuring, right? In the worst case, it can even be slower to run two things after another if you have created a certain profile. Because as I said before, you have profile-based optimization, where a profile is built and certain optimizations is triggered. And since de-optimization takes time as well, if you have to de-optimize first before running your second piece of code, this will cost you, right? Okay, so again, harnesses are good, self-made code is bad, right? Simple rules. One last thing that you should know about, in my opinion, every Java developer should know about are intrinsics. If you look into the implementation of Java long integer, there's a method called bit count. And bit count basically counts all the 1 bits of a number. So this is how bit count is implemented in the OpenJDK, right? However, there's an instruction, a machine code instruction called pop count that is available on Intel, I think. So what the JVM does is that it knows certain methods, and these methods are called intrinsic. If you copy this code into your own method, this bit count method, it will be slower than when you call integer bit count, for the simple fact that the JVM knows this method and automatically reduces it to a certain processor instruction, right? So it is important that if you know certain methods, especially in the context of mathematics, the math class in Java is a very important class, because it is often mapped to certain ways of doing things on the processor level, on the hardware level, right? So this is another thing. And you can actually, if you go into Hotspot, the source code of Hotspot, there's a class called vmsymbols.hpp, where all the intrinsics of Hotspot are listed. So if you write algorithms, mathematical algorithms especially, find out what your intrinsics are and apply them, right, as much as you can. Yeah. Okay, something that the JVM doesn't do for you, and I hope it's trivial, but people misunderstand it, unfortunately, regularly. This is a sorting algorithm, right? But it's not a very good one. What this sorting algorithm does is it sorts or shuffles values as long as they're not sorted. Eventually, they will be sorted if the shuffling is truly random, but it will take a while. The JVM doesn't optimize algorithms for you. Algorithms and what you asked before, data structures are your concern. If you, for example, collect a lot of items in a list and you probably will never iterate over them, for example, to collect debugging information or something, it is often better to use a linked list. Array lists are almost always the right choice, but sometimes linked lists have much better performance implications. It's not often something related to memory layout for linked lists and array lists, but you should choose your data structures correctly. Data structures are algorithms as well. This is something that the JVM cannot do for you, right? And always keep that in mind. You have to still describe your program in the appropriate way, and that includes choosing the right collections, that includes choosing the right algorithms, right? Okay, so think about your programs. Analyze what you have to do, and don't just do random things. This will cost you a lot. Okay. I don't have that much time anymore, so I'll jump just quickly about exceptions. Exceptions are a terrible way to implement control flow. Don't emulate an if-else with an exception that you catch. The JVM regards exceptions as something that are rather rare. And this is there's a great blog post of Alexei Shipilev, who's a performance engineer at Oracle, where he analyzes or compares control flow by exceptions to actual control flow. So what's here on the y-axis is basically the average performance of an operation, and on the x-axis we have how common it is to throw an exception. And if you just look at, for example, the yellow line, which is just a dynamically created exception, if it only happens 10 to the power of -6 times, it is much faster than the black line, which is basically an explicit control flow with if-else. So if you use exceptions to do really, really rare events, then they are the right tool. But let's say you use an exception to indicate wrong password exception, right? So from this class, you can tell that the black line and the yellow line hits at 10 to the power of -3. So if your users, if 100 logins, you have only one wrong login, then already the exception is then slower than an explicit control flow. So really, exceptions are meant for rare cases. Okay, so exceptional control flow is a really bad idea, not only for aesthetic reasons and code readability, but also for performance reasons. Okay. Another thing we want to look into quickly, and then I'm almost through, is false sharing. False sharing is, again, something related to mechanical sympathy. Let's say you have an object that is shared. It's class shared here and has two fields, x and y. And you have two threads where one only works with x and the other one only works with y. And false sharing means that basically these two threads interfere with each other despite them not having a common value, right? That's why it's called false sharing. The thing is that on hardware, you don't read fields. You never read fields on hardware level, you read cache lines. And cache lines might have more than one value. They will always probably, most of the time, they will carry much more than one value. This simple example, we just have 5, 6 values in there, and let's say the other ones belong to other objects, but the 14 and the 7 should be x and y in this case, right? So if we have two processors, and one writes only to x and one only writes to y, then both processors will write to the same cache line, because they will both get this one cache line that contains both values. And one says, okay, this 14 becomes 24, and the second one says the 7 becomes 1. Then we have a contention. These two processes have to figure out how they change their cache lines and have to synchronize their information, despite that these two values don't have anything to do with each other. And this seems very artificial, but it's actually something that I see all of the time. What people like to do sometimes is that they write algorithms that use different threads. Then every thread, for example, has a value in an array. And arrays are always aligned in one row. So they most likely share a cache line. So if you have caches that write to different indices of the same array, this will often cause a lot of performance overhead. What you can do, however, is there's an annotation which is unfortunately internal. So with Java 9, it's not available anymore. But in Java 8, it's called contended, where you force the JVM to put every value on it that is annotated on its own cache line. The old way of doing that is, and you see that in a lot of like high performance libraries, you see that people add a lot of fields above the X and below the X. And that way you basically create a buffer where the cache line will be taken. But then you have, that's not communicating your intent, and you cannot be sure if that is then causing a value to end up on a single cache line for all fields, right? So that's a bad way. The contented annotation is much better, but don't be confused. If you look like an LMAX disruptor or something like that, you will see it there, right? Okay, and this is important, really important. If you look at how much it takes to read something from a cache line or to synchronize something again with main memory, which contention always causes in the end, then that's the times, right? If you need to read something from disk, like if you don't write cache-efficient code, where you basically have to exchange values with the main memory all the time, or at worst case with the file system. Let's say you have a swapping space, right? So you write memory to disk and read that memory again back from disk, where a process instruction can cost 1 nanosecond, and reading from disk 1 megabyte can cost the time that it takes to execute 20 million instructions. And this also is really an important getaway. I've rewritten algorithms for customers. Before, these algorithms were running for 10 to 12 hours. And then just by writing them cache efficiently, basically changing just a few bits, these 8 hours can be reduced sometimes to 1 minute. And it's not because the old algorithm was slow. The thing is, people like to think processors are super fast today. What people don't like to speak about is that these times, what it takes to get something from main memory to a cache, these times have improved by about 10% over the last 10 years, while processor speed has improved magnitudes, right? But if your processor never does anything because the caches aren't filled, then your programs will be slow, and that won't improve anytime soon. The reason that we have more and more cache layers is exactly that. It is because processors get faster, but the time it takes to transport information to a processor didn't improve much. So that's important.
So is it a trade-off between space and performance?
Pardon, what did you say?
Is it a trade-off between space and performance? If you don't use it as a cache layer, are you wasting?
Yeah, you're wasting space, right? That's the problem with contention. Otherwise, you could just say, okay, we put everything on a single cache line, right? I just take it that people are leaving for Elton John and not because that's boring. All right. Okay, we're almost through. I'll release you in 5 minutes. You know what that is, right? Well, now you don't, because I didn't before I Googled the relation either. That's Heisenberg's uncertainty principle. And what Heisenberg says is if you observe, I think, an electron, I'm not sure anymore, then once you can observe it, you can either tell how fast it is or where it is. And the same goes a bit for performance measuring. If you want to measure a program, then you often have to change the program in order to make it measurable. But by changing the program, you change the program that you were observing, so you're not observing the same program anymore. So don't be fooled by profilers, and they almost all lie to you. Profilers don't tell you the truth. So don't rely on heap dumps, even on, heap dumps maybe, but almost all information. Like, we all love to look at big graphs, but it's difficult to take data out, and often this data isn't even correct, right? So one example is that we instrument code in order to make it observable. However, I told you before that we optimize, the JVM optimizes code for us, and that might trigger the JVM to be in an inconsistent state sometimes. For example, a constructor is called after an object is allocated. So we have a short amount of time where the object is allocated and exists, but the constructor wasn't yet called. So if we instrument code, we might look this object up, but then it wouldn't be consistent. So we're never allowed to observe the object in its inconsistent state. And for that reason, the JVM has so-called save points. And save points are points where it is where it is safe, of course, to observe a Java program from the outside. And this is how instrumentation works in a way. And a typical approach for profilers is using JVM-TI, the native interface, where you can then basically extract some information about a program. But let's say we have a program that is either in state A or in state B, and we try to observe it. And if we have a sampling profiler, which then basically all 5 seconds tries to check into the program what's happening, it will probably observe this sort of thing. Sometimes it's in state A and sometimes it's in state B, right? However, if it is never safe to observe this program in state B, the JVM will simply never allow the profiler to take control when the program is in state A, right? So we will always only observe state A instead of state B. Does that mean that program is never in state B? Yeah, so I have to check, I can't really read from here. Does it mean that the program never is in state B? Of course not, but our profiler was never allowed to check. So that's why all the typical profilers lie to you, right? So better options, in my opinion, is the honest profiler. If you are really into performance, you should look at that program at some point in life, which doesn't use JVM-TI, but basically Unix interrupts. So it comes from the outside. It says to the JVM, no, now I want to have a look, no matter what. And since it's basically not changing the heap, it's okay to do that. But the JVM wouldn't know for general application that it is allowed to go into the program. Another great profile is mission control from Oracle, which basically reuses information that is available anyways by garbage collectors, by just-in-time compilers. So it has an unfair advantage over other profilers, right?
Quick comment on that before you move on. For flag recorder, I think you may need to set a flag above non-safe point.
Yeah.
Otherwise, you get exactly that.
Yeah, not true for all profiling information. Mission control does both.
Right, so you have to tell it. You may have to look that up.
Yeah, it's true. Yeah, I mean, of course, always walk through even these tools have the limitations, and it would.
It works fine with that setting.
Yeah. Yeah, no, you're absolutely right. I should mention that. The thing is, again, it can do that because the OpenJDK knows in a way that mission control won't ruin anything, right? So that's an important condition. But if you write a generic agent, the hotspot wouldn't know that the agent doesn't access fields and objects, right? Okay, so what you can also do, there's a great tool called JITWatch. It's a part of Adopt OpenJDK, which actually allows you to extract the machine code of a method, right? And that's not always helpful, but it's very interesting to see how some code is optimized and not optimized. If you have very crucial applications, that can give you really good insights. All right. Generally speaking, what I want you to take away today is that you should write good programs. You shouldn't care about performance too much, but it helps if you think about it, right? Okay, so with these words, thank you. That's me. You can find me on Twitter. You can find my open source project ByteBuddy, which was created using a lot of performance analysis. And Documents for J is another open source project that I wrote. Thank you for staying with me. Enjoy Elton John. See you tomorrow, maybe. I give another talk on the memory model tomorrow at 4 if you want to. Otherwise, I'll be around. I won't go to Elton John.